Once again, may I have check sound? Sound. Check. Check one. Once again, ladies and gentlemen, may I have your kind attention, please? At the back, we request you to please settle down. We are just about to begin the event. Thank you. Once again, we request everyone at the back, as Chairman NHAI is about to arrive, we request everyone to please settle down. And all our delegates who are outside, we request them to please join in inside. Thank you. Good morning, everyone. Ladies and gentlemen, a very good morning to all of you, to all our senior dignitaries, to our delegates and our officials. On the behalf of Cube Highways, I am delighted to welcome you to the Global Convention on Coal Central Plant Recycling that's organized by Cube Highways, Cube Tech, and Mine, which is an innovative center for Cube Highways. It's supported by IIT Madras and NHAI. It's also partnered by Word Gun Group, IOCL, OMS India, L&T, and Bitcoin. So first of all, I would like to thank for each one of you for making a part of this event by gracing the occasion with your presence. Today we gather to explore cutting-edge CCPR technology from strategic planning to seamless execution, addressing challenges, and fostering solutions for sustainable infrastructure development. This event is not just about sharing knowledge, it's about capacity building for a sustainable future. I'm also pleased to inform you that this convention is being streamed live on our website and LinkedIn page. You can share the QR codes available on your tables to share this link with anyone who may want to join the conversation virtually. To formally begin, may I invite Dr. Harikrishnan K. Reddy, Chairman of Cube Highways, to extend a warm welcome to our dignitaries with our bouquet presentation. First of all, with a huge round of applause, we would like to invite on stage Shri Santosh Kumar Yadav, Chairman of NHAI. Ladies and gentlemen, I request you all to please put your hands together. Thank you, sir, for gracing this occasion. I also invite Shri Sanjay Nirmalji, former Special Secretary MORTH. Very warm welcome to you, sir. Thank you so much, sir. Moving ahead. So as we begin, of course, we all know, as per our Hindu tradition and mythology, we will now commence the event with lighting of ceremonial lamp. Symbolizing knowledge, enlightenment, and prosperity, I humbly invite our esteemed dignitaries to the stage for this auspicious moment. Ladies and gentlemen, please join me in wishing for success of today's deliberations and collaborations as we light the lamp. Thank you so much to all our esteemed dignitaries for this ceremony. With this, I'm sure we all have heard of this very important shlok, Vaktatunda Mahakaya Surekoti Samaprabha Nirvighna Kurume Deva Sarvakareshu Sarvada. So with the blessings of Lord Ganesha, we begin this event. And once again, I thank you so much. This auspicious start sets the tone for an enlightening day ahead. So as we move ahead, it's my privilege to now invite Dr. Harikrishnan Reddy, Chairman of Cube Highways, to deliver the welcome address. Dr. Reddy's visionary leadership has been instrumental in transforming infrastructure development through innovative and sustainable technologies like CCPR. Now I would like to give a brief introduction about him, as he is the Chairman of Cube Highways Advisor, a leading entity in road operations and maintenance within the highways and infrastructure sector. With over 2 decades of professional experience, he is widely recognized for his expertise in traffic engineering and transportation planning. Playing a significant role in shaping India's transportation infrastructure, Dr. Reddy holds a PhD in transportation systems engineering from IIT Kanpur. He is also the founder of VR Technish, known as the Cube Highways Technologies, a consulting firm dedicated to delivering specialized solutions for the highway sector. His network analysis and operational efficiency, his technical expertise encompasses intersection design, signal management, capacity and service level analysis, and queue-length evaluation at signalized intersections. Dr. Reddy has developed a scientific methodology for origin-destined travel, demand matrix estimation from link volume counts and marginal trip totals. His pioneering work includes the application of fuzzy linear regression models for trip generation and route choice modeling in the face of uncertain information. Our visionary leader, Dr. Reddy, drives Cube Highway's commitment to sustainable O&M practices, operational excellence, and innovation across India's transportation system. Ladies and gentlemen, please welcome Dr. Reddy, Chairman of Cube Highways, to the podium. Please put your hands together.
Thank you. Distinguished guests on stage, Chairman Sir, NHAI. Is okay. Oh, thanks. Nirmal Saab, all the delegates who are attending this conference. So we come from a country which scores for good and bad things magnificently at the top. So we are the most populous country on earth. We have the second largest road network on earth. Given that scale, basically anything that we do, good, bad, will have a substantial impact on earth, right? So therefore, it's extremely important that, basically all the steps that we take, at least are oriented towards sustainability and, greening this earth. So today's convention, starting from basically the conceptualization to the implementation and the monitoring till date, our experiences on recycling of pavements. So we'll go through, I structured 5-6 slides to present the magnitude of this problem in front of us, and why this is very important, relevant, for us, and why we should take it very seriously and start implementing from today, if you have not already done as a day-to-day practice. It is not moving. Oh, okay. So it's not moving. So.
You can take a mic from here and then you can ready?
Yeah.
You can take a mic, stand over there, and then you can keep on seeing over there.
Yeah, that is not.
No issue. It's not moving.
So you can take this one.
Is this moving now? This light's not going back. Yeah, sure. Okay. No, it's not moving. Can you check?
टेक्नोलॉजी के लिए क्वालिटी एश्योरेंस बहुत जरूरी है.
Yeah. No, sir, it's not moving actually.
It's not moving.
Can you just? Yeah. It's not moving, no? नहीं back जाना है ना? हाँ, this is moving. Okay. So I thought of structuring this under 3 broad heads. Sorry for that disturbance. Sometimes it hits the floor. First and most fundamental question: are our pavements dying young? Unfortunately, the answer for this seems to be yes. So many roads that we have constructed, from my experience in the last 20 years, We have been designing, these roads to last for, anything between 10 to 20 years, and we talk about, perpetual pavements and everything. But what we see is, from second year, third year onwards, basically, we are sealing cracks, we are doing patchwork. So what do we do about, basically, these pavements, which are, distressing much ahead of, basically, the schedule? And given that, basically, why this recycle and therefore, basically, the cold recycling is relevant. And if you are doing, CCPR, what's the big deal about CCPR? The world has been doing this for years. So therefore, if you have done, what is the big thing or a great thing that we have done? Fortunately, unfortunately, the science and technology has been evolving for decades, but it always gives a new chance for India to, basically, reinvent the wheel. Even the dead material in India, seems to behave differently, because of, basically, various parameters. So we will quickly go through, what they are. So coming to, Ghaziabad Aligarh section where we have done this, CCPR, cold central plant recycling. So this project was completed from 2-lane to 4-lane in two parts, one in 2015 and one in 2016. The sellers came to us sometime in 2018 with some people who are there in this room. I was on a site visit. I do not want to explain what I've seen on that road, but the condition of the road was like this. So this was just about 2.5 or 3 years old pavement, completely distressed. If somebody would want to see what alligator cracks looks like, there cannot be any picture better than what we have on the left side. So therefore, full width, full length it is. And after the initial 4 or 5 minutes of the trip, I thought, so let me see if can I come across 100-meter section where there are no cracks. And at the end, we couldn't identify one section, basically, which did not have cracks. This was the condition of the road. In about 2-3 years, the whole road required, basically, we did a lot of investigations. We thought, we'll do some rehabilitation. But finally, the conclusion was we have to, reconstruct this whole thing. Sorry. So moving forward, this is another road. This was a second road, I guess, we acquired sometime in 2016, a section between Mahua and Bharatpur. Story was, very similar. Construction completed in 2009. By 2011, 2012, people were started patching. By 2014, everything was, kind of basically the way it is there on that. So this was our first, CCPR experiment was on this road as a trial we have done. This was in-place recycling, CIPR that we have done. Worked quite well, I should say. Another section, this was our first road. The story of this road is basically, this was before I joined Cube Highways. I was accompanying so many investors who wanted to buy. We traveled half the section and all those investors said we cannot live with this road, let's go back. So we used to go to Jaipur and by the time we come to Dausa, they said there's no way we can manage this road, let's go home, right? But finally Cube formed and we acquired this asset. We have done so many things. We have done an SMA. Recently, yesterday somebody was talking to me. The SMA that we have done on Delhi, Mumbai is completely basically is failing. So therefore, what do we do? Basically, given this scenario. So these are the broad questions. So we were looking at what are the broad buckets of parameters which are resulting in this distress, right? We all know, basically, and we discussed this in every meeting, the overloading of roads. So we tried to do something in 2008 by inserting clauses in our toll rules that will penalize the overloaded vehicles. Nothing much has changed. The most important, so these are wheel loads distribution. So we at Cube, we designed an AI-enabled camera for automatic traffic counting and classification, and it will give you exactly in half a meter strip how wheel loads are distributed, right? On a 4-lane road, we take a directional distribution. We take about 75% as the main lane, but you can see from wheel load distribution, it's almost 90% of the load is in one particular lane, right? So that's something basically probably resulting in in these accelerated failures. The climate is not with us. Last year or this year rather, basically the air temperature was more than 51 degrees centigrade in NCR, which means we are talking about maybe 75 or 80 pavement temperature. So all of this put together, whatever we do, I think basically there will be failures maybe, right? And of course, to compound all these problems, the way we design, the day we do QC, QA, also probably is not helping the cause. And therefore, the solution is basically, if a road fails, like, completely, two options that we have, like, you mill it and, throw it off, or like, basically, you reconstruct. This particular road, Ghaziabad Aligarh, I've demonstrated, like, basically the extent of failure that we had seen. Our team, along with IIT Chennai, we said, like, let's reconstruct this entire road with cold recycling. Today, like, basically across 4 sessions, we will take everyone through, like, basically from the design to execution, to quality control, quality assurance, to, like, basically, our findings, in terms of, like, what is our experience. We've already seen, I guess, 2 cycles, or maybe 2.5 weather cycles, 2.5 years of load. I should say, like, it's working excellent. The 2 cores here, I hope, like, everybody can see this. This is cold recycled cores, actually, like, I think all the, intellects, like, who have worked on, like, creating this, crust with cold recycling, starting with, like, basically a specially designed emulsions, everything, like, basically, I think they need, they deserve a big round of applause. I believe firmly that, basically, this will provide a sustainable solution to, like, addressing the pavements, like, whether they're failing young because of, like, all the factors that we discussed, or, like, basically when everything becomes all right, like, basically when they fail in fatigue, like, basically where they lived their life. I think those are, the broad, on CCPR. I think we will have, like, basically, whole day, like, we will have all these discussions. So before kind of concluding, like, the other thing that I would want to, mention to everyone is basically as part of, like, the 6th learning of this project, we had set a world record, so we were running against time because of land acquisition, because of, utilities. Then L&T came and, basically they came up with this idea, who were our contractors, like, we'll do 100 kilometers of surfacing in 100 hours. So we started that. It was a humongous exercise, and we completed, in fact, 112.5 lane kilometers in 100 hours. That was a world record, ensuring basically the quality. I guess the surface on which the people are sitting are probably the CCPR surface, and that's how it looks like. This is I should say, a successful experiment. As an industry leader, like, we thought, like, we should share our experiences, specifically with NHAI, specifically with ministry and in all the industry, so that, like, basically we take points from here and, and make this part of, like, basically our road maintenance, exercises, like, for future. Thanks a lot.
Thank you, Dr. Reddy, for your inspiring words, for highlighting the impact of CCPR and other innovative technologies that are shaping a sustainable future. Your insights truly set the stage for today's discussion. Next, we are honored to have Sri Sanjay Nirmal, Formal Secretary, MORTH, to address us. Sri Nirmal's experience and expertise have significantly contributed to the advancement of transportation sector in India. Shri Sanjay Kumar Nirmal is the Secretary General of Indian Roads Congress, bringing decades of expertise and leadership to India's premier body for road development. With a career spanning of 3 decades, Shri Nirmal joined the MORTH, that's Ministry of Road Transport and Highways, in the year 1986, later serving in NHAI as General Manager and Chief General Manager from 2003 to 2010. He concluded his distinguished career at MORTH as Director General Road Development and Special Secretary. A highly recognized figure in engineering, Shri Nirmal has been honored with numerous awards, including the Pandit Jawaharlal Nehru Medal, the Lifetime Achievement Award from Indian Geospatial Society, an Eminent Engineering Personality Award from the Institution of Engineers, Delhi chapter. He also received the prestigious IRC medal from Best Technical Paper in 2019 and in the year 2022. Shri Nirmal is a fellow member of both the Indian Roads Congress and the Institution of Engineers and serves on the Executive Committee of World Road Association in Paris. France, reflecting his ongoing commitment to advancing global road infrastructure and engineering excellence. Ladies and gentlemen, please welcome Shri Sanjay Nirmal ji to the stage with a round of applause.
Good morning, ladies and gentlemen. Respected Chairman NHAI, Sri Santosh Kumar Yadav ji, Chairman Cube Highways, Dr. Reddy, delegates, invitees. First of all, I am grateful to Cube Highways for inviting me to this important global convention on CCPR technology. I must compliment Dr. Reddy and his team for implementing CCPR as well as many other sustainable technologies in India, which were, I think they were first in many of these implementation of these technologies. Even the government and IRC was looking to their experience and feedback for preparing some of our standards. In fact, the recycling standard of IRC came in 2015 after you had already implemented it on Mahua Highway. I was also associated with the implementation of this Mahua Highway project. And another technology which SMA you used here, in fact, I was also associated with Kishangarh Ajmer section, where entire road was constructed with SMA way back in 2010-11. So, as you know that IRC and BIS are two standard preparing bodies in India. In fact, there is a broad we have the scope. We are preparing basically for implementing these technologies for road construction, and BIS is preparing standards for material aspect as well as the testing aspects. IRC in last 90 years, they started in 1934, and last 90 years about 300 codes and guidelines have been prepared in IRC, out of which 20 standards and guidelines are dedicated to sustainable and new technologies and environment-friendly technologies. They are working in 26 technical committees are working, and one technical committee is dedicated only for eco-friendly, environment-friendly and technologies for reduction of carbon footprint. I think that is a very important goal which has been set by United Nations, as well as our country also has now a goal for 2050 zero emission. So this particular technology is contributing it significantly for reduction in the carbon footprint. Now coming to recycling, in fact, this is nothing new. This is not a new concept. When I joined Ministry of Road Transport in 1986, that is 38 years back, the first task I was given during my orientation program was to discuss with the DG, then DG and others, officers, what is recycling. In October 1985 itself, Ministry of Road Transport had brought out a detailed guideline and tentative specifications for recycling. It was a very broad, detailed guideline. And in 86, we were discussing this aspect, that how to do recycling in our pavement. And that time we had a chief engineer, Mr. R.K. Saxena. He was very dynamic and standard and research he was looking after in ministry. And I was working, then I was posted in regional office Jaipur. Then I was asked by him that why don't you start implementing in Rajasthan this recycling. So under periodic renewal work, I sanctioned 10 kilometers on Jaipur-Delhi highway, that is beyond Kotputli to Jaipur section. And there was only one contractor, Atlanta was having only the machine. So he wanted feedback from me that once you do this, complete this work, let us have the feedback about the quality of work, about the cost aspect and every aspect, and we found that it is costlier, much costlier than the normal conventional work which I will do with the normal plant and machinery. And because of the, very few works were there, so the cost was coming enormously high, and nobody was taking up this technology further. And then scattered somewhere, though ministry was issuing circular to circular, that this is a very effective technology. Why don't you try? In fact, you find every 4 or 5 years, there are circulars coming on recycling. But the technology became popular only after it was streamlined and mainstream IRC published the guideline, that is IRC 120 on recycling of bituminous mixes. And there we had some cap on the maximum use of RAP in this, that is 30 to 50% maximum we can use. Though industry was pursuing with IRC that why don't you increase this RAP percentage based on the feedback which we have received. And in fact, we wrote to all the implementing agency, why don't you provide us feedback, what percentage you have used, and whether it is, effectively working or not. Because we also know that now when we have a huge road development program in the country, and there is a huge scarcity of resources, particularly bituminous resources, more than 90% of the road in India are flexible pavement. So we must see that how to optimize our use of resources, particularly this bitumen aggregates all, and RAP. Utilization of RAP is a very important element in that. So in spite of that, they were not coming forward. After this publication, I think a lot of work has been done in recycling, and in this code we have specified that all the kind of recycling technology, that hot mix or cold mix, then in situ or in plant, central plant, all the kind of recycling technologies have been given. And after that, we have prepared now in 2022 another code, that is IRC 135, that is talking about the manual for bituminous mixes, design of bituminous mixes, and there we have dedicated one chapter on design aspect of RAP. So I think there is a need now that after, say, more than 10 years of the earlier code, recycling code, and then this feedback, we need to review this, our earlier code on recycling, but I am looking forward for the feedback from the industry. And I think the project which you have mentioned, that Ghaziabad, Aligarh, and 90% RAP you have used, though we were very apprehensive about that, because the consistency of the RAP quality is a very important element, and there are other challenges before we implement this into the code. Now another aspect is that the specification also is under revision, and there also there were suggestions that why don't we increase. There is a chapter on recycling in the specification book, that 6th revision which is under finalization. So there we want to have the feedback. I think the today's seminar, which we will be discussing about various aspects, right from the design, then implementation, quality control, and we have the international experience, we have from the academics the experience. I think this will be very useful when we review this code. And sustainability is a very, very important element, and the entire world is working on that. And this is one of the most important technology, but there are other technologies also. As I told you, there are about 20 codes from IRC which are dealing with this aspect. Even warm mix, the first code was published in 2014, but hardly there is any feedback. Hardly there are 1 or 2 projects which we see, and I expect that cube highways should come. In fact, today morning also I was discussing with Arpan that why don't you implement this? Warm mix also is a very important technology where we can use and show that how much of carbon footprint we can reduce, and there are other technologies also. So I expect that cube highways, which have been the leader in this field, they should come out with many such feedback in the new technologies which are only on the codes and not in the ground. So today's conference should be very useful for us, particularly because I am chairing this flexible payment committee of IRC. So we are looking forward for revision of this particular code, as well as any new idea which come up during that course of discussion. We will be very happy to get the conclusion from based on the today's seminar. Thank you very much.
Thank you, sir, for your valuable insights and guidance. I'm sure your experience and expertise will help us in contributing towards the advancement of transportation infrastructure in India. Our next distinguished speaker is Shri Santosh Kumar Yadav, Chairman of NHAI. Sir has been instrumental in spearheading transformative projects across the nation. Shri Santosh Kumar Yadav, an IAS officer of 1995 batch, took charge as the Chairman NHAI with effect from 2nd Jan 2023. Prior to joining as Chairman NHAI, Shri Yadav served as an Additional Secretary, Ministry of Education, Government of India. He joined the IAS in 1995 and served in various positions in Government of UP, Government of India. He has been involved in policy making and decisions in various sectors like human resource development, administration, personnel, finance, agriculture, public administration, and urban transport technologies. In a career spanning of over 27 years, he has handled several key assignments at the center, state, and local levels. As Vice Chairman and later as the Chairman of Ghaziabad Development Authority, during the year 2012 to 2015, he conceived and implemented several infrastructure projects. He held the position of CEO of Yamuna Expressway Industrial Development Authority in the year 2015 and was Managing Director of Noida Metro Rail Corporation in 2017. He holds a BTech in Civil Engineering from IIT Roorkee and MTech from IIT Delhi. Please join me in welcoming Shri Yadav with a huge round of applause.
Nirmal ji, Reddy Sahab, the whole Cube Highway fraternity present over here, stakeholders and dear attendees, from bottom of my heart, I am expressing my gratitude to this team of Mr. Reddy, because for the past 1 year, when I'm more deep into highway, because once you start your journey in a sector, 4-5 months goes back like you are searching here and there. I'm seeing the contribution of Cube Highways to National Highway Authority Set of India. We do lots of capacity building sessions, and quite often we keep on calling Mr. Reddy, Mr. Bowen is over here and their team, to build the capacity of the good work you are doing across all the stakeholders of NHAI, which means our project directors, our authority engineers, even the concessionaires, headquarter officers, even journalists like me. So, very big thanks to your team. And this implementation of CCPR technology, definitely 534 lane kilometers, 5 lakh metric tons of recycled material. It's a humongous task. Got a world record. Made proud you yourself and your team as well as NHAI as a whole, as a Ministry of Road Transport as a whole, in fraternity across the world. We got known that we can do it. I must appreciate the team, the engineers, the contractors, the policymakers and technology experts who all collaborated together. They all collaborated together and made this realize, this milestone, and they could set a precedent for future. I have been told by the team, by this effort, 78,000 ton of CO2, carbon dioxide, it has been reduced. So success of this technology, in a way, demonstrates our commitment of nation, that we'll go ahead with our development need. At the same time, we will not compromise environment. So this is the Hindi word is Sangam. Development, just I am telling you, I appeared for IS 2 times, right? The first time when I appeared, the question, the interview marks carry 300 marks. So the first, I was pretty young. The chairman of interview committee asked, Mr. Yadav, you just tell me the kind of content. I am just telling it it was year 93. They said, should environment really be a concern for India? I mean, immediately I blurted it out. I said, sir, it should not be. Because as a nation, we need growth. We need growth, we need to feed teeming millions. Not that he gave me 75 out of 300, I couldn't qualify for IS that time. But I was wrong. You know, you learn from the experience. You cannot feel nations good, consume resources at the cost of your future generation. You cannot. We have 1.50 lakh kilometers of national highway network. We are growing by 7%. GDP is growing by 7%. And there is lots of demands of highways. We are creating around 11,000 kilometers of highway network, not lane kilometers. If you multiply it by 4.2, it means close to 50,000 lane kilometers every year we are creating, and we'll keep on creating for next decade or so. Every year now we have been tasked to construct 4,000 kilometers of high-speed networks. So, you know, if I am to create this much of highway, and I use traditional technologies, traditional maintenance practices, then I'll guzzle lots of resources, lots of natural resources. What will happen to environment? So, technologies like this, they bring a hope. They set a way forward. So that's why I said today, though I am pretty committed. Its parliament is on. I have to rush to the parliament. I said I'll make it. I'll make it because this is something what is not only NHAI, future of nations at stake, how to move forward. Friends, I do understand when you implement technologies like this, new age technologies, then two aspects, quality control and quality assurance. They need to be stringently followed. If they are not followed, you know, if they are not followed, however good the technology is, if they are not followed, it will fail in the field, and eventually this will remain in files, they will not be in practice. So what is important? Important is quality control protocols, be it material testing, be it mixed design, be it on-site inspections. They must be rigorously followed. Quality assurance practices. We need to make SOPs. At the same time, independent audit, independent certification, these all to be followed, and everybody. You know, what we do, we create lots of technologies. But where we fail, to me, with 27 years experience of my in job says, we are not able to tell people at the ground how to do it. When I travel on the national highways, you travel on the national highways, you see whenever there comes an expansion joint here. No concession saves even a single paisa in that creating expansion joint. But there are a few concessions of whose construction joint is good quality, rest 60-70%. You do not save the money. So what is it that we are not able to? We do make SOPs, but the person who will execute it on the ground, the quality supervisor, we are not able to tell. We are not able to convince him. We are not able to tell him, you know, what is it, how to implement it. We are not able to create, you know, cartoon videos. Look, this is how you have to do it. So once I requested Mr. Reddy, please make me few cartoon videos of the practices you do, so that I host it on NHAI website. I tell it down the line in the field. I tell it at the project site, I'll show it. When the workers go for siesta in the evening, I'll display at their campsite. So that, I mean, you know, the word is dissemination, how I am able to disseminate it. So my request is this. And the big role of his is PMC. For us, authority engineers. They are the one who are a bridge between me and how this technology will be transacted. So, friends, to me, today's this CCPR convention, I am looking as a vital capacity building exercise, not only for NHAI, for everybody who is watching this. Mr. Reddy, all my ROs, my RPDs, everybody in the front of the field across the country, they are glued to it. They are whole day, they will be watching it, they will enriching it. So far as NHAI is concerned, you know, whosoever, we know that NHAI per se, our role is, if we test a technology, lots of institutions in the country, state PWs, other departments, they look up to us, they follow us. So we know the role that unless until we pilot any technology and we demonstrate its, you know, usability, others will not follow. So we are in a way, big way. We are going to in a big way in bamboo crash barrier. Other steel ministry said that we produce lots of steel slags. We are piloting it on some of our highways. Fertilizer ministry said that lots of their fertilizer waste and residue is there. We are piloting on some of stretches. Once this is successful, so we'll roll out in a big way. So what I'm trying to say, NHAI per se is very upbeat, very positive about innovations, research and partnership. We in NHAI reaffirm our faith, commitment that we'll embrace all the new technologies and all these, the experience which comes through collaborations so that we can make world-class highways and make nation good. Thank you.
Thank you, sir, for sharing your vision and for reinforcing the importance of innovative and sustainable practices in infrastructure development. Now, ladies and gentlemen, we have arrived to the most important moment of Global Convention of CCPR, for which we all have been waiting. We arrived towards the coffee table book launch. Ladies and gentlemen, Cube Highways has recently achieved a monumental milestone by creating a world record of laying 112.5 lane kilometers in just 100 hours. Can we have a huge round of applause? To commemorate this extraordinary achievement, we are proud to unveil our special coffee table book. This book is not just a record of our accomplishment, but a testament to relentless efforts of our teams and partners. Let's have a big round of applause for this remarkable achievement. And now I invite our distinguished guests to join us on stage. Please. Please put your hands together. Very heartiest congratulations to each one of us for achieving this milestone of world record of laying 112.8 kilometers in just 100 hours. Once again, I congratulate Cube Highways for achieving this monumental milestone. I now request our distinguished guests to please stay on the stage for a photo opportunity to mark this special occasion. Thank you, everyone. We are truly honored by your presence. As a token of gratitude, we would like to present mementos to our esteemed guests for their valuable contributions and presence here today. I would once again request Dr. Reddy to please join us on stage, and also I request our distinguished speakers to please join us. First of all, I would like to invite Shri Santosh Kumar Yadav, Chairman NHAI. Please, ladies and gentlemen, please put your hands together. Thank you very much, sir. Now I invite Shri Sanjay Nirmalji, Formal Secretary, MOD. Once again, ladies and gentlemen, please put your hands together. Thank you, sir. Additionally, I invite Mr. Bhuvan Kumar, CEO, Cube Highways, to present a memento to Dr. Reddy as a mark of our appreciation for his leadership. Thank you so much, Bhuvan sir. Thank you so much, Dr. Reddy. Thank you to all our dignitaries for gracing this occasion and sharing your wisdom with us. Now we will move ahead towards taking a short networking break. Tea and coffee are being served in the foyer area. Please take this time to connect with fellow attendees and exchange your ideas. Kindly rejoin us. We request you to please join us at 11 as we commence the technical sessions. We have an engaging line of expert speakers and interactive discussions awaiting you. See you all shortly. Thank you.
और Hasin? Hasin? ये पीछे माइक ये हैंड माइक दो, हैंड माइक ठीक है।
सारे माइक ऑन कर दिए, आप बोलिए।
Pragya, is it visible properly? Perfect.
हेलो, इट्स ऑन ऑलरेडी ऑन।
Hello.
सर उसको बंद मत कीजिए, वो नीचे।
Hello. Hello. Hello.
This podium is also working. Check one.
Hello.
presenting the world's global brands to the Indian consumer.
Ladies and gentlemen, may I have your kind attention, please? We request you to please settle down. We are just about to begin our technical sessions for the day. Thank you. Once again, ladies and gentlemen, all of you are requested to please settle down. Once again, I welcome you all to the Global Convention on CCPR, Coal Central Plant Recycling, which has been organized by Cube Highways, Cube Tech, Mines, Innovative Center for Cube Highways, supported by IIT Madras and NHAI, partnered by Wood Gun Crew, IOCL, Homes India, L&T, and Bitcoin. Once again, I welcome you all, and I request you all to please keep your mobile phones switched off or on silent mode during our sessions. So, ladies and gentlemen, I hope you had a refreshing break. As we move forward, it's time to dive into the heart of today's discussion, the technical sessions. The subject of coal central plant recycling is really vast, fascinating, and brimming with potential. While our time today is limited, the knowledge we share and the collaborations we build here are invaluable. This platform has been created not just to inform, but to inspire, to spark invigorating discussions, quench our collective thirst for knowledge, and address challenges collaboratively. By learning, engaging, and sharing resources, we aim to make this transformative technology accessible across the country. Just imagine, if one expressway can create such significant impact, think of the exponential benefits if we collectively embrace and scale this technology. So let's begin with our first technical session, that's design aspects of CCPR. To begin the session, I invite the session chair, Mr. Bhuvan Kumar, CEO, Cube Highways Advisor. Before we invite him, first of all, please put your hands together. I would like to give a brief introduction towards his achievement. Mr. Bovin Kumar serves as a CEO of Cube Highways and Transport Assets Advisors to his current role. He held the positions at NHAI, Ministry of Road Transportation, Government of India, Rambol, CH2MHLL, and Halcro. He holds master's degree in civil engineering from IIT Kanpur and executive diploma in international business from IFT, New Delhi. He has over 28 years of experience in infrastructure sector. He specializes in infrastructure project development, program management, road design, and operations and maintenance. He has worked on designs of roads in India and abroad. Besides road sector, he has worked in rail and aviation infrastructure design as well. Now I would request Bovin sir to please take over the session. Thank you.
Thank you. Good morning, everyone. So as Dr. Reddy has already showed you the pictures and told you the brief of the project, so we acquired this project in 2000, we started discussion in 2018, and so when we were doing the DD, that time we realized that the pavement is in a distressed condition, and we need to find a solution. What do we do with this, and how do we do it? So as you all know that, in today's workshop has been divided into 4 sessions, right from design to implementation, and then specifically on the bituminous materials, and then the global experiences. So in this first session, we will be covering the design aspect, and we have 4 speakers. The Professor Murli Krishnan from IIT Madras, Dr. Stephen Charmot from Longevity, Dr. Nivita from PhD Coimbatore, and Bhanoj from Cube Highways. So our first speaker is Bhanoj Toku. Bhanoj is working as Vice President, Strategies and Analytics in Cube Highways. Bhanoj, so I'll just give you a brief about Bhanoj. Bhanoj holds postgraduate degree in Transportation Engineering from IIT Madras. One of his primary responsibility is leading design, operation, and maintenance of pavement network of the assets with Cube Highways. He is actively involved in various research activities and has multiple publications in the field of pavement engineering. His expertise includes pavement evaluation, design development, and implementing maintenance strategies and sustainable pavement technologies. Under his monitoring, Cube Highways has successfully implemented and executed many innovative materials and technologies. One of them is use of HIMA, for which Cube bagged Gold Award for Innovation. Prior to joining Cube Highways, he was associated with the ITS Planner and Engineers. So before I request Bhanoj to come on the dais, I would also request all the speakers to come on the dais. I would request Professor Murli Krishna. Dr. Stephen, Dr. Nivita, so now I would request Bhanoj to take us through the valuable insights into strategy, preparation, and reasons for employing CCPR at GAPL.
Thank you, sir. Can you play the presentation, please? I hope this session will address many of the conceptual things related to design of CCPR, be it from emulsion, pavement design, as well as mixed design aspect. So I will be taking care, just walk you through in terms of how we kind of came up with this idea of CCPR. Why CCPR? Why not some other technology? What are the benefits of it? As well as little bit glimpse about, we are saying GAPL is very bad, or its payment condition is very poor. Maybe with respect to data, let's look into that in terms of how bad was the road, and how we have kind of walked through the strategy. So mainly I will be covering about, as I told, little bit brief background and what all investigations we have carried out, and then little bit about traffic studies, like what was the design traffic that was considered at the time of design, and what is the actual design traffic that is there currently. And then what are the options that we have evaluated, because I think that will throw some light by CCPR. And then like what is the final strategy that we are implementing, because at the end of the day you should know like what we have done on the road. So maybe that will be the kind of an last part of my presentation. So like I think many of you already know, I think already Dr. Reddy briefed and Bovin sir has already briefed. So this is a highway which is connecting Ghaziabad to Aligarh, about 126 kilometers. About 126 kilometers. So it has about 2 toll plazas. I mean, this will be relevant for traffic studies. So and it will be connecting major cities of Uttar Pradesh. Like this was open to traffic in 2015, and we looked at in 2018. So some of the investigation data that we'll be presenting will be part of 2018, and some are part of 2021. And finally, we have taken this project in 2022. Like as part of the concession agreement, we are supposed to kind of a 6-lane this project by 2023. So this is also very much important. So which will be kind of an also played a major role in considering CCPR. So this was the condition of the road. I think you already seen the photos. So these are the investigations that are being carried out. So starting with structural condition evaluation with FWD and functional condition with NSV. Not only that, like you have already seen the payment condition is very bad. Now if someone wants to understand why the payment is bad, so we should also understand in terms of what is there in the payment. So we did material investigations, core cutting as well as test pits. So we'll be going through that data as well. So if you look at this is the kind of a remaining life data that we get from FWD, where you can see most of the payment doesn't even have any life left. And sadly, like this was open to traffic, as I was telling, in 2015, fully operational from 2016. So from 2018, we are monitoring this. This was the condition of the road, where there is no life left to the payment. So which is also visible with respect to the images of the payment. Similarly, if you go to functional evaluation, you can also see here, like more than 90% of the payment is either in fair or poor condition. And the same is with roughness as well. So which is kind of correlating between what we are seeing on the field and what we are kind of getting from FWD and what we are looking from the NSV point of view. So to understand more, as I was telling, so we did extensive core cutting. Like because first of all, we should understand whether the problem is in granular layer or subgrade or bituminous layer, because unless until we understand the root cause, we will not be able to kind of treat it properly. So we did extensive core cutting as well as test pits. So if you look at major problem with respect to cores, like wherever we have taken the cores, so they were like debonding and cores were not proper. So you can see here, this core recently we have taken about a month or 2 months back, which is about after 2 years. So you can see the condition of the road. But whereas when we were taking, there was not able to extract any core there. And when we look at in the like bottom layers, there are completely voids where there is a loss of fines. We do not know. I mean, our expectation is loss of fines. Whether it's loss of fines or the gradation in the first place itself is wrong, we are not sure about it. But however, the condition was very poor. So like this is generally we do not carry out, but for this to understand further, we have extracted, checked the binder properties as well as checked the aggregate properties, where what we have understood is like most of the aggregates that are used for bituminous layers are flaky, elongated, so which itself is going to create durability issues. And even the AIV, because like within Cube we have certain specifications, like we target about AIV of 12 to 15 to have better strength. But however, the AIV of this material is also very poor. So this is one thing which we are leading, like, okay, so bituminous layer, there is a problem with respect to the amount of binder content. Even the average binder content was about 3.8 to 4%. I'm combining BC and DBM. So versus a 4.7 sort of an. So we have binder content loss as well as the issues are with respect to aggregate. So now we are clear that the bituminous layer, there is a problem. Now we should further understand whether is there any problem with respect to granular layers. So we kind of carried out extensive test pits. Like where to understand subgrade properties starting from CBR, Atterbug limits. Same goes with the granular materials. So what we have noticed is like CBR is low in few locations because the design CBR was about 8%. But however, when we did test pits, about 30% of the locations, the CBR was on the lower side. But however, other than CBR, we did not find any major problem with respect to, let's say, any of like physical properties like Atterbug limits, like liquid limit, plastic limit. So we did not identify any problem in that sense, so which can also be seen in this graph. So like if there is a problem with CBR, we can always design. But if there is a problem with respect to the material that is used, then there is a big challenge. Because let's say if you have a plasticity index very high, then how do we going to kind of like we can put whatever we want at the top, but however it is keep on expanding and then it eventually leads to failure. So with this, we got a confidence, okay, if it is only CBR, we will treat it. Now, like how we have done and how we have rectified, we will kind of walk you through. So, like before that, just to kind of give a glimpse in terms of traffic, because we are speaking about remaining life, we are speaking about condition of the road. Now we should also understand what is our target. So what should be the design traffic to which we are looking at? So it cannot be unlimited. So we kind of carried out traffic studies as well, because when it was constructed, there was no Eastern Peripheral Expressway. So now we have added an Eastern Peripheral Expressway, and the road network has kind of developed a lot. So with that, other than those two toll plaza locations, we have identified two more locations. One is between EPE and then like Ghaziabad, where there is a movement of traffic that is coming from EPE going towards Ghaziabad or into NCR, and then like between Bulandshahr and Kurja, to understand what is the diversion of the traffic that we are able to see. So these are some of the numbers, because like everyone thinks coal center plant recycling is for a low volume road. That's how the practice has been. So like we should also look at the number of like traffic as well as in terms of VDF. So we are talking about like 16. So which like on a thumb rule, if I consider it is about it is carrying about 1.5 times its legal load limit. So like this is the kind of loading that is there. It is not extremely heavy loaded, and at the same time it is not like kind of a passenger driven or like very less loaded highway. So it has decent amount of loads. So, and also decent amount of traffic, which has to be kind of designed for. So this is the design traffic, where you look at like it is varying from 60 to almost like 105 for about 15 years. Whereas the initial design was done for about 55 MSA throughout the project. There is no bifurcation, so 55 MSA for about 10 years. So, and like it did not sustain till that time. But if you look at the actual traffic has also gone up. So this is the traffic for which we will be kind of carrying out the design. So, like just a comparison to appreciate, I mean for you to appreciate, if you look at the kind of a comparison with respect to remaining life and then the design traffic that we are looking at, so about like more than 80% of the sections, like LHS, RHS put together and inner and outer line put together. So where like we do not have life left or to meet our requirements, and also like why we have considered less than MSA is like just to show how much percentage of section has life less than 1 year. So which is also about 65 to 70%. So this is kind of an like substantiating the initial slide where we spoke about the remaining life. So what are the options that we have? So any pavement engineer, like we got excited because this is one peculiar or the kind of a challenging project that we can get to understand what needs to be designed. So what are the options that we have? Immediate thought process one can get is like, okay, let's go for reconstruction. Let's remove complete bituminous material and fill it with a hot mix material. So because it's easy and it's kind of well practiced as well. So that is one solution that we have. And the other solutions are like when we try to explore, okay, we have used HIMA, we have used cold in place recycling, we have used various other technologies. Can we bring some of these technologies to here? So finally we are able to identify, okay, in the alternate technologies, maybe we can think of a cold recycling. So when I'm saying cold recycling, why I'm saying cold recycling will also be coming in the next slides. So where, when we are talking about cold recycling, it's an umbrella term. It can be in place, it can be center plant. But however, the only advantage with respect to cold recycling is we can consume as much amount of RAP that we can. But at the same time, as I was telling, we have taken out this project in 2022, we need to complete it by 2023. Cold recycling takes its own time to complete. So that's a kind of a challenge that is there. But however, these are the options that we are kind of we have finally arrived at, saying that let's explore between these options. So then we have carried out design as per IRC 37. I think like we also did with like Circley, so that Dr. Nivita will be covering. So in this, if you look at, people think cold recycled material is weak or it doesn't have enough strength. And that's correct. There is no kind of a debating point or any of those things like that. But having said that, it's like at the end of the day, it's an engineered material, right? So we can design however we want. So based on that, we kind of want to explore that. But having said that, if we look from the design aspects as well, the difference between a conventional technology and a technology with CCPR is about 5 mm. So this is also because of stress strain behavior, how the axis is shifting up, so many other things. So like the difference is about only 5 mm. So which means it's not substantially kind of an higher that we are putting when we are going for a cold recycling material. So similarly, like just because at the end of the day, like when we are presenting this, anyone will ask like, what are the questions that will be there? Is it cheaper? Or what is the time that is going to take? And what are the additional benefits? When I'm saying additional benefits, sustainability point of view. So these are the 3 aspects. Anyone will get a question saying that, okay, you have 3 options. While you're evaluating, can you look into these things? So this is the kind of an, just a thumb rule like estimation. This is not the actual numbers that we have incurred in the project, but just a thumb rule. If you look at like for a conventional, obviously cold recycling is cheaper because one, there is saving in aggregate because we are talking about 80 to 90% of consumption of wrap. So there is no requirement of virgin aggregate, and even the binder content will also kind of is on the lower side. So obviously it will be cheaper. So it is about 25 to 30, 20 to 25% cheaper. But having said that, if you compare apple to apple, this will be about 35% cheaper. But for this design, this is about like 25%. When we look at the time, because as I was again reiterating, so we need to complete this in about 1 year of time. So when we looked at in terms of time, obviously the cold recycling is going to take more time than hot mix because of it has its own challenges, because after laying, you need to give enough curing time to get the strength before you kind of bring the traffic onto it. So because of those things, time, it is more. But having said that, time is always in our hand. Like, let's say we deploy more resources or we kind of play with that. Eventually, we can play with this. So like time, obviously, it is more. Now, one more interesting aspect. This is, I mean, as part of Q, we kind of ensure we always look at what sustainability point of view we can bring in. So about 700,000 metric ton of like wrap that will be produced from this project. I mean, based on the initial strategy. So out of which, if we go with the alternative design, be it in place or in plant, we will be able to consume about 650,000 metric ton. So we will be able to consume most of the wrap because that 50% can be a wastage. And whereas if we go with a conventional method of hot mix, we will be able to only consume about 320,000. So we are talking about 40% of material. So, which means after this, where are we going to dump remaining 4 lakh metric ton, like 400,000 metric ton? I'm not sure, because at that scale, I don't think so anyone we had experience in implementing at that scale, because where are we going to dump this 400,000 metric ton? So this is also one major aspect that has played in the background, okay? So like considering the wrap point of view, considering the cost point of view, considering the time point of view. So overall, it looked like in place and in plant are fine, and then conventional technology. But however, it's a big like bet that we are putting, because no one has executed at this scale. But however, like the amount of deliberation, the amount of discussion, the amount of brainstorming that has happened behind this is like huge, where like various industry experts, various people from like across the world have put their minds, and accordingly like we were able to come up this thing. So like, as I was telling, so cold recycling is the final technology, I mean, which is looking lucrative for us. So in that, what do we have? In place, in plant. So why not in place? Because it is more cost effective and more sustainable point of view, because at the end of that, there is no hauling of aggregate. Like you do not have to take the material from site to back to HMP and bring it back. So that is also there. But if you look from the aspects of quality control, because we are talking about 1 year construction where we do not have a second opportunity. If the payment fails, we are going to miss the bus, we will not be able to complete the project. So we do not have to take any sort of risk with respect to quality. That's the major aspect. So if you look at the comparison, so there is no quality, I mean, we can control, but it's very difficult, because Indian roads are like, in design we consider it as homogeneous and uniform, but that's not the condition that is there on the road. Every kilometer, every 100 meters, the wrap changes, the complete gradation changes, the source may change. So all those things have to be kept in place. Whereas in place, it's everything is happening in the machine. It's kind of a challenge. We do not know what is coming out of it. So, and we also had an experience with that, like where we have executed as a trial section, because we are thinking we will be taking out this project where we might have to do a cold recycling. So as a trial project, we already carried out an in-place recycling just to see where do we stand. So when we executed about 11 kilometers of in-place recycling, in that about 30%, like 30% showed distresses, premature distresses. So there are reasons associated to it. We studied what are the possible reasons for those kind of issues, be it like, as I was telling, it's a black box. What is going in, what is coming out, we do not have any control. And like in terms of foaming, because like we used foam there, so like how the foaming is happening, whether the mixing is happening within the half-life, that it's very difficult to control in that. So these are some challenges that we have learned. So from that, when we move to kind of an like center plant recycling, where it's clear, like any hot mix, like whoever has executed hot mix can execute cold center plant recycling, because what we are talking about, you take the material from site, bring it to the plant, and then you check the gradation, how it is, and then based on that, just like how we kind of handle hot mix. So look at the gradation, look at this, and then accordingly we can go for implementation. So like if we want to kind of change the gradations or change the proportions, we can always do it. So that is the kind of benefit that in-plant recycling has kind of at least initially that's what we thought, and it's true as well. So with that experience, so we are able to kind of pick CCPR. So these are the main challenges. So like main advantages, aggregate gradation can be controlled, and in terms of quality control, this is way better compared to like cold in-place recycling. And even once it is laid, we can always do the kind of an quality control testing. And one more aspect is, so 4 to 6, how are we going to widen it? Let's say if you are going for in-place recycling, we mill it in that 4 lane. How do we shift that material to that additional lane? Even though Wittgen has come up with some solution there, but however, at that time, it looked kind of a little bit crazy, I mean to put it in that words. But having said that, like, because what we are saying is we produce in the 2 lanes and then shift the material to there and then we compact. So because till the time we compact, we have that curing time which we need to kind of transport, which is a very challenge. Instead of that, take the material back, bring a full width paver, lay it for full width, it's easy. And like from that point of view of quality, as well as from the looking of that, there is no going back because we do not have time. From that aspects, this is the kind of a suitable technology. So this is the final strategy that we have implemented. So where like for first 10 kilometers, where you have already noticed, the remaining life is good and the condition is also better. So there we went ahead with conventional methodology where we 40 mm overlay, and wherever required we have carried out rehabilitation. Whereas for the remaining about 96 kilometers starting from Dadri bypass till Aligarh bypass, so we were able to kind of do cold center plant recycling because that's the most distressed portion. And then the last 20 kilometers of Aligarh bypass where we do not have to do 6 laning as well, the condition is decent. So there again we went ahead with like conventional methodology. So I mean, because it's not like complete 126 kilometers we did cold center plant recycling. We have developed tailor-made strategy based on the need. Accordingly, it was implemented. So just to present in the strip chart, this is how it is kind of for the implementation purposes. Where from the point of view of bitumen, so for bituminous concrete, we have used PMB 70-10E because of the loading characteristics there as well as the temperature characteristics there. Whereas for DBM, VG40, again it's refinery based. There were suggestions where it was kind of suggested, why don't we kind of add 1% polymer to VG30 and use it. So, I mean, we have our own issues concerned to that, but it's a VG40 procured from directly from refinery. And then like SS2, I think in my next session, Dr. Stefan is going to talk about it. So tailor-made SS2 has been used because as I was telling, curing time we need to reduce, and also strength characteristics needs to be considered. So these are the materials and this is the strategy that we have used. Thank you so much.
Thank you, Manoj, for insightful presentation covering the nuances to be considered while finalizing the treatment and why and how CCPR was considered to be beneficial over the other treatments. So one challenge which was left with this treatment was now the time cycle. And how do we reduce the time cycle? I think then the bituminous emulsion was a very important part in that. So after this presentation, now the second presentation in this session is on the design of emulsion for CCPR. The presentation will be done by Dr. Stephen Charmot. Stephen Charmot works for Longevity and as a technical director, and Stefan has been involved with the pavement engineering for 30 years, which includes 12 years in Asia. His experience is related to the implementation of cost-effective maintenance and rehabilitation technologies, RAP uses, hot and cold recycling, warm mix asphalt, and asphalt emulsion-based technologies are the key focus areas of his work. Stefan has been involved with the construction of more than 100 recycling projects in USA and Asia. Stefan oversees the structural pavement R&D team at Longevity headquarters in North Charleston, USA. Stefan is passionate about conducting research that can result in sustainable solutions. Now I would request Dr. Stefan to share his views and experiences on emulsion design for CCPR, its chemical properties, selection criteria, and development of tailor-made emulsion to achieve superior results in recycling projects.
Good morning, everybody. A real pleasure to be here today, traveling from the US, escaping the cold and getting to a very comfortable place, so it's a real pleasure. Again, thank you for putting this great event together and for the willingness of all the stakeholders to share their experience. So hopefully together we can make a difference and implement cost-effective and environmental solutions. So CCPR is definitely a great example of that. So what I will cover today is really to talk more about the asphalt emulsion that can be used for this type of application. So we'll give you some general information about emulsion. You're probably already very knowledgeable, but I'd like to emphasize a few key points. We'll talk about production, and a word that comes very often, people like to refer special emulsion, specially designed emulsion, as engineered emulsion, but what does that really mean? So I'll try to really cover that, and really how we optimize the system to make it as successful as possible. So let me very briefly start with, what is an asphalt emulsion? And I apologize if it's something that you already know, but basically what we're trying to do is to take bitumen asphalt and turn it into liquid asphalt at ambient temperature. And the way we do that is basically to make an emulsion. So an emulsion is usually, in this case, the way we used it for this project is asphalt droplets that are suspended in a water medium. So the way that it's done is basically using a surfactant that will allow these asphalt droplets to remain in this water suspension. And a simple way to basically represent that is you basically have the chemistry that goes into the asphalt, and that will provide a charge to keep the asphalt particles from coalescing. And a very important process of the asphalt emulsion is basically, after you make it, is how quickly will it kind of break? How quickly will it come back into the form of the bitumen asphalt that you started with? So there is a process by which that takes place, and that's what we're trying to control and formulate the emulsion depending on the application that we want to use it for. So I will share a few more details related to that, but the type of emulsion for the type of application is very, very important. So talking about the production of emulsion, and here you have a great producer, so I think you're in a very good shape as far as how to bring emulsion to the marketplace. But I'd like to mention in the US, PPRA, on the presentation there is a website, roadresource.org. It has a lot of very valuable information about different maintenance and rehabilitation techniques and specification and case studies. And they have a very nice little overview of how emulsion is made. So basically you can see here, we're going to design an emulsion for a specific application, but very importantly, we have to produce it. And typically the way it's done is at a specific site, you will have a mill that is a really key tool to produce this emulsion for real implementation in the field. So again, the emulsion needs to be formulated based on, being produced, being transported, and again, having the application in mind, especially related to the breaking of the emulsion. That's a very important consideration, how well it will be utilized in the field for what the intended purpose is. So going to the factory, this is kind of typically a key component to make an emulsion mill. So you have a lot of shearing action that takes place to make these asphalt particles, and that typically with a colloid mill, so you have a rotor and a stator in this mill, so one is fixed and one is rotating, and it will really shear the asphalt as it's going through that mill. So you can envision the asphalt going through this equipment, and you have the water and the chemistry that will come together, and under the shearing action, you're going to create that emulsion. So some things that are very important when you make the emulsion is really, the shearing action. And that will really drive a very important property of the emulsion, which is, the particle size of the emulsion. So in the project that was done for the CCPR, again, some really qualified people produce the emulsion, produce a high quality emulsion that's formulated well for the project, but also that's produced in a consistent way. And one of the parameters that's important is the particle size. So that was checked when the emulsion was made to make sure it met some specific requirement. So some of the factors that will affect the particle size are the equipment, the type of asphalt that you're using, the emulsifier that you're using, and you have listed here a few other parameters when you make the emulsion, some details related to back pressure and the overall flow. But it really comes down to the shearing energy that you create during the process. Going back to the type of emulsion, you can see here a basic classification. So typically, we like to refer to emulsions as being rapid set, medium set, quick set, or slow set. And it really, again, depends on what you want to use it for. So the rapid set and the medium set, they're typically spray type of emulsions. So they're used for spray application. So it can be a tack coat that you want to break very fast to bond different layers of the road. A very common application for a rapid set emulsion is a chip seal or surface dressing, where you spray emulsion on the road and then you drop some chips. So that's a very popular maintenance treatment. So you need a very rapid breaking emulsion for that application. So on the other end of the spectrum, you have more quick set that are typically used for microsurfacing, or slow set that are used for cold central plant recycling or cold in place recycling. So these emulsions are also referred to as mixing grade. So now you're not going to spray it, so you're going to mix it with typically wrap or aggregates. So you need a slower system. So you've got to be able to get that mixing going and not have the emulsion breaking before that's done. So these are kind of basically the breakdown of the type of emulsion and emulsifiers that you want to use, again, depending on the emulsion. So in the case of the CCPR, it's more towards a slow set type of application, again, a mixing grade, where you will rely on more the pH shift and the environmental conditions for the emulsion to break under the compaction of the rollers to start building the cohesion. So a high performance CCPR emulsion will rely on different things. So first of all, it has to be compatible with what you're going to mix it with. So in this case, for the CCPR project, that was with a high percentage of wrap. So you're going to make sure your emulsion is compatible with the wrap that you will be using. Another, again, variable is the base asphalt and the grade of the base asphalt. And the base asphalt itself can have an effect on the emulsion quality, some of the emulsion properties. So looking at the SARA analysis or the acidity of the asphalt, that will play a role. So that's a factor to look into to make sure that your bitumen will be suitable to make a good quality emulsion. Of course, the emulsifier itself, the emulsifier package, what kind of, again, chemistry you're using to achieve the goals of your application. The specification, we can say, well, we'd like the emulsion to do certain things, but we need to have a specification. So to make sure it's captured by the specification. And then what you're going to use it for, in what environment, under what environmental condition, that's also very important. And of course, your QC/QA, as it was mentioned in the inaugural speech, it's very important to make a consistent product. So your emulsion quality needs to be as consistent as possible once the target is established. And then how you will use the emulsion, we can go beyond the specification. We can have additional SOP requirements for the emulsion itself, but also how we're going to use it in the mixture concept and apply some approaches such as balanced mix design to really optimize your emulsion, not only formulation, but the amount of emulsion to achieve the mixture properties that you're looking for. So let me go back to this concept of engineered emulsion. It's kind of maybe not so clear what that means. So I mentioned here on the slides, there are some resources out there, and there's a nice webinar that was done again by IMA, the Emulsion Association in the US, about engineered emulsion. So if you're interested, you can go back to the recorded webinar and hear more about engineered emulsion. But basically, what is an engineered emulsion? So it's a type of emulsion that is formulated specifically for an application and for a project. So it's really intended to meet specific goals. And you keep in mind the end result. What do you want your mixture performance to be? And then you work backward in terms of how to formulate the emulsion to achieve these goals. So that's pretty much what that means in terms of engineered emulsion. So specifically for the CCPR, our engineered emulsion for the CCPR, what are we looking for? So beside selecting the right base asphalt, so that's number one, but also what do we want the emulsion to do? So looking at performance, as we said, wrap compatibility, and that will be taken care through the kind of mix design. But one thing that we want to make sure to achieve is very good coating, because the coating is related to durability. So once you take your emulsion, you mix it with all the other components in your mixture, you want to get good coating. So that's something to check, because again, durability is related to that. Another aspect is the workability. So we're using a mixing grade type of emulsion, but we want to make sure that we have enough workability. So we're going to mix it with all the components, so wrap, water, active filler, at the factory, at the central plant, and then we have to transport it to the job site, we have to make it go through the paving equipment, so it has to be workable. We don't want the emulsion to break before it's down on the road. So that's another important consideration, so the workability. And once you place the cold mix on the road and you compacted it, at that point, you want the strength to increase rapidly. So you want as quick strength gain as possible once you basically compacted it. So it's a little bit of a balance, you have to design your emulsion and formulate it so you can achieve these goals from early life to long-term performance and what happens especially during the construction project. So talking a little more about the short term, specifically when it comes to workability, what does workability mean? So, again, we can define that a little more scientifically. So for the workability in the lab, we can do certain things. So there are some tools, some methods. There is a workability test. So basically you make your mix in the lab, and then you make a pile, and then you let it sit for whatever time you feel you will need in the field before it goes through the paving equipment. And then you can check, basically pushing a piston that will give you the graph that you see on the slide, that basically a force as a function of time or displacement. And you can see from the graph you have replicates. So one graph goes higher, you needed a large force to move the mix. So that tells you that this mix is not that workable. So if I'm trying to push my pile and it's resisting, so it's not workable, the emulsion is trying to break, and that's probably not what you want, because you want to make sure it's really workable. So we have ways in the lab to kind of compare different emulsifier package, different emulsifier loading to make sure we have a workable system. And then at the other end, after you successfully put it down, what you want to do, as mentioned earlier, you want your strength to really build very fast. So we can also measure that in the lab. We can run some stability on short-term cured samples, and we can compare different formulations. So we can again optimize and engineer our emulsion to make sure that we find the best balance between workability and a strength gain. So for this project, and others will talk in more details about some of the emulsion properties, but once the chemical package is established, again to have a well-engineered emulsion, so these are the typical results, kind of meeting mostly the SS2 specifications here in China, but again being checked to make sure that it could do the job that we want this emulsion to do. So workability, strength gain, and long-term performance. But you can see some typical property for a SS2 specification. So as mentioned earlier, particle size is very important because the size of the droplets and how uniform they are, usually we like a single size, slow, relatively slow average particle size, so less than 6 microns is a good indication of the quality for the type of application that we're looking for, versus a more broad size distribution or bimodal that's not very suitable. So we also, in the field on this project, we really made sure that the emulsion was very workable. So you can see between the mixing, taking to the job site, and then checking a sample of the mixture that, the emulsion was still alive, so it was not broken. So it really behaved very well as far as the workability goes. And once compacted, it gained strength quickly. So this was, again, what we were looking for in the field, to have an engineered emulsion with the right emulsifier package. So you get the adequate workability and then gaining strength. We all want the rod to become very strong very quickly. To some extent, we don't want it to be super stiff so it will crack either, but as far as short term, we want to make sure we have enough strength. And that was really demonstrated on this project as well, because as you can see, the upper two right pictures, some sections, right after being compacted, they were open to live traffic because that was in a congested area. So it could take the traffic for many days before putting the overlay and not have any issues as far as raveling or rutting. And then we could see that very quickly the strength was sufficient so that the overlay could be placed within 3 days. In some sections we could do it even earlier, so it was cured and strong enough to definitely have no issues with the overlay. So again, in summary, just wanted to share a few details about an engineered emulsion. What does that mean? Some key factors that we look for in designing the emulsion specific to the application, in this case CCPR. So overall, we know from past experience from other projects in other countries or your own experience with CIR that emulsion cold recycling can be an effective and reliable technique because it's really cost effective. It can allow the construction to be rapid versus removing and replacing. That really takes time and that's not environmentally friendly. The NH91 project on a very large scale is really impressive. There were 3 production sites throughout the project, and then, making an emulsion that was designed for the application, that was of consistent quality, I think is a big part of the success for the project, because the emulsion is really kind of the glue that will hold the wrapped particles together. Not only short term, but we want it to be very performing for the longer term. and other speakers will talk about the pavement mix design and the evaluation of the mixture properties that we're looking for in terms of moisture resistance and rotting resistance, which is more the longer term performance that we're looking for. So specifically for this project, the emulsion was customized as an engineered emulsion to, again, provide good quality, being compatible with the wrap, and we tried to make sure we got 100% coating, that the emulsion was workable, that the mixture was workable, that it could gain strength soon after compaction, that the curing time was short enough, so again, it could take the traffic very well if needed, or you could put the overlay, the HMA overlay on top of the CCPR relatively quickly. And then again, as mentioned, the longer term performance, requirements would be met, specifically moisture damage resistance, rotting and cracking. So that's pretty much it as far as the engineered emulsion that was designed and actually really produced and constructed as intended. So a really big hats off to all the stakeholders involved with this project, which is a massive scale. To my knowledge, being on many projects, this was really, I guess, probably the biggest world cold central plant recycling project that I'm aware of. So it's really very impressive that all the people involved could make it as successful as they did. So thank you again for the chance to be speaking to you today.
Thank you, Dr. Stephen, for detailed technical insights on emulsion design. Your global perspective is invaluable for our understanding of CCPR. So now we will move towards our third presentation, which is on mixed design of emulsion-based cold recycled mixes. The presentation is essential for understanding the material science and engineering principles behind CCPR, and it would be presented by Professor J. Murali Krishnan. So Professor J. Murali Krishnan is currently working as a professor in the Department of Civil Engineering at IIT Madras. He teaches highway engineering and pavement engineering at IIT Madras. Prior to his PhD, he was an asphalt engineer at NH1 and NH45 in one of the country's earliest four-laning projects, which was late 80s, early 90s. Professor Murali Krishnan got his PhD at IIT Madras, and he was a postdoctoral fellow at Texas A&M USA for 5 years before returning back to IIT Madras as a faculty member. He is currently an associate editor in the International Journal of Pavement Engineering. He has carried out many sponsored research projects, and some of the notable ones include the Bureau of Indian Standards sponsored IS-73 project, the Department of Science and Tech sponsored project on developing warrants for use of modified binders for Indian highways. Would request Professor Murali Krishnan to share with us the intricacies of mixed design for emulsion-based cold recycling mixes.
Thank you. Thank you so much. How does this work? Proper. Is there any laser here? No. I don't think so it is. Okay. Good afternoon, everyone. So we will walk through this whole thing, mixed design process in the next 20 minutes. In fact, the story started here. So you can see some cores that are kept in the laboratory, and then you can also see a email from Arpan, June 18, 2021. And if you read it very carefully, he said, which will involve cold in-place recycling. So I kind of told him that, we don't really want to do an in-place recycling, considering the variability that we are going to see in the site. Let us do an in-plant recycling. So that is how it started. So when we sat down and looked at most of the things, other than our own IRC that we have, we consulted various reference manuals that are available. And in fact, for the sake of the practitioners, I am listing some of them here. One of the finest manual was written by Sabita, TG2. Then you have UC Davis manual, UC Davis and UC Berkeley. And then you have the AASHTO PP86. Then there is a series of NAPA documents that were available. But then finally, with the help of Dr. Stefan here, we also stumbled into JTG T5521. Okay, so before we just get into the actual talk about the mixed design, there are few things that we need to very clearly understand, because there seems to be a lot of misconceptions about what is this recycling and what is reclamation. And I am not really sure what we really did here, because if you go by the Caltrans definition, they will tell you that recycling means you use the material for the same purpose. If you are talking about reclamation, you are basically trying to push the material down, so which means, you know, in the food chain it is going slightly lower value. So you get a much superior material, you do something to it and push it below in the base or in the sub-base cores. And if you are a designer, pavement designer, you would really want to understand what kind of model that you are going to use to do your stress strain analysis. So this becomes a critical issue. Now if you look at what exactly constitutes, there are few things that are listed there: wrap, virgin aggregates, emulsion, water, active filler. So this looks like very deceptively simple. You know, there are a few interesting things that are going to happen in item 3 as well as in item 5. So is this a simple recipe mixed design? Yes, if you look at it in this particular way, it looks like a simple recipe based mixed design. You can ask Banoj or Arpan here or anyone from Cube, they will say, oh, I used 90% wrap, 10% virgin aggregate, 2.5% water, 3.5% emulsion and 2% cement. But did all these things tumbled out on the first day when we started really looking at it? No. The reason is we need to understand how these things really work. In fact, if you see the picture on the left hand side, this is a typical TG2 kind of a picture in which you can actually see what is there on the x-axis, the binder content increases. What is there on the y-axis, it is the cement content. And whatever you say, I'm sorry, I'm not able to show you where I really want you to look at it. So you will see something on the top that says stress dependent behavior, more like a granular material. And on the bottom right, you are going to see something called as temperature dependent or viscoelastic behavior. So that means, so if you just draw a line, you are looking at bituminous material to granular material, and your material that you are going to design is somewhere in between. Now where it is, we don't know. Okay, so if you don't know this aspect when you are doing the mixed design, I can tell you for sure that dead on arrival, this is going to work in a completely different way. So this is a detailed understanding of the whole thing is needed, and this works in 0.5%, 1% variation. So that means it can show a brittle to pressure dependent response to rate dependent response, and with a very small variation of cement, emulsion as well as the wrap content. So there are different schools of thought. We have our own IRCSP 100, there is a TG2 South Africa, there is ASHTO, there is China. And then how should we really design? So we just need to ask this: do I want it to behave like a bituminous material, or do I want to behave like a stabilized granular material? And if you don't really have a better understanding of all these things, this mixed design is really not going to work. So for the sake of this particular talk, I'm just going to walk you through TG2, because the manual is fairly well written in a language that could be understood, and it clarifies most of the questions, but it has its own limitations. I will also talk about ASHTO, and then finally about the JTG, and then I will show you what we actually did. So this is your technical guidelines for bitumen stabilized material. Please understand this, look at this very carefully. They call it as a bitumen stabilized material. This is a freely downloadable PDF file. You can go download it. So if you take a look at it, this is their definition. So that means it is a stabilized material, granular material stabilized with either emulsion or with foam. It could be used only in base or sub-base, and the residual bitumen content. So that means, if you are using 5% emulsion content, and if you are using 60-40, what is the residual bitumen is there. That is what it essentially says. And then they also tell you clearly that inorganic binder cement cannot be more than 1%. The interesting part is focus on the middle box that you see there. There is a permanent deformation, there is a fatigue, there is a moisture susceptibility. But these are guidelines. So the guidelines basically means, they give you lot of ifs and buts. So if you really want to restrict the permanent deformation, restrict on the emulsion content. If you want no fatigue, then restrict on the cement dosage. If you are looking at moisture susceptibility, these are the following things. So when we are really talking about mixed design here, we are talking about aggregate, bitumen and active filler. Now comes the interesting tidbits here, and this is something in which we need to focus our attention, especially when we are doing these kind of projects in places like Ghaziabad, where the temperature can be the key issue. So if you really think that you take 80% of wrap, 90% of wrap, show it in your base course, and if your air temperature goes to 45, 46 degrees centigrade, so the pavement temperature at that particular location is going to be 55 or 60 degrees centigrade. If you think that the wrap is not going to do something, then we are mistaken. So it is going to do something actually. So what they typically tell you is, if your PG of performance grade of the location is going to be more than 70 degrees centigrade, try and see whether you can measure the shear properties of the wrap. And now how active is the binder? And this is $1 million questions in which most of the people in this industry do not really know whether the wrap binder is activated or not. We just do a wild goose chase here. And as far as the strength and durability is concerned, and this is where always I have a concern with the practitioners who give us the material, because when they mill the material, it is not very clear. You get it in chunks. So now we need to see how exactly the strength. And so these guys have this very ingenious way of telling, oh, there is something called as a breakdown coefficient. You just take this material, hammer it, do the sieving, and if there is a change of 9% or 10%, you seem to be having a pretty good wrap. That is what it will be there. So now when it comes to the binder, and it is very clear, they are asking you to use only it as a stabilized material. So that means you are looking at a very low viscous material, something what we call in this country as VG10. Right. So now let us talk about the filler. Different types of fillers are given, but what is very important for us to understand is the TG2, the South African guidelines, will tell that there is a hydration that is happening. But in the last 10 years in which we have worked out at different ways in which these things behave, we have not been able to really see any kind of hydration that is really happening here. It is, in my opinion, it is just a mopping up of the moisture. And this is also an interesting thing, and in the next talk which I will be talking, we will be talking about something called as the fluids and bitumen stabilized material. You have water in your existing material, granular material, you have water in emulsion, you are also going to add some additional amount of water, but all this water content cannot really be added. So whatever is the water that is present in emulsion and what is the pre-wet water that you are adding, this really cannot be added, because this water release rate from the emulsion is going to be totally different than the water that is already existing, but they seem to be adding it. So in fact, that is why my remark is this really cannot be added. But what we really liked about this gradation, it's a smooth gradation. Okay, so this is something that we just need to keep in our mind. So then as far as the compaction is concerned, they basically tell you to do a vibratory hammer compaction, in the sense that it kind of tries to simulate what is the compaction that you normally do in a sub-base or a base course. We will come to this compaction also in a while now. And the curing, which is the most important thing. So how do you really decide what kind of emulsion dosage you really need to do? So you have to kind of cure the material. Again, there are many schools of thoughts related to how to cure the material, how to decide what exactly is the kind of material that you are going to use. So depending on the type of BSM that you want, a bitumen stabilized material you want, one or two, you could go into your geotechnical engineering fundamentals, find out the C and 5 and try and see what is the retained cohesion and do it. Remember, they always want you to treat it like a granular material which is stabilized with bitumen and not as a bituminous layer, but that is not how the material is really going to work. So this is as far as TG2 is concerned. Now if you switch gears, come to the Americans, what they really say, they have a very terse document. The UC Davis document and the UC Berkeley documents talks a lot more, but they have not really come to any conclusion. But ASHTO is always PG driven, performance driven. So there is a very clear definition of what is called a CCPR, base layer stationary cold mix plant, and you need to have a surface treatment with an asphalt mixture overlay. The gradation is very sketchy. There are many sieve sizes that are missing here. So that really means you do not know what you want between 19 mm and 4.75 mm. So this is just open. Okay, so that is one issue here. But since PG is their people's strength, especially the binder specification, they would really want you to use their long-term payment performance binder software to do the binder selection, ask for a 98% reliability, find out what is the temperature at which the CCPR is going to be there and what is the binder PG that you should use, and they want you to use ASHTO M320, which is your performance grade specifications for binder. And most importantly, they also developed what is really called as the emulsion residue recovery. So that means you make an emulsion, you develop, find out the residue, and then you measure the PG of it, and then say that this is the PG of the emulsion residue that you are going to see there. And people are looking at something called as a 64% residue. Different test methods are given, and now you see slowly that they indirectly tell you that it should be treated like a bituminous layer, because they just push in that Marshall stability values here. So that is something that you can see. Now when you come to the China, you will also see the name of Dr. Stefan somewhere written in between that Chinese things there. So he probably had a role in rewriting this. Zamping is somebody I know professionally. So this is the recommended industry standards of the People's Republic of China. So we went through it, and I can tell you that I was really surprised at the detailed manner in which the spec was written. Okay, it took me some time to understand what they were trying to say. I have just highlighted only the blue color band, cold central plant recycling. So you are talking about a central plant asphalt layer, and you also have a non-asphalt material, and you can add an emulsion as well as you can add an inorganic binder to it. And where do we really use? They have their own motorway class 1 as well as class 2. I am really surprised at some of the AADT values that they use for classifying what is class 1 and class 2. So this is their classification. So they basically say you could use this for your base layer or a bottom layer. If you want, you can use it what is really called as a middle layer, but they are very clear that you should not be using this for the surface layer. And you may also want to, especially there are many of the practitioners are here, you may want to take a look at the thickness that they really want you to use. Your cold recycling layer thickness can be more than 120 mm, but on top of it they want an overlay of minimum of 120 mm. Again, it depends on the traffic level. You can see very heavy to extremely heavy here. The emulsion requirements now go back to what is their prevalent practice, because they still follow the pen and viscosity grade of a thing. So there is no PG that is coming in here. So you can actually see what is the penetration, what is the viscosity, what is the ductility that you are going to use here. But the interesting part here you will see is their gradation. Gradations are beautiful in the sense that there is a consistent, uniform, smooth gradation that is being followed. So that essentially means if you are going to use this kind of material, it is necessary that substantial amount of processing of your wrap has to be carried out, because only then you are going to get this kind of a gradation here. And similarly, the mixed design requirement is coming. You will see that there is a Marshall method. There is also a modified Marshall method. So that means, you could use nominal maximum aggregate size more than 1 inch. Most importantly, which is in a sense very useful to practitioners, is they give you the guidelines for the air voids. Now the moment you specify air voids in your mixed design, you are up the creek, because you are using a wrap material. Now the $1 million question that again people have to answer is, what is the effective specific gravity of a wrap material? Everybody will say different one, method A, method B, method C, but there is no final answer to all these things. And then there is an ITS test. So you are thinking, okay, so this is going to be like a bituminous material, bitumen stabilized material, but they also want you to do your at-will testing. So that means the combination is like that of a bituminous material, like that of a granular material, and then try and see whether you could do a at-will testing, you could do a Marshall stability, you also do a ITS, then you are also specifying what is really called as a the volumetric properties. So this is the general mixed design procedure that was followed. So the important aspects that we learned after we went through all these things is, first and foremost thing, the combined gradation has to be smooth. Second is, what is the optimum moisture content, water content, because you want to treat it like a granular material, try and see whether you can get an OWC so that you will be able to push in your emulsion in a smoothest possible manner possible. So for that you need to know some kind of an emulsion content. So we assume that it will be 3.5% emulsion. Then basically we did it similar to what you do for a HMA, 4 to 5 contents of emulsion, 1 to 3 content of cement. That is what we did. Now comes the interesting part, because this layer is laid here, and on top of it, as the layer is gaining strength, you are going to have bituminous layers going on top of it, and so there is going to be a compaction that is going to happen. So what JTG said is, in fact there is a PhD thesis related to it, is 25 blows, 50 blows on either side, and then 25 blows, and measure the volumetric properties and the ITS and the Rutwheel test results, iterate it with the cement content. But why is this two-stage compaction? In fact, this is the cover page of the PhD thesis that was submitted in Tongji University, research for some key problems of coal recycling asphalt mixtures used in reconstruction of heavy duty pavement. You can actually go through this, right? And so to summarize, you have a very wide range of methods, and in fact if you go to United States, it is a mess. You can actually see each and every state has different compaction procedures, different guidelines for the choice of emulsion content. We did not want to do that. So what did we really do here in the last 3 minutes that I have? I will quickly summarize. We picked the medium gradation, JTG. Emulsion design was done in tandem with Ingevity, IIT Madras, and then what we did in IIT Madras, we basically wanted to check the PG of the VG30 emulsion residue. We wanted to see whether there will not be any substantial change in the PG properties. Compaction, we did PP86 and then JTG. So that means two-stage compaction that we did. Volumetrics was the one in which we faced key challenges. That is a story for a different time. So I won't get into the detail here. And performance, basically what we did, we carried out the Rutwheel testing at different rates. So this is the final design criteria that was evolved after many trials, and I will just show you how the whole thing was done. So you have the batched materials, cement, water, and the sequencing here is most important. If you change the sequence, you get something else, because after you add the cement, you want water to be added so that you kick start the hydration that is happening when you add cement, and then after that you add the emulsion, do a 50 blows compaction, and then cure the sample at 60 degrees centigrade. So when you cure the sample at 60 degrees centigrade, and there is some amount of you are accelerating the emulsion residue as well as the cement hydration, then bring it out and then give another additional 25 blows, and you do it. And this is something one of my former PhD student, Dr. Atanu, he came out with saying that, so how do you really break the emulsion in the laboratory? So we just went and bought this cake oven silicon molds, poured this emulsion there, and then tried room curing it, and then you can actually peel it off. So the emulsion breaks completely, and then after that what we can do is, we can just measure the PG, because unlike your hot mix asphalt in which your RTFO and PAV procedures are well developed, these procedures are not well developed, and that is what we did. So then finally we did this Rutwheel testing. You can see on the left hand side picture, bottom, we have 3.5%, 4% and 4.5% emulsion content deformation. And so from this 3.5%, we wanted to see what is the cement content that we needed to add. So again we play around with the cement content, and that is how you typically see that we picked on the 2% cement. So to summarize, what are the salient features? We designed it as a bituminous material. We did Rutwheel testing. We did PG of VG30 emulsion residue. So we designed it as a bituminous material. We wanted to have a smooth gradation. We did the smooth gradation. We did two-stage compaction, and our cement dosage choice was based on Rutwheel testing, and the emulsion dosage was based on the ITS value, and the flexibility in the gradation basically depends on the site condition. Thank you very much. Arpan from VRT, Cube Tech, Stefan, Asif, Atanu, and my lab superintendent, Dr. Pugaid in the Pavement Engineering and Asphalt Laboratory, IIT Madras. Thank you.
Thank you, Professor Mullikrishnan, for your in-depth explanation of mixed design. Your session has been incredibly informative and will surely guide future implementation. So now, after the mixed design, now we move towards our last presentation of this session, and In this presentation, Dr. Nivita will cover structural design of CCPR, from material mechanics to load bearing capacity to different design guidelines. Her session will address key parameters that ensure longevity and reliability of recycled pavement. Dr. Nivita is currently working as assistant professor at PSG College of Technology. She graduated with her MTech and PhD from IIT Madras. Her areas of interest are pavement design, pavement material characterization, and recycling of bituminous pavements. So we'll now request Dr. Nivita to share with us the structural design aspects of bituminous pavement with CCPR.
Good afternoon, everyone. The moment I said good afternoon, my clock started ticking. So let me straight away get into the content. Okay, so I'm going to talk about the structural design that we adopted for the CCPR. So first let me start with what is that we want from a structural design, right? The question that we want to answer is whether a pavement can carry the load that is plying on it without failure for a specified number of years. The failure here is not straightforward as we have in some building elements. It is basically when we say take IRC, we say that it is 20 mm rutting or some 20% cracking, etc. So we have some criteria for failure here, and we say that it has to be achieved within a specified number of duration. So that is what we call as the design life here. And how do we do this? How do we achieve this? We have this mechanistic empirical pavement design method, which is what is adopted in most of the countries, starting from India to countries like South Africa, Australia, until United States. People follow this mechanistic empirical method. But again, the details that they are considering in the design procedure are different. So let me just briefly explain what is this mechanistic empirical design method so that we will be able to better understand how we are taking into account of the input parameters and the design procedure. I am sure this most of you would be familiar with. When we say mechanistic, it is the estimation of stresses here. You can see here, we have a pavement section that we will be taking. We have inputs as traffic and climate. So if I have a composition of pavement and I have a certain traffic and climate conditions, what will be the stresses that this is experiencing? So ultimately, it is the load that I am giving and the modulus which will give me the strains. But strains is not sufficient for a pavement engineer, because what do we do with strains? We want something in terms of traffic that we would be able to relate to. So how to convert the strains that we are getting here into the traffic capacity? That is where we have the empirical part, which are the transfer functions. So once I know the strains, I input them into the transfer function. This transfer function is again dependent on the type of mix that I am adopting, type of material, a number of parameters, which I'll be touching upon later. So I will get the traffic capacity, and this is the mechanistic empirical method. To just put it in a different perspective, you can take a pavement cross section, whatever is the assumed cross section that we want. We know what is the traffic capacity. Again, I'll come to the details of the traffic capacity. Let us now assume that there is a load acting on this pavement. Let us assume that we are using a standard axle load for the design purposes. So once we have a standard axle load, we will be computing the critical strain. Again, we have different layers for which we will be computing different parameters. This strain value, I will be using it in a distress transfer function, which will give me the capacity of that particular pavement. We are not, we can actually calculate it for individual layer or the pavement as a whole. In IRC, we are doing it for the pavement as a whole. So it will give me the traffic capacity of the pavement. And we also have the damage factor, wherein the numerator is actual traffic that is observed on the pavement, and the denominator is the load carrying capacity. Basically, we have to check whether this is less than 1. This is the procedure that we are aware of. But what are some of the issues that are present with this procedure, right? So there are some queries. First one is, how are we accounting for traffic? We can just take the AADT, use a simple multiplier like VDF and get the traffic capacity. Or we can do a detailed design like that is done in ASHTO, basically where they take each axle group and then the load group corresponding to each axle group, place it on the pavement, calculate the damage, do it for all the axle groups, axle types and all the load groups, sum up everything. Right? That is a more precise way of doing it, but we can also keep it simple. So it depends upon the design procedure. The second one is the modulus. Can we use a constant modulus for design? We are all aware of the variation in material parameters. If you take the bituminous layer, we know that its modulus is highly dependent on the pavement temperature. If you take the granular layer, we know that its modulus is dependent on the moisture content. But some guidelines assume a constant modulus, whereas some guidelines take into account of all these details. The third one is the performance relationship. You have this equation which gives the capital N, right, the load carrying capacity. If I have a different type of mix or if I have different pavement composition, can I use the same equation like the NF or NR equation? Right, again they have to be revalidated for the type of mix. And the last one is each layer has its own design life. Basically, we would be using just one design life for the entire pavement. But ideally, we can calculate the design life for each pavement so that we can individually optimize each layer. Later, I'll be showing when you have a layer like BSM, which has a higher load carrying capacity, we are not able to maximize the benefits of this layer because of certain assumptions that we are using. So this will again help us here. Now, to give the details about the design procedure, let me just walk you through this. The first one is a pavement, a typical pavement composition that you are aware of. So we have a composition, we have a load acting on it, and we will be attributing modulus to each layer. But one more thing is, the modulus will vary with the layer, but even within a given layer, the modulus will not be same. For example, let us take the granular layer, the base and subbase together. Let's say we have a 450 mm thick granular layer. The modulus in the top, let's say 50 mm, will not be the same as modulus in the bottom 50 mm because of the confinement conditions and stress dependency. But rarely we take into account of this factor in the design procedure. So that is one thing we should take into account. Right, let's say that we have taken into account of all this, which is how sublayering works. And once we take into account of all this, we have to associate a modulus. Right, so now if I have climatic parameters, I have shown you a graph wherein the moisture content varies over a period of time. Right, so first information I need is what is the variation of the climatic parameter, say pavement temperature or the modulus. Then I should be able to have some relation which tells me if this is the moisture content, this is how the granular layer modulus will change. Or if this is the pavement temperature, this will be the probable modulus value of the bituminous layer. So then we have to arrive at such kind of correlations, which again we have to look into it in detail. So once I know these things in detail, then I can have the traffic which I will be incorporating it, put everything together. Let's say if I have to consider all these things in detail, right? Let's say our design life is 10 years. I will be dividing it into each year. For the year 1, I will again have 12 months. So for the first month, I can take what is the average temperature, use that, calculate the corresponding modulus, what is the moisture content, use it, calculate the corresponding granular layer modulus, put it, what will be the traffic experienced in that particular month, again put it in the stress strain analysis procedure, get the strain value. So like this I can get it for different periods in a year. Let's say 1 month is a period for us here, get it for different periods in a year, and then get it for all the 10 years of my design period. When I cumulatively add all these things, it will give me a more realistic representation of the pavement design. In fact, just for the academic interest, we have even tried to automate it using MATLAB with the IIT Pave software itself. We have given the input values for all the modulus. IIT Pave, like MATLAB automates at the back end, it uses IIT Pave, and we were able to calculate. So it's just the cumulative damage or incremental damage approach we will be using. So ultimately, we will get the cumulative design factor, which should be less than 1. So now with this background, let us look at how design approaches across the world take into account of this pavement design procedure. We have considered IRC 37, the SABITA, which Sir was talking about, the TG2 guideline, the Australian guideline AGPT02, and the MEPDG, which is used in the United States. So if you look at the climate, IRC takes into account AAPT, annual average pavement temperature, whereas SABITA takes into account of the microclimatic regions that is present. They basically divide it into 5 climatic zones and have some Waynard numbers which they use for design. And in Australian guideline, they have a weighted mean annual. The same average pavement temperature is used, but they give weightage factors for the temperature that is prevalent above your average value. And then in MEPDG, we have an extensive climate database wherein hourly climatic parameters are input for a minimum period of 2 years, which will be taken into account in design. And when you come into the traffic, the IRC and SABITA takes into account of equivalent standard axle load. What AGPT also takes into account is an equivalent load, but they call it as design equivalent standard axle. I'll be touching upon this later. And in MEPDG is where we have detailed consideration wherein, as I said, each axle type and each load group in an axle type is used for calculation of the strains. And when you look at material properties, IRC and SABITA uses resilient modulus, whereas AGPT uses flexural modulus for cemented layers and resilient modulus for granular layers. And MEPDG uses dynamic modulus for bituminous layers and resilient modulus for the granular layers. And when it comes to the evaluation of critical strain, in IRC we have at the bottom of the bituminous layer and at the top of subgrade. Whereas in SABITA, it is at the bottom of all cemented layers. If I have, like in our case, we can do it for BC and DBM, so like that. And at the top of all granular layers, AGPT takes into account of the critical strains for each layer. In fact, they do it for each sublayer. And finally, in MEPDG, they also do it for every sublayer within a given layer for all layers. So now with this perspective, we have to now look into this BSM, what this material is about, so that we can use the appropriate parameters in the design procedure. As we all have been discussing, it is a mixture of wrap, cement, emulsion, which has been discussed in detail in the previous lecture. The first thing is whether to consider it as a granular or a bituminous layer. For design purposes, we are going to consider it as a granular layer. If it is a granular layer, whether it is bound or unbound, again because of the usage of bituminous emulsion and cement, we are going to consider it as a bound granular layer. And what modulus is required to be measured? See, if you take the design procedure, we are only going to input modulus. It does not know what layer it is or what are the properties of the layer. It is ultimately characterized by the modulus. Only if you use an appropriate modulus, we will be able to get the maximum benefits of that particular design procedure. So identification and usage of correct modulus is essential. I'll show you what modulus we have used. And do we have an appropriate distress transfer function, which is that equation which inputs strain and gives you the load carrying capacity. Again, later I'll show you these equations also. So to start with, the design approach that we have followed here is a combination of the South African TG2. In fact, TG2 is the only manual which is solely available for bituminous stabilized materials. And we also have some inputs from Australian guidelines and also use something related to IRC also. And we have used Circly software here because of some advantages we have in this. The first one is sublayering. I was telling you how the modulus varies for each sublayer. To account of this modulus variation in a material across depth, this could be done through Circly, so we have used it. And we also can take into account of the anisotropic materials. When we are designing, we assume that the material response is isotropic for all layers. But actually most of the granular layers exhibit anisotropy, wherein the modulus in the vertical direction is twice when you compare it to the horizontal direction. So to account for this also is taken into account in Circly, and it helps us to calculate the traffic capacity or load carrying capacity for individual layers, so that we will be able to optimize the thickness of individual layers here. So now what are the design requirements in Circly? The first one is traffic data, climate, material properties, structural strength, design, distress transfer functions, and reliability. So let me just quickly go through all these things. First one is traffic data. They basically have something called as design equivalent standard axle. You can see here, there are two parameters there. The first one is ESA per HVAG. It's very simple. It is like how much is the equivalency factor for a given particular axle load group. The equations are given here, you can go through. Right? So that is the average number of equivalent standard axles per heavy vehicle axle group. If I take a particular axle group, what is its equivalency? It is averaged out considering different type of axles. And the next one is NDT, which is cumulative vehicle axle groups per vehicle. So if I take all my vehicles, consider the axles in all my vehicles, divide by total number of vehicles, I get this NDT parameter. If you take the actual traffic and if you do the calculations, it will work out to be more or less close to what VDF is. And Circly has an option wherein you can input directly this proportion. It will calculate this ESA per HVAG for you. There is not much detailed input that you have to input into Circly. So this is the table that I have shown is the input that you need. For each axle type and for each load group, what is the proportion? This total will add up to 1. Right? So this is the proportion that we have to input. And along with that, we should be inputting the number NDT, which is very simple. Take into your design traffic, calculate how many axles are there, divide by total number of axles. So that worked out to be 3.921 in our case. And climatic data, so the temperature values that we have an in-house air temperature, pavement temperature database that we had developed at IIT Madras. So we have used that climate database. the maximum and air temperature is given. We have a model which is a very preliminary model, but still we have it customized for India, which will help us to convert air temperature into pavement temperature. And then we, that is the pavement temperature for it. And also the annual average pavement temperature works out around to be 35 degrees Celsius. And it is a 4-lane highway wherein the 50th percentile speed is 44 km per hour. For 6-lane highway, the design speed is taken to be 40 km per hour. Why do we use this? We have to correct the bituminous modulus for the vehicle speed. That is why we need to know the average traffic of your highway. And finally, the material properties that we are going to associate with each layer. As I said, the granular layer is considered to be elastic and cross-anisotropic, wherein the vertical modulus, it basically has more load carrying capacity in the vertical direction compared to horizontal direction. So that is what it says. And the Poisson's ratio we consider to be equal for both cases. Subgrade, it is like what we do in IRC, measure the CBR value, use an empirical equation to get the modulus value from CBR. This is what even the Australian guideline says. We have used it again. And we have used a Poisson's ratio of 0.35. And for bituminous layer, they have some 4 procedures for the measurement of modulus. You can either measure a resilient modulus or a flexural modulus. We have measured resilient modulus using indirect tension test procedure. And this modulus value is corrected for 3 parameters. First one is the air voids, right? So we have an air voids which is in-service air voids that we observe in field. 2, what is the air voids that you have for a laboratory specimen for which you will be measuring the modulus. So this correction factor is taken into account. The second one is temperature. We all know the influence of temperature on modulus. And the third one is vehicle speed. Bitumen being a viscoelastic material, we have to take into account of the variation in modulus with the vehicle speed also. And other considerations, as I was talking to you about the sublayering concept, you can see here, this is an unbound granular layer of 475 millimeters. And you can see it is divided into 5 sublayers. In fact, Circly considers every layer into 5 sublayers. So you can see whatever modulus we are measuring is the modulus of the top sublayer of a given granular layer. So the modulus of the first layer is 500 and it is divided by the modulus of the subgrade to get that R value. So the modulus of the previous layer is divided by this to get the modulus of subsequent layers. You can see here actually the modulus of the first layer is, let's say, 500. The modulus of the next layer is 315, 199, 126, and you can see the modulus of the last layer is only 79. But typically we tend to use a uniform modulus value of 500 for all the layers, right? So this is one consideration which is advantageous when we try to use circling. And critical strains are calculated for each sublayer. So now these are the material properties. For BC, we measured the modulus, resilient modulus using indirect tension test as per ASTM D7369. For DBM also the same thing. The modulus values are 6,400 and 7,600 megapascals. For the bituminous stabilized material, we used ASTO T307. We considered it as a granular layer, so we did a triaxial test wherein we calculated the resilient modulus. It is about 2,700. But since we wanted to align with IRC and use the limiting values from IRC, we had used only the limiting modulus from IRC for design. And the granular base and subbase were calculated from a CBR value. We used a CBR value of 5% for the safer side for design. And again, Circly has also an option to calculate the strain distribution that you see. Like when you typically load, you can see here the overlapping of strains when you have a dual wheel. Or the second one shows the strain values between the wheel separation and the axle separation also. So it also helps you to visualize for different axle types what is the the strains. And we'll be able to get critical strains for each sublayer. And finally, we use it in the distress transfer functions. So we have the distress transfer function for subgrade, which is given in Australian guidelines, and for the bituminous layer. But what we did was, like, we did not want to use this because this is specific to Australian conditions. We wanted to use our own NF and NR equations, which are given in IRC. There are some constants which are given in Circly, which will help us to incorporate this. So we tweak those constants so that we will end up with the same NF and NR equations. Ideally, we should be having our own, we should be using our own distress transfer functions. For the BSM layer, there is no specific distress transfer function available except for that which is given by Sabita. It is called a Stellenbosch bituminous BSM function. You can see here it is a function of deviatoric stress ratio, which is the actual to maximum stress. the compaction level in field, and retained cohesion. Cohesion is nothing but what is the principal stress in the soaked condition versus unsoaked condition, basically the effect of moisture. So it considers all these things and it calculates the traffic capacity. But again, these things have to be revisited for Indian conditions now that we have started using CCPR. And there are two considerations which are given in CERCLI. One is the shift factor, which is like we have this equation based on laboratory materials, laboratory characterization, but when we implement it in field, there is a variability. So to consider for the laboratory to field variability, they have something called a shift factor. And we also use reliability, which we are again familiar with. We have equations for 80 and 90% reliability. They have different reliability values for different conditions. And finally, this is the input data that we use. So this is the pavement composition. And traffic data, we gave it as per CERCLI requirements, which more or less works out to be close to your VDF. Climate data, whatever we got for New Delhi. Material properties, which was measured or calculated as I had displayed before. Structural design was done as per CERCLI. Distress transfer functions, what was given in IRC. And reliability, again, we just use the same equation. So it is just for 90% reliability from IRC. And you can see here, this is the output that you get from CERCLI. For each layer, we'll be able to get, maybe I'll just show you this particular one. So for each layer, you can see this performance constant and performance exponent is what we tweaked in to mimic the same IRC distress transfer function. And then these are the thicknesses. You can see we get the critical strain for each layer and we are able to get the layer capacity. Now we can also do it in IRC. What is the advantage in doing using CERCLI? We will be able to better represent material properties, basically consider the anisotropy, the individual sublayer properties, consider for variation in modulus, etc. So then in that case, we will be able to better optimize individual material properties than what we will be able to do when you consider the pavement as a whole. So initially, to just check the design, we have aligned more with IRC and we have calculated all this. But once we have the values for all these things, we will be able to use CERCLI full-fledged with our own values and then optimize the performance of each layers. So that is from me. Thank you.
Thank you, Dr. Navita, for simplifying the complexities of structural design. So your presentation has added immense value for our understanding of CCPR engineering dimensions. We now open the floor for questions. So this is a great opportunity to clarify doubts, exchange ideas, and explore solutions to challenges you may be facing in your projects. Please feel free to address your questions to any of our presenters. Yes. Can you please give the mic?
Yeah, in the presentation, I understand that flakiness and elongation is the biggest, one of the main reasons for failure of the pavement. So when we recycle, how we addressed that? How we, again we use the same material. So flakiness and elongation of the aggregate, how we addressed and how we achieved the limits.
Okay, so like what your question is, since there is issue with respect to the shape of the aggregates that are used for bituminous materials earlier,
yeah,
we have kind of translated that to use it here, right? So basically, that is why if you look at the limiting factors that we have used. So for DBM, we have used only wrap in DBM. We have limited only to 25%. So that the overall effect of the shape will not be a problem with respect to the DBM. And BC, again, anyways, it's a virgin material, like virgin material. Whereas for like CCPR, which is again a base material. So there you have further relaxation compared to what you have for a bituminous material. That's how it is kind of taken care of.
Okay, thank you.
I have a question to Mr. Banoj. Myself, Sachin Joshi from Highway Concession 1. So first of all, congratulations to Cube team for taking up this initiative and doing one of the pilot project in CCPR. I seen in your presentation that it was an old road and you want to make it into 4 to 6 lane, and you did detailed investigation on the existing pavement, wherein you found that the CBR particularly was low than the required more than 8%. So did you do any improvement in CBR of the soil, or what technology you have adopted for improving that?
Thanks for the question, Mr. Sachin. So it's not a pilot project, like just to say, because it is about 90 kilometers which we have executed. Like to address to the fact, like low CBR, we have not done any stabilization because it's not kind of, it's very difficult to do a stabilization on a live project without disturbing the granular materials. But what we have done is like as part of the design. So that's where we have kind of factored in the low CBR in those locations where we have a lesser CBR, and accordingly the thickness have gone up. Let's say when we say we have laid about 110 mm of CCPR and 50 mm of DB and 40 mm of BC, that is an average thickness. But in some places we have went up to 150 mm, 160 mm of CCPR. So that's how it is kind of factored in, where by increasing the thickness of stronger layers, overall the amount of load that will be going on to the subgrade has been reduced, and accordingly it has been compensated in that.
Okay. So one more thing, that you said that in DBM you use 25% of the RAP. So mainly we have to focus more on the oxidation component of the existing bitumen component. So for that, what type of treatment you did?
So in first presentation of Dr. Reddy, he mentioned, right, like many of our roads fail very young. So if you look at the bitumen that we get from GIPL as well, it's very young. So we are talking about 5-year-old pavement. And the amount of RAP percentage that we have used is also only 25. It's not very high. So from that aspect, when we have verified in terms of is there any need for rejuvenating agent or something, we did not identify any need. So we have not used any kind of a rejuvenating agent in this. Thank you.
Hello. Yeah. My name is B.R. Tyagi, and my question is to Dr. Stephen. What is your opinion about the use of the polymer modified emulsion for recycling?
So thank you. That's a really great question. So it's really kind of back to engineering the emulsion to meet specific goals. So there's definitely some thinking along those lines. What if we were to use a polymer modified emulsion? So it could be using SBS in the base asphalt or even a latex type of modification to improve the emulsion properties, to therefore improve the mixture properties, to improve the performance. So in that case, based on the pavement structural design layer and the fact that for this specific project, you have a DBM and you have another wearing course, the value that you would get from the polymer modification couldn't really be justified. So in that case, in that project, based on the pavement structure, it's not, it wasn't the cost benefit wouldn't drive you to consider using a polymer modified emulsion. So, to your question, maybe in more general on other project, there could be cases where a polymer modified emulsion could be beneficial. We have projects where people are looking at using actually a CCPR type of mixture as the wearing course. So at that point, when you're really getting close to the surface and you're looking at specific properties related to especially cracking or in maybe cooler climates, then it could be a beneficial or something to look into. And again, quantifying it and making sure that the cost-benefit ratio is favorable. So in that project, that wasn't really there couldn't be a justification per se, based again on the specificity of this project. But in more general, that definitely something to consider. Thank you.
Yeah, please.
Dr. Stephen, good afternoon. A wonderful presentation and a great way for India to go. For SS2 emulsions, this is something new which has happened in India. The emulsifier that we use, India, it's very, very cost specific. So if we are left with some emulsifier, what are the areas where we can, utilize these emulsifiers? Because I am looking from a point of view that more and more such projects will be coming up and should come up. Therefore, we must know the alternate use of any stocks of such emulsifier, which is very, very costly, if it can be used, number one. Number two, what's your take on the shelf life? Because that's, again, very important.
Yeah,
Thank you.
Thank you, sir. Thank you again. I think, the scope of many projects, now people are more aware on the sustainability, so, coal recycling is definitely along those lines, but cost effectiveness is still a very critical factor. We have to build cost-effective road. That's, a very key requirement, and I'm glad that Mr. Banoche emphasized that in the case of coal recycling, it can be really cost-effective even compared to a traditional alternative. So that's great. Now, to your point, if we really want to achieve good performance, good quality with the right formulation, the right mix design, the right QC, QA, the right SOP, that's also very important to make sure that our investment turns out to be a successful venture. And back to your question, if we use this maybe higher end, higher quality, well customized emulsifier for this project, if we have leftover, what can we do with it? So it's really, the emulsifier can really make you an emulsion. In this case, again, customized for CCPR. But the emulsion, is very versatile. Being a mixing grade, you can use it for other application. For example, you could use it, and it may be a not glamorous, use, but you can use it as a worst case as a tack coat. I mean, that'd be maybe not. You could have maybe lower cost alternative for that, but that's definitely another option to use this emulsion as a tack coat. You can use it as also a fog seal to rehabilitate. If you have a project where you have some oxidized surface that starts to ravel, then you could use the emulsion as a fog seal. You can also use it to make probably some cold patch mixture. That would be, a very good way. If you have potholes, if you have local repairs that you need to have mixture that could be used for that, you can use the emulsion and make that kind of mix. So definitely, you can probably find other applications.
Thank you, Dr. Stephen. This is a live question which we are addressing in Cube Highways, and probably maybe it will give us an opportunity to work with you to come up with some solutions for this. We will work along with you to see how we can overcome this issue.
Thank you, sir. And sorry, I didn't answer your other part of the question, which was about the shelf life. So the good news about many of the additives that are used in road construction, would it be a warm mix additive, a liquid anti-stripping agent, or in this case an emulsifier, usually the shelf life is very long. It can be really years. So if it's especially if it's stored and properly, with not opening the drums or the container that the product is in, the shelf life is in years. So that's kind of, I guess, the good news. But the best would be to find a good use for it. Yeah. Thank you.
Thank you. The confirmed shelf life is 2 years, and we are taking action as per that. I know it can go up to 5 years, but we have to go as per the confirmed shelf life. So that's another issue which we are trying to address at Cube Highways. Thank you.
Thank you.
Okay. Yes. Please give the mic there.
My question is to Dr. Stephen. Hi. We just met outside. Yeah, I am Srinanda Banerjee from Innovative Roads Tech. My question is very simple, but I am unable to understand that in this recycling process, why only VG30 is recommended, not VG10 or VG40?
Yeah, great question. So I think I have an opinion, but I'd like to pass the question to the professor because
Sure,
he
sir.
really put a lot of thinking, and I'd love to maybe add
Sure,
more
sir.
at the end, but I'm sure he's going to cover it perfectly.
Okay, thank you, thank you.
Thanks, Stephen. So, sorry, yeah. Right. It's on. Yeah. In fact, in the rapid presentation that I made related to mixed design, we emphasized on few things. We did not want the emulsion that we designed to be of a very low viscous material. So you already have a wrap which has an aged binder in it. And we wanted to really bind all of them together. And we wanted to use more like an ASHTO opinion. In fact, if you go by JTG, the Chinese specification, they don't really tell you anything about, you could use a VG10 if you follow their spec. But what we really wanted was to use a VG30. We could have used VG40. But again, making an emulsion out of a refinery produced VG40 is a problem because we don't really get a refinery produced VG40 in this country. Let's make no mistake about it. If I get a VG40 which is produced from the refinery, making an emulsion out of it will not really be a big problem for anyone who has an expertise related to it. But sometimes you also get many things. For instance, you could add PPA, and in this case, the VG40 that you make may not necessarily work out well. So you don't really want to play fire here, right? So that is why we wanted to use VG30, number one. Number two, this is going to be, and we wanted to talk about the PG. So if I have to really talk about the PG, typical PG of VG30 that is produced in this country comes around PG64. So if you are familiar with the PG system, you are talking about 64 degrees centigrade, but this is way too below, like it's not in the surface course, it's slightly below. So that is why we just picked the VG30, but then we had Stefan's expertise in how to make an emulsion out of it based on the VG30. So that is why, he can give more details about the surfactant dosage, the manner in which we made it.
Yeah, but thank you for the question, because again, the engineered emulsion, one aspect is selecting the right base asphalt for the job condition. So as Professor Murley mentioned, that's an important step. And then of course, formulating the emulsion as far as the chemical package for how it's being used, taking into account, I'm sorry, I'm repeating myself, the workability and the cohesion gain, that's the other aspect as far as the chemistry itself. But you're right that the base asphalt is an important first step. And based on where the CCPR layer is in the pavement structure, based on the environmental condition, the temperature, that we have the tool to predict what temperature we get at a certain depth, taking the average 7-day high temperature of the pavement at that depth, the VG30 was probably a really good choice, and making a good quality emulsion.
Hi, good afternoon. My name is Mojibur Rahman from Norion Chemicals India Private Limited. So I have two questions. First question, I would like to ask Murli Krishnan sir. Sir, we have come to know that in terms of sustainability and cost effectiveness, CCPR, that means coal mix plant process, is better than conventional hot mix process. Sir, in terms of performance on the road surface, finally, which one is better? Yeah, are they close to each other in terms of performance?
I did not get the last part of your question. Can you please repeat it?
Sir, we know that CCPR, that means central coal plant, this is better in terms of sustainability and carbon foot reduction, and ultimately cost effective. CCPR is cost effective. But sir, in terms of performance, which one is better? Conventional is better than the CCPR, or CCPR is better than the conventional hot mix process?
For the first part of the question related to sustainability, I think we have a presentation by people.
Sippy will be presenting.
She will be making a presentation. As far as your second question is concerned, whether it is conventional. So now we need to understand where we are placing this layer. We are not placing it in lieu of DBM. Right now this is placed in lieu of the existing base course. There is already a DBM 50 mm layer, I think, right? No, in the new one. 50 mm, and then there is also a 40 mm BC. So as of now, this is, though we did a mixed design assuming that this will behave like a bituminous material, but we just pushed it little bit below. So the performance data, I think they are collecting it. I think there is a presentation related to, but this data is being analyzed. I am sure compared to the conventional one, since this is a stabilized, bitumen stabilized granular material or a bituminous material in base course,
yes,
I expect that it should give a much better performance, but this is a data that is being collected. So hopefully when we get the data and then when we publish it, we should be in a position to.
Yeah, thank you so much, sir. So, I have one more question.
Okay, so we are running out of time now. So
Dr. Stephen, you have come across various mixed designs of CCPR around the globe. Do we have, we have to use around 2.5% of water, I think, in the mixed design process. Does quality of water plays a role in terms of workability, in terms of mixed design of that coal mix process?
Absolutely. I think it is a wonderful question that you asked, because the reason why we are adding this particular water, what is really, we call it as pre-mix. So something like, you allow this water to penetrate through the material so that the emulsion could go, but at the same time, whatever, you are adding the cement, so the cement is going to start reacting with it. So whatever is the quality of water that you are going to use in a regular cement concrete, you are expecting to use the same quality of water in CCPR.
Yeah, thank you. Thank you so much, sir.
So before we close, one question for Dr. Nivita. So we have distress transfer functions in IRC 37 also. Can we use these functions for CCPR type of layers as well?
May not be possible, because each material, each mix type needs to have its own distress transfer function, because like if you have a particular strain in a given layer, how the strain converts it into the traffic capacity depends upon the inherent characteristics of the layer. In fact, even I forgot to mention, when we did the same design using IRC, we got a higher number of load carrying capacity for the subgrade. But then when we considered all these anisotropy and material properties, I forgot to show it when I was presenting, it was just safe. Okay, so when you consider different aspects of it, then you will be getting a different perspective. So I think we should get it, but as of now we do not have data, and we have to start collecting data. Maybe that is one request from my side to CUBE, to start collecting data so that we will develop distress transfer functions.
Professor Murli, just one clarification. From what you said, I understood that VG40 does not seem to be available from the refineries.
I did not say that.
Okay, fine. Because
I did not say that.
So
I said, let me complete. I said it is very difficult to determine the VG40 that I get in my laboratory, whether it is a refinery produced product or
modified.
Is it modified with any modifier? If I have to do that, I have to do IR. How many of you are here ready to have patience to listen to Nivita about IR?
Fair enough. Fair enough.
Because you are measuring only viscosity.
Accepted.
Yeah.
Accepted. Thank you.
Yes, please.
Sorry, a quick maybe added comment to the question about the comparison in the performance of a coal recycle layer with a traditional conventional. So there are actually quite a few studies, and later in the presentation I will be having, we did some test sections where we had actually side by side a traditional method, which is mill and fill, with a CCPR, coal recycling method with an overlay, and we can see that, again, if properly formulated, properly designed, properly constructed, the combination of the coal recycle layer with an overlay is a fantastic system that can perform equally or better than a traditional method. So both can be designed, both from a mixture, job mix formula, and also from a pavement structural standpoint. If properly done, you can achieve the goal that you have to achieve based on carrying the traffic. So it can be as successful as a traditional method if, again, engineered and constructed properly. So, and we have there's actually a lot of case studies showing side by side that the performance of the recycled section perform very well compared to traditional way.
Just to add, so the cores that are present here, this is for everyone. So the bigger core is the conventional crush that we have followed, BC, DBM and CCPR. The smaller core there, like whoever is interested can see, it's BC laid directly on top of CCPR, which is a trial section which we have laid about for 1 kilometer to see the performance with respect to how do we like traditional DBM BC and CCPR DBM BC and CCPR BC. How the performance is kind of observed in the field. We have laid a test section just for reference. Since the context has been like, you can see these cores.
I think that should answer your question. You asked what is the performance, right? That should answer your question.
Okay. So before we close this session, I would like to thank all our presenters for excellent insights and making this session very interesting. Thank you very much. So, yeah.
So with this, our first session, technical session of design aspects of CCPR comes to an end. Thank you, Bobin sir, for chairing the session. Thank you to all our speakers for the vibrant and engaging discussion. It is your curiosity and critical thinking that drive the innovation and adoption of CCPR. Now I would request Mr. Bobin sir to please kindly present the mementos to our speakers to express our gratitude. Firstly, we would like to thank Mr. Bhanuj. Please put your hands together. Next, we would like to thank Dr. Stephen Sharma. Next, we have with us our speaker, Professor J. Murali Krishnan. Thank you very much, sir. And we have with us Dr. Nivita M.R. Thank you so much. Also, I would request Dr. Stephen Sharma to present the memento to Mr. Bobin Kumar. Thank you so much, sir. Now we request all our speakers to please be on stage for a group photograph. Thank you, everyone. Thank you so much. So now, ladies and gentlemen, we will now break for lunch. Networking is an essential part of events like these. So I encourage you to connect with the fellow participants and speakers over the meal. We will reconvene promptly at 1:50 for the next session. Please ensure you return on time as we have more insightful discussions awaiting us. Thank you. Thank you so much. Ladies and gentlemen, we'll be resuming back at 1:45 p.m. We request you all to please be here by 1:45 p.m. Thank you so much. Once again, welcome back everyone. Very good afternoon and welcome to the Global Convention on Coal Central Plant Recycling, CCPR, organized by Cube Highways, Cube Tech and Mines, supported by IIT Madras and NHAI, partnered by WordGun Group, IOCL, OMS India, L&T and Bitcall. Once again, I request you all to please settle down, and also you're requested to keep your mobile phones on silent mode. Thank you. Well, I believe, hope all of you had an enriching session. The first session of the today was very enriching and you all had a refreshing lunch. Now we are moving towards the second technical session that is dedicated to the field implementation of CCPR, an equally critical and practical aspect of this innovative technology. This session will address the real-world challenges, solutions, and workflows required to implement CCPR successfully. While the theoretical understanding of CCPR is essential, it is meticulous execution in the field that determines the success of this technology. Today's speakers bring a wealth of experience and expertise to help us bridge this gap. Let us keep the discussions time-bound to ensure we cover all the topics. Should you have any additional questions, I encourage you to continue engaging with the speakers during the networking breaks. Without further delay, let's move on, where we are going to introduce the chair of the second session, Dr. Bhagwan Raju, COO, Cube Highways Advisor. Before we invite him, I would like to give a brief introduction about him. Dr. Bhagwan Raju holds master's degree in geotechnical engineering from University of Pune, a PhD in civil engineering from JNT University. He brings over 30 years of expertise in road construction, maintenance and toll operations. His distinguished career includes roles at Afcons, Soma Enterprise, Gammon Infrastructures and Ashoka Buildcon Limited. Notably, he contributed to the world-class road construction during a 4-year tenure with the Land Transport Authority Singapore, earning gold and silver awards for his Quality Circle papers. As a life member of IRC and IGS India, Dr. Raju actively shares his expertise, currently serving as Chief Operating Officer at Cube Highways. He oversees periodic maintenance, routine maintenance, incident management, and toll operations. Dr. Raju focuses on innovation, new materials, and cost optimization, emphasizing life cycle cost in road maintenance. With huge round of applause, let's welcome him on stage to lead our second session for today, which talks about field implementation of CCPR. Also, I would like to invite our speakers for this session. We are going to have together with us Mr. Arpan Ghosh, President Engineering Cube Highways Technologies. Please put your hands together. Mr. Sanjay Bajaj, Vice President Business Development, WordGun Group. Please put your hands together in inviting Mr. Rahul Kumar, Sales Engineer, Terex Finlay. And also we have with us our speaker, SN Srinivas Sharma, Head R&D and Technical Initiatives, L&T Constructions. Now over to you, sir. Please heading the session.
Thank you and a very good afternoon to everyone. So in this second session, in the morning session, we heard about the materials, the mixed designs, and the structural designs, and all these things. So that means the recipe is ready to go ahead with the CCPR. Now in this session, we will discuss about the implementation and the machinery that is used in the construction challenges and all these things. So in this, there are 4 speakers to cover the topics on the implementation of CCPR of the field importance of the SOP by Mr. Arpan, and then smart, safe and sustainable solutions for the road rehabilitation, and by Sanjay Bajaj, Vice President from Business Development Virgin Group, and Mr. Rahul Kumar, Sales Engineer, Terex Finlay, and on the sustainable road construction CCPR execution challenges, and Mr. Ishan Sharma, Head R&D Department in L&T. So he's going to cover the special initiatives in this R&D and the construction challenges. So before going ahead with the first presentation, I would like to introduce Mr. Arpan. He is currently leading the engineering department comprising of 5 sub-departments, namely payments, technical due diligence and the project management, highway design, structures and estimation, costing, and Arpan holds a postgraduate degree in civil engineering, MTech, with a specialization in transportation systems engineering from IIT Kanpur. He has more than 15 years of experience of working in over 150 assignments, which include transportation advisory, lenders independent engineer, pre-bid and post-bid assignments, and detailed designs. He has an experience of consulting assignments in India and abroad. His key interest areas include payment design, payment evaluation, deterioration modeling, payment maintenance management, evaluation of the payment materials, etc. He has also delivered the number of training sessions at IIT Noida, IIT Mumbai, IIT BHU, and for government and private industry professionals. He led the PMC team of 50 plus engineers for the world record of paving 112.5 lane kilometers in 100 hours in NH 34 Ghaziabad Aligarh section, in which today we are all discussing about the same. So in today's presentation, he will emphasize the importance of standard operating procedures in the successful field implementation of CCPR. His presentation will provide actionable insights into how meticulously planning and adherence to the SOPs ensure quality and efficiency, because that is very important factor in implementing the project successfully, without which no matter what is the design efficiency, so it is very difficult. So he is going to give you a detailed presentation on that. So now I request Mr. Arpan to give the presentation.
Good afternoon, everyone. Thank you, Dr. Raju, for the introduction. So my presentation topic will be on field implementation of cold central plant recycling and the importance of SOPs. So as we are mentioning in the initial presentations, when Banoj also presented, that typically this project starts from Ghaziabad to Aligarh, and we have important places like Bulandshahr, Khurja, and the project condition initially when we did the due diligence, everybody, Banoj has showed the pictures, it was pretty bad, and then when the actual construction started back in 2022, this was the condition of the pavement. So the challenges and then how we planned it basically step by step. So the challenge was to identify a technology which can maximize the utilization of RAP. So as we all know that cold recycling techniques, cold in place or cold in plant, are techniques where we can use maximum amount of RAP, because predominantly for using high percentage of RAP in hot mix, there are certain challenges. Higher percentage leads to some performance issues basically. So cold recycling allows us to use a lot of not much percentage of RAP basically. The second challenge was that there was a variation in RAP properties, obviously, because the road has failed in a very quick amount of time quickly, and then there may be some variation. So how to address that, how the RAP properties and the quality control can be ensured basically. So CCPR, since it is a very controlled process, there is a screening, there is then plant production and all those things, it gives a good aggregate gradation. Since it's a plant manufactured product basically, so it will have get precise control of percentage of RAP, virgin aggregates, cement, water, emulsion, and then we can also evaluate the product before it goes to the site for implementation basically. So this is the second way forward regarding the variability. The third thing was we have to be really confident about how it will perform, because the project was in a stricter timeline and there was no chance of again redoing the work. So the whole idea was that there was no time for rectification of failure, as we had a deadline already there as per the concession agreement. So to do, and then we have to design a mix which can withstand more than 70, even as Banoj said, it was like almost like touching 100 MSA. And then it will also have a rehabilitation measure which will disrupt, will cause lesser disruption to traffic, because it's already a 4-lane operational highway. You cannot close it for a very long period of time. So it called for a detailed research. So that's why a core team was formed with Professor Murli, Stefan, Asif, Dr. Nivita, and our own pavement team basically. And as Dr. Murli was also suggesting, we did a very detailed literature review to understand the industry best practices, because we were dealing with something which was never being attempted, so we needed to be 100% sure about that. So this was the main thing. So typically it comes with wrap characterization, emulsion processing, then determination of design gradation, determination of optimum water content, determination of optimum emulsion content. So whatever things which we did in the lab, the whole idea was to translate it in the field basically. We had some lab properties of ITS, dry as well as wet, and so we wanted to replicate the same thing, the same methodology which was followed in the lab to the field. So if I talk about the variabilities, we had to do milling, we have to do wrap processing, we have to do emulsion production, we have to do CCPR production, we have to do all the routine tests, and then do the laying, compaction, and curing basically. So these were the multiple processes that needs to be followed. So we had critical processes. All those critical processes, we have multiple stakeholders. We have our design team, we have a contractor, we have engineers, we have machine operators, we have independent engineers. So there are multiple stakeholders involved. And then there was zero tolerance for mistakes basically. So the whole need was that we needed an SOP basically. We needed an SOP because when there is a lot of these critical processes, stakeholders involved, and we don't need mistakes, we need an SOP to be absolutely sure about the process. So what we did, even we had a very detailed discussion with Stefan, Dr. Murlian. We created a document which is called Guidelines for Construction of Pavement Layer Using Bituminous Stabilized Materials by Coal Central Plant Recycling. This was a proper document which was prepared and discussed with L&T and all of our team. And this was discussed and this was presented with them so that every stakeholder is aware that what is going to be done in each and every step. We also created a poster, basically. We also created a guidelines poster, and this poster was present in all the laboratories, all the site offices of L&T, ensuring that all the technicians, engineers were aware of what are the steps, what are the processes to be followed, basically. So starting with the first component was milling and wrap processing. So the milling of the bituminous layer was done since the pavement was extremely cracked. If we do a milling in a very unscientific way, there can be a lot of chunks which is of no use because we need a particular gradation to be followed. So the speed of the milling was such that it would avoid a larger chunks. So we kept the speed to 4 to 6 meters basically. So we had a lot of deliberations at site with Regent's team, and they came and then they helped us in adjusting this, and then the PMC team at site was monitoring the speed. You can see that from the image it was 4.4. Similarly, we are monitoring the milling speed because the milling speed was very, very critical for the wrap production which was coming. The second thing was wrap fractionation, which is absolutely necessary if you want to do any recycling project. So we fractioned it in 3 fractions, 0 to 6 mm, 6 to 12, and 12 to 26.5 basically. We took special care that it was not contaminated with any other aggregates. The stockpiling was also kept to a height of 3 meters basically, and the moisture also was controlled because it's a cold mix with water is also being added, so you need to constantly check about what is the moisture present in the wrap. So typically these were the key points to be noted during the wrap screening. So these were our 2 plants basically. Section 2 and section 3 has a McCloskey plant basically, and section 1 has an electric plant because section was coming under NCR. So NCR you cannot use diesel plants. So Terex provided an electric power screen, and this is how typically the unprocessed wrap was stored, and then it was segregated and screened in 3 different fractions basically. There was some amount of chunks which was also produced. We initially did some trial with a horizontal shaft impactor for crushing of wrap, because crushing of wrap is not very common in India, but we also had a very small trial, but predominantly we used the screen material and then the wrap, the chunks we did some kind of a post-processing where we can recrust it basically. So this is the whole video of how the whole, these kinds of plants, there were 3 plants in 3 of the base camps of L&T. Typically this photograph is taken from the video by L&T. So we had a coal bins, we had the cement silo. In the coal bin, you had 3 bins for the wrap and 1 bin for the virgin aggregates. Then we had the cement and then the emulsion. And then we have a feeding and a pug mill where all the material used to be there. So the whole idea was the CCPR plant should be capable of mixing the aggregate wrap, virgin aggregates as per the proportions. We also specified that there should be some tolerance limit in terms of each ingredient. So those kinds of controls should be there basically. And a specific flow chart was determined during the lab trials that this should be the sequence. The wrap and virgin aggregate should come first, then the cement, then the water and the emulsion. So accordingly, the pug mill was designed in such a way that the wrap and virgin aggregate was dosed, then the cement will get dosed, then the water, and last as the emulsion will get dosed basically. So the key points was that nothing should be added after once the emulsion is added, and the emulsion monitoring should be proper. Even what Stefan was showing in the picture initially, when you take the mix in your hand, the emulsion is still not broken down basically, and this is how it should, the mix consistency should be basically. Then we had proper, in the SOP we have written down examples of how to determine a water content and then what should be the variations and all those things. Suppose if your mix is absolutely dry with 0 water content, then with the water in the emulsion and the pre-wet water content on 2.5, you arrive at a 3.83% of total fluid content basically. And you can vary between 5.83% to the maximum and 4.83 to the minimum basically. And then if the moisture is getting more than 2%, the pre-wet water could be accordingly adjusted. Then comes the transportation and paving. We adopted a standard 3-point loading system. The existing WMM top was cleaned, then you applied a prime coat basically, and then used to cover the trucks, do the prime coat, and then proper laying. The recommended paving was done typically 3 to 4 hours after mixing, typically within the initial setting time of the cement. The compaction criteria, initially there was two types of pneumatic rollers. Basically one is a double drum roller, 12 to 15 ton total weight, 1 static passes and 2 vibrating passes, and then a PTR roller, 6 to 8 passes basically. So initially in the SOP there was a soil compactor which was also introduced, but there were some execution challenges. The material was getting stuck to the tires of the soil compactor. So based on the discussion which L&T has given us and their suggestions, we have modified this, and this came out to be pretty well. Then we used either a sand replacement method or a nuclear density gauge method to determine the compaction parameters. So L&T had deployed 3 trained and authorized or licensed engineers who are allowed to use these nuclear density gauges. So we are using that for a speedier checking of compaction. This is how we monitor the quality. We created a dashboard where you can see, you can select 3 project sites. We could select the CCPR layer, and we could select the year, which year, 2020 to 23, 2 years we did. And if we can select the month, basically, then all the data of typically our dry ITS, wet ITS, air voids, FDD, compaction, week-wise, we could get the data, and then how much sample is passing and failing. So typically, we have collected all the data basically. All the 3 sections had a laboratory, and it was all the data. There was a full-fledged team from the PMC side. So there were 2 people in the lab in each site, and there was 1 person in the plant to monitor the emulsion dosage and other things and check the mix quality. So there was a proper quality control between in the lab as well as in the mix plant to ensure that we get the proper quality. So this is how the reconstruction happens. So there was a reconstruction with and the old pavement, then reconstruction on CCPR, and then the DBM on top of it basically. This was the stage 1. So typically the scope, what we decided is, let us first make the 4-lane motorable. So we targeted the 4-lane first, and then started with the widening so that at least the traffic movement could be smoothened. So the strategic call was taken by the GAPL team that we'll do a four-laning or the rehabilitation of the four-laning first and then do with the widening. So this is some pictures of the photograph. And this is how the six-laning thing was happening. So we widened and then we are doing step by step basically. This is you can see the old pavement, how much it was cracked, and then the cold recycling and the DBM widening. Then after we did the BC, it was looking like this. So this is the full 3-lane width of the pavement actually. So these are some before and after pictures. So same location, before and after DBM, these are the pictures which we have taken basically. So this was there, and then that's it basically. So I will acknowledge Dr. Reddy, Dr. Murli Krishnan, Stefan, Dr. Nivita, Mr. Neeraj, Naveen and Manish from L&T, Vision who helped us for the screening, Ridgen who helped us with our milling. Amarjit was with us and he worked extensively for the mixed design as well as the initial post-processing data collection, and he's currently doing his PhD at Arkansas, and Dheeraj along with Amarjit. Then from GAPL team, Mr. Avdesh Sharma, Mr. Ishu, Sudhanshu, Vishal, Banoj, and Janmajay basically. And from my bitumen team, Vipul, Shamim, Thilai, and Devinder, and Kamlesh, Harish, and Rohit for the entire PMC team at CubeTech was there at GAPL. So typically we had almost like a 35 people team at GAPL who was constantly monitoring the entire construction process. The SOP and the team is very, very critical for implementing the project because we need a very stringent monitoring on each and every step basically. And then it has been 2 years. Till date we haven't seen any defect and deficiencies, and it has been performing very well. So that's all for my presentation regarding the implementation. Thank you.
Thank you, Arpan, for a very insightful presentation on the SOPs, because SOPs are very much essential for a successful implementation. Now I'm going to introduce about the second speaker, Mr. Sanjay Bajaj, is the Senior Vice President, Business Development, Virgin Group. So Virgin Group is the market leader in road construction, road rehabilitation equipment and technologies, catering to both flexible payments and rigid payments. Mr. Sanjay Bajaj joined Virgin Group in 2007 and has served in various leading roles and functions. He has over 25 years of experience. Prior to the joining Virgin Group, he has worked with major capital and engineering companies in the past. Mr. Sanjay is the member of IRC Mechanization Committee and is also involved in the IRC in various committees. Mr. Sanjay has played a vital role in bringing new technologies like cold milling, stabilization, and recycling of pavements to India. Under his leadership as a product head in India, the world record of highest concrete paving was created at the Delhi-Vadodara-Mumbai Expressway. Sanjay Bajaj, with his valuable overseas experience, has helped in setting up the design parameters for both cement and bituminous-based stabilization. He has played an instrumental role in convincing the MORT to adopt stabilization payments, which has helped our nation not only in saving our natural resources, but also achieved a fast-paced road construction. So Mr. Bajaj is an engineer, holds master degree in management from IMT, Ghaziabad, and has also studied at Indian Center of Harvard Business School. In today's presentation, he is going to give presentation on the role of the construction of sustainable infrastructure, mainly emphasizing on the recycling technologies and state-of-art machinery to effective construction practices. Mr. Bajaj.
Good afternoon, all. Thanks, Mr. Raju, for that introduction. That means a lot. Reddy Sab, distinguished guest on dais, leadership team from Cube, colleagues from industry, friends, ladies and gentlemen. Thanks you for giving us this platform. It means a lot to us. Thank you for considering us your partner. My name is Sanjay Bajaj and I work for Vidgin. And today, on behalf of my company, Vidgin, and my team, I would like to present you on our experience on recycling in India. Largely, since the topic is cold, so I'm restricting myself to cold recycling. And I'll move with the presentation, which is here. Arpan, you can help me to run this. Yeah. So who we are a part of John Deere Group, an American father, mother, and a German kids. We were acquired by John Deere 7 years down the line. John Deere today is a $51 billion company. And Vidgin comes under construction forestry, which is close to $10 billion. We are based, headquartered in Germany, and we work in all the aspects of roads, starting from crushing to the final paving, including rehabilitation, compaction, hot mix plants and all. So we complete the full circle in terms of road construction, start with, and rehabilitation to end with. Okay. India, we are part in India. We have a big presence in India near Pune, where we have a huge factory. We export to almost 87 countries today, and we employ close to 800 people, and we are the market leaders, not only in India, but also from India to the world market. Big setup here, how we serve our market India and export to 87 countries now. All right. I can't miss sustainability part of it here. We have been doing that. So by 2026, we'll have 42 machines or products which will be either emission free or will be very, very low emissions. That's a path number one. On a sustainability goal, we have kept it. Mostly hybrid or electric driven machines. And by 2030, we want to work with the Team India here, Work India, to reduce environment footprints in India, reduce emissions by 50%. That is in scope 1 and 2. And scope 3, we want to put on 30% upstream and downstream. That's what we are working on currently today. So what is Vidgin's group approach towards this? One is powertrain solutions, what we are working on, a machine part of it. And that's where our core is. But can we extend it to market? Answer is yes. How do we work with our customers, contractors, concessionaire partners, help them to reduce their carbon footprints? Recycle, do more with less, that's a concept. And one of the biggest tool what we're working now is on connected job site intelligence called digitalization. So that's how we operate here. So let's see in the background, there have been a lot of talks in NHAI. I heard in the morning Mr. Chairman Saab, then I heard Sanjay sir and professors. If I look at it, it's a bit confusing. We are talking about various authorities, industries, concessionaires. The topic has been hot, conventional, and new, so-called new, not so being acceptable, called BSM. Professor Muli talked about it. What is BSM? Thanks for the encouraging session, sir. And what are these benefits? What do we gain out of this, both in environmental as well as economical solutions to end customer? It has been a roller coaster ride for us. I mean, we started this in 2011 before the IRC guidelines came in, and thanks to IIT Madras, Professor Viragwan and Dr. Mulli, again they helped us there with L&T when we did the first project, L&T IDPL. So what to use when? Our wisdom, our experience wisdom says is use the hot mix for the top layer, keep it there, but use everything else in the so-called, we can call it sub-base, base, whatever norm, we can name it, DBM, part of it, BSM, in-between material, and they offer different parameters in terms of the defined levels of technical aspects. Fine. So one is very clear, you need the top material for surfacing material and need the ideal for base layer material and reuse the same back into the ecosystem. And structure equivalency is almost 1.25 BSM equivalent to 1. That's again coming from Sabita guidelines from Stellenbosch University. So what has Vidgin got to do in the whole scheme of things? So we look at the whole scenario. We have a hot recycling concept, we have a cold recycling concept. Both again in situ, in plant, and that's where we play around. We come in with the experience of machines and a little bit of knowledge on the ground. Yeah. So we can talk about CTB, FDR, recycling, BSM, foam, emulsion, separated, clearly categorized. Cold recycling to me personally is very convincing because I see it worldwide, coming back from China last month or in Europe a couple of weeks back. But China is far ahead of us in acceptance of so-called sustainable technologies, not even US, sorry for the disagreement, colleagues, and not even Europe. Europe is virtually looking for the market outside. In China, they have decided to 100% recycle their existing resources completely. Answer is completely. And since we're able to cut down CO2 almost by 60% by cold recycling, largely more, it helps us reduce, transportation, logistics, and associated emissions. And of course, the shorter time, which you have set an example, benchmark, congratulations once again. And of course, the answer is given that it's more durable. So we are designing that on. We heard from Dr. Nivedita how to design the pavement. So it's durable, it works, right? What it is, how the work looks like, the concept, it's somewhere in between. It's not fully bounded, it's not fully unbounded. It is partly with bitumen, a little bit 1% with cement. Cement acts as a filler for better dispersion of foam or emulsion. And then you get back into stabilized mix we're designing for 800 megapascal, though in the lab values are much higher. So that's how the whole concept comes in. Though in our design parameters, we are designing as one of the pavement layers, right? That's how the concept is. So when I talk about it, how it works, so the scenario very simple. You either mill off complete asphalt, recycle in situ or in plant as per the situation, and 100% goes back to the pavement and seal with the hot top layer to get your levels done. So no FRL raising, no curbstone going up. And of course, you get the material back and everything is sent back to the ecosystem. So what have been solutions from Wittgen Group? We have 3 solutions: in situ, treat and place. That is what we did in Jaipur, Mahua with you. Actually, India, we have largely done in situ more than in plant. Then we have in situ treat and place with inbuilt paving system. That's a new innovation we bring to India now, coming next year. And KMA is in-plant treat and pave with a separate paving arrangement. So all 3 gives you different flexibilities, different solutions, right? So this is a typical schematic when you do in situ, but place it there. Don't use a grader later on. But then we have challenges there on the levels and all. But then what comes next is you have the very interesting slide on the screen. You mill the asphalt, bring it to a plant, KMA, a cold recycling plant, what you did exactly at Aligarh, Ghaziabad, and recycle it and then pave it back. So whole ecosystems get complete. So we have the full solution here, and that's how it works worldwide. Yeah. This is the other solution what Chinese are using more and more. They recycle in situ and they pave back in situ. What happens is in our WRs or wheeled recyclers, we had the material to be left there and then grading is done. But the new solution from Wittgen is that we recycle, send back to a paver behind, and it's paved to the profile and the width and the depth, you can control it. So considering 3.5 meter width, you can do full in one pass or you can do selective working solutions. Yeah. This is catching up more and more, both in Upper Asia, I would say, and also in Latin America. Brazilians also on the run with the recycling one. Yeah. So the answer is simple. What you scarify, you send back, and the numbers are very, very encouraging in terms of material saving, emissions, and of course, time, and the numbers add up to dollars. Yeah. Okay, India. We started in India in 2012. The first experience, big highway was ITNL. They were the big concession company, Baroda Halol. And then the second biggest or jointly was L&T IDPL. Some impressions on the table. Actually, Professor Viragwan and Professor Murali Krishna helped us there. First big project, 87 MSA. And here we recycled in situ 180 and asphalt top was only 50 millimeter BC layer. And proof is that even today the section works very, very well. So it's all how well we design it, how will we execute it, how will we work on this. So overall scenario has been very encouraging. Yeah. So some impressions about Indian market scenario from last 12 years. So starting from, I would say, 20 MSA to 180 MSA, with CRI, Dr. Ambika, we worked in India's busiest highway, 180 MSA, that was in UP, Varanasi, Aurangabad. It worked with Soma Isolux was a concessionaire, so also works very, very well here. Yeah. So that has been a scenario largely in situ for us. Yeah. So overall, I would say, upon with your numbers put together, we are close to 5 million square meters of coal recycling in plant or in situ put together. So that's a decent base we have as a technology acceptance or adoption in market India. And this is the project recently, 2 years back we worked on how the in situ works. The pictures are here. We recycled in situ, cement, bitumen, working in situ, pulverizing and recycling, yeah. Moving to coal in plant, we have actually 3 big players who use Whitgan. Of course, the project done by Cube is the biggest in terms of magnitude. But GR Infra, then we had Oriental, they use it extensively. Itawa Chakeri, then West Bengal, then in UP. So we have in-plant references and very decent done. Yes, you have comparatively much better selective quality control in terms of when you work in plant. But also the same case also happens in situ also, but depends on the type of crust, the material, design, our approach and execution. It's a combination of not only equipment, but a lot of things, So and surprisingly worldwide in situ solutions are 90% acceptable than in plant because of the logistics part of it. There's nothing else. The logistic cost actually add up to your node project cost. So that's one. So some pictures, some impressions. In the short of time, I will skip this video. But this is in plant. So this is a big concept in US, China, and Brazil. In situ with PAVE, because I think this is what India will look at it going forward, and we are getting ready for this. So solution is simple. We mill, recycle, do in situ, and the belt conveyor loads back to a paver, which can be paved to the profile and thickness, and it's very, very, I would say, it's a down cut. So it generates more fines, and then you also eliminate sometimes the addition material requirement, and result is fantastic. Performance is almost, we're doing almost 1 lane kilometer a day plus, depending on the logistics and all. Yeah. So this is what scenario I want to share with you, how Chinese are doing this. These impressions from China last week. They recycle the top asphalt layer in situ and hold it on a job site with either tippers or in plant, or if stockpile the BSM, we can stockpile the BSM foam for 7 to 10 days, no problem. Same time, they are recycling the base with cement. It's already CTB. They're adding more cement, and then that gives them a stronger anvil to compact, and they pave back the milled asphalt back and sealing with 5 or 6, which is 6 centimeters of asphalt. And they're very successful. And what my colleagues in China told me that as of August this year, they have recycled more than 70,000 kilometers of highways in China, and that's getting a norm also there. Yeah. So this is how the benefits of in situ are. I'll just take a short animation video before I end my presentation. So this is a concept proof what we have put together. I know I'm running short on time. 1 minute left.
In the downcut process, the milling and mixing rotor operates in the recycler's direction of travel. When cold recycling with bituminous binders and cement, a Streumaster binding agent spreader pre-spreads a layer of cement. Computer-controlled metering feeders ensure highest spreading accuracy. The spreader is followed by a water tanker and a bitumen tanker. The recycler takes in water and bitumen via connected feed hoses. The powerful milling and mixing rotor with a working width of 3.8 meters operates in downcut mode, thus controlling particle size and preventing the formation of chunks. Microprocessor-controlled injection systems guarantee the precisely metered addition of bituminous binders and water into the mixing chamber. The pre-spread cement is mixed in at the same time. The recycled homogeneous construction material is fed via the discharge conveyor directly into the material hopper of the Vögele paver following behind, which then places it, achieving high pre-compaction values. The final compaction is performed.
And then we use both emulsion or foam to do this, and there are a few benefits, we all know about it. What it helps us to save environment, emissions, transport, logistics, and of course the cost. So, just a small data. We worked up the team. If you do recycling, numbers are on the screen. I think this is no-brainer. But as a country, I think we have to accept more green technologies. Today, the challenge still remains convincing NHAI or IEs or the policy. Thanks to Q for taking this forward, and it's really appreciated work. And this conference says all. Last slide, in case anybody here is looking at 100 MSA design and this is a solution, the most economical, both in terms of technical and commercial solution, is proposed here. Yeah. And thank you very much for your attention. Appreciate this. Yeah.
Thank you, Mr. Bajaj. As you all know, Virgin is well known for the delivering a state-of-art equipment, because without this type of advanced technology, it is very difficult to implement the new innovations in the payment implementation. Really, and as per the messages given in the morning session by Chairman Sir NHAI and our Chairman Dr. Harikishan Garu, it seems there is a lot of scope for the CCPR in future. I think you have to really scale up your business to produce more and more state-of-art equipment. Thank you. More recycling. Yeah, recycling. Yeah. Yeah. So now come to the another third speaker presentation on the wrap crushing by the impactor by Mr. Rahul Kumar, Sales Engineer, Terex Finlay. So Rahul Kumar is a dedicated professional with a strong academic record in the engineering. He did MTech in mineral processing from IIT ISM Dhanbad, and his academic journey has equipped with a solid foundation in mineral processing, allowing him to explore advanced technologies and industry practices. So he is going to cover on the key issues of the wrap crushing. Generally, after milling the material from the existing pavement, so we used to get the lumps. So how those lumps and all these things can be processed to actually put into the plant, and he is going to cover up on these key points. Now I request Mr. Rahul to give his presentation.
Hello, good afternoon everyone. My name is Rahul Kumar. Thank you, sir, for the brief introduction about me. And myself, Rahul from Terex India Private Limited. I take care of Finlay division for hybrid crushing and screening for North India as well as northeastern part of India. And I'm going to discuss about how the crushing improves the material quality in this wrap processing. So firstly, about the Terex, I'm going to leave you all with a short video. If it is played. Just a second. Is this playing? Yeah.
Sometimes purpose begins quietly. It starts as a thought or an idea. It's a small stone or a gear in a machine. And when a few small elements join together, it all begins to grow. It becomes a commitment, a reason for doing things. Our promise begins with our commitment to serving people and communities. Our team members are making a difference in the world. We are helping to build our cities and to leave them more sustainable than we found them. Our products are designed to help the health of our planet and repurpose its precious resources. We are taking the world to new heights, and helping rebuild. We are focused on zero harm safety at every step of the process, from the factories where the machines are built to the job sites where the work comes to life. Our commitment doesn't just benefit our customers, but also sets a standard for safe work around the world. Every team member in every community we are a part of contributes to the success of Terex. We lead by example in our industries and with every interaction every day. And we do it with integrity, always guided by our Terex Way values. At Terex, our greater purpose is clear in every part of the business: to help improve the lives of people around the world.
And this is the video which shows about the purpose of Terex. Now, Terex India Private Limited is under the Terex Corporation, and it works under material processing, which is one of the consistently highest performing portfolio of Terex Corporation. If you look at the manufacturing and parts location, these are all the locations in which the manufacturing of our plants happens. In Asia, in Hosur, Tamil Nadu, we have the biggest plant where all the crushers, screens, and as well as the conveyors are getting manufactured. Now, coming to the topic of wrap processing, basically we have already discussed about these things and all, just a little bit from my side. That wrap processing involves breaking down of reclaimed asphalt into reusable material. There are various equipments used. Already sir has explained about the milling and all. This next part after milling comes to the crushing part. The initial step of wrap crushing, there are different types of crushers in the market like jaw crushers, cone crushers. But the impactor that Terex gives, or any company, which is the most efficient way of crushing a wrap, because it crushes the chunks of asphalt with impact, so that the bitumen and as well as the freshly cut surfaces, also in next slides, it gets separated equally and uniformly. Then post crushing, we have the solution from screening also. Terex has 2-deck screen as well as 3-deck screen to get the product out of it, to separate coarse as well as fine aggregates from it. Then from after crushing and screening, there comes the main portion, which is stockpiling, because stockpiling is one of the most important thing to prevent from contamination and segregation of wrap materials. So we have the 2 different types of conveyors that I'll show you, radial as well as track mounted of conveyors. So wrap crushing by Terex impactor. I'm going to discuss about this one. So why wrap crushing is required? Wrap crushing is required to meet out the cost efficiency, because it reduces significantly the requirement of fresh aggregates as well as the asphalt binders. The other useful impact of this crushing is to reduce the environmental impact, because if you are going to use the fresh aggregates, then it has to be somewhere mined and somewhere quarry has to do the crushing and all. So it increases the environmental impact for that one also. So to reuse the wrap, we are going to reduce the quantity of fresh aggregate, and which significantly improves the this environmental benefits. Next point is performance improvement. Properly crushed wrap retains high quality of asphalt and aggregates, thus increasing the performance of further in the CCPR process. Then operational flexibility, because after crushing we have an operational flexibility to separate the material as per the size, whatever is required as an end product. So we have an operational flexibility to do it. So this is one of the impactor animation that I'm going to show you how this crushing happens, and where we are going to do the this feeding and all, everything I'll explain you. This is one of our impactor in which the feeding has been done with the help of excavator to the hopper. I'll show you the material flow in the next slide. And this is completely mobile. You can take this machine directly to a site where you require crushing, do the feeding and all, everything will be crushed. And the most important thing is that one, it consists of a single deck screen to same chassis, which is like a removable portion. And this conveyor that you are seeing is a recirculation conveyor. Suppose if you want to recirculate the material after screening, you can do it directly from this. You don't have to do manual take out from a bucket loader and then again you have to make a stockpile, then feed it. No. Directly this recirculation conveyor will recirculate back to the hopper. I'll show you the videos and all everything. So how exactly the material flow happens in impactor? Firstly, the first impact of the material come in hopper, where the excavator will feed the wrap material to it, and then it consists of a feeder which make the material flowable, and it goes to a first hand grizzly. The first screening happens over there, and you can see that there is a bypass conveyor over there in which the material, suppose if you are going to do the cut size of say 20 mm, then the minus 20 mm from the big stockpile will come out from there. Then further it went to a chamber, impact chamber, where the crushing happens because of impact. There will be a shaft which rotates horizontally in approximately 1500 RPM. There are two set points. One 1425 to 1525 range of RPM, and second, it depends on the feed material that you are feeding. The second range is 725 RPM to 1825 RPM. These are set according to the feed material that you are going to feed it. Then after that crushing, it came out of the conveyor and we have a stockpile of it. And the size of the stockpile and the product quality can be maintained with the help of CSS, say close size setting. And you can see that there is an impact chamber over there where there are two percussions. That percussions are hydraulic cylinders, and you don't have to do it anything manually. You just have to go over there. The HMI panel is there in the machine. You just have to say, okay, you want to have a size less than minus 40. You set the CSS to 40 or 50. Accordingly, it will produce the material. This is the impactor chamber video, which is one of the important thing to know, that how crushing happens inside the chamber. Suppose you are going to feed the material from directly from the hopper, it went inside to the chamber. So inside the chamber, there is a rotor which has a 4 blow bars, too high, too low, usually which we prefer for wrap trussing. This is the rotor that you have seen in the locking mechanism. And all the change of blow bars is very efficiently done with the help of a hang pulley, which is over the head. This is the blow bar lifting tool. Suppose your blow bar has already been worn out, then it has to be removed from it. So with the help of this lock and pin mechanism, we can directly take out the blow bar and just reverse it and then put it. I'll skip this video because this is the rotor that you have seen. That material come over it. The rotor will direct the material towards the chamber. There are liners in the chambers where it get impacted and get crushed. So this impactor has been used in the same application in Aligarh Ghaziabad highway project, in which the maximum feed size of wrap was 330 mm, and the required size is minus 26 mm. And the capacity that we are getting, we have done the belt cut method, in which we have taken a sample of 1 meter of this material from a conveyor, product conveyor. Then with the bulk density of it, we have multiplied it and we have got approximately 150 tons per hour in minus 26 mm after recirculating plus 26 mm back to the hopper. So this is the feed material, and you can see that 60% of the feed material is less than 100 mm at the site, and maximum feed size was roughly around 330 mm. So the output required was minus 26 mm, which you can see in the image. There was also a trial happened at that site by putting a wire mesh of 40 mm, saying that how the aggregate came out if we are going to put a wire mesh of 40 mm and increase the CSS of the impactor. So this is the image of the product output getting out of the impactor when we are going to increase the CSS for plus 40 and minus 40 mm of output. There was a joint visit by Murli sir, Arpan sir, as well as Bano sir at our site, including L&T people. And they have found out that there in minus 26 mm stockpile, it usually consists of two different types of these chunks. One with the bitumen and one with the freshly cut surface. So Murli sir has said that we have to reduce the freshly cut of surfaces. So we have done a CSS setting, and it has been done hydraulically to optimize this one, because we don't have any control over that one, because it is crushing with the help of impactor. And based on the RPM of that one and based on the crushability of the wrap, it crushes abruptly in the chamber. So we have to minimize as per the guidance from the Murli sir, that we have to reduce this freshly cut. We have increased the CSS, then decrease, then we have found that optimum CSS to maintain it to use as an end product. So this is one of the video of the same plant running at the same site, in which plus 26 mm was recirculated back to the hopper, and fresh 330 mm of the boulders is getting feed. This is the recirculation coming back to the hopper. An excavator is feeding from top this fresh wrap. And this all went to the impact chamber that we have shown, that how then it got crushed and single deck screening happens afterwards. After crushing, the important portion is screening. So Terex also provides two different types of hybrid screens, which can be operated both on diesel as well as electric. So we have 2-deck screen. This one is 2-deck screen, which is having apron feeder, which is of a MS steel, and whatever size it can take up to approximately 500 to 600 mm of boulders, you can directly feed it. And it will segregate as per the wire mesh sizes into 3 products, because it's a 2-deck screen. This is just an animation video that how it is folded to a transportation position. Second, I'll go with the next one. Oh, sorry. After screening, we have 2 different types of conveyors also. First conveyors that Terex offers is radial stockpile conveyors, which will move 60 degree left side and 60 degree right side, maintaining a 120 degree of a stockpile continuously to increase the capacity in a single go and to reduce the loader cost. Because if you are going to do the simultaneous stockpiling with the help of loader, it increases the cost per ton. So for that one, these conveyors are deployed to the customer sites. The other type of conveyors which we provide in India is track stockpile conveyor, which is having an engine over it, which can be operated with the help of diesel, and it can move in a single direction as per the requirement. Because since our earlier machines is also a track, so it can be moved alongside to maintain the stockpile. That's all from my side. This is all about the crushing and screening and conveying. Thank you.
Thank you, Rahul, for giving a wonderful presentation on the wrap processing. I think you have seen how the wrap looks like after milling from the existing pavement. So unless it is properly processed, you cannot get a consistent mix, so which is very important. So now let us go to the last presentation on the sustainable road construction, CCPR education challenges, by Mr. Srinivas Sharma, Head R&D and Special Initiatives. Mr. Srinivas Sharma is a civil engineer, hails from Hyderabad. He is having 33 years of experience in various highway projects from 1991. His career started with KMC Constructions. So in the construction, he has been involved in quality control and in most of the Indian projects, and so he has been involved in the execution of different roles of site engineer, section in charge, and resident engineer also in the highway projects in Andhra Pradesh. His passion for material engineering, quality assurance, and control taken him back to the quality function, and a lead as an in charge for the projects such as Satara Kolhapur Road projects, Hyderabad International Airport, Mumbai Monorail, Hyderabad Metro Rail projects. He is currently heading R&D department and special initiatives in the L&T, transportation infrastructure. So now today is going to cover in his presentation on the challenges faced during the execution of the CCPR, which could address several critical areas, apprehensions about the implementing CCPR. Mr. Sharma, please.
Yeah, good afternoon. Good afternoon to all
business experts and technical experts, and people like me who learns by practice. I'll just cover some of the execution challenges, and already Arpan Ghosh has covered some of the things. So I go a little deeper inside how we have gone through a few of the challenges and came out with solutions. Before that, I strongly opine that RAP or the RBM is going to be the future of the nation in terms of conservation of the resources and ESG goals, as we discuss about many times. Reduce the carbon footprint, zero water neutrality, or many things. So this is one of the best technology which will actually lead India to the next level. So these are the topics which we'll discuss today in the discussion. I will cover these 7 topics, one after the other. So morning I would have gone through the mixed design, methods of mixed design and all. I thank Ms. Stephen Murli, Professor Murli and Arpan Ghosh. They are always with us. Whatever way we communicate them, they take it very proactively, and we have very, very good long discussion sessions to finalize the mixed design first, because we are all worried about the performance parameters. That's what we are trying to look into. And the handling of the RAP, the RBM, which you would have seen the photographs which are cracked severely, and how to handle, how to size them. These are the discussions went on. So these were the challenges. Okay, we need to achieve the ITS, highly deteriorated, distressed pavement, and still we have to achieve the ITS, which is required to be designed at 310 kPa, and the aggregate gradation and consistency of binder. These were the 3 challenges. As morning it was discussed, right, why VG30 is being used was used for SS2. That is the one control point which we want to bring in, where the SS2 itself is having a given properties without any hiccups in that. So we started reading many specifications to understand it well, and every time we had a discussion with all these 3 experts, and we were reading ARA, then Sabita, and IRC 120, IRCSP 100, where there were many discussions. Why not this? Why only this? So those were the discussions went on. Then we have decided that the consistency of the mix, not only the mix, the ingredients to be to the maximum. So then we started adopting the different systems. I'll take it to the next one. So the biggest challenge is this, the non-homogeneous nature of the RAP. There were very, very big, large chunks of broken asphalt pavement. Those to be crushed, rather I said to be crumbled more than a crushed, because we don't want to change the particle shape. As Mr. Rahul was telling that the idea was not to crush, not to make a fresh fracture faces. It is more to retain that size. So that's the reason we started milling it to the entire depth instead of going with layers. Taken the help of Virgin to understand what is the depth of the pavement available there, 100, 120, 150. So we want to mill an entire pavement at once, so that there is no particle shape and there is no change in particle shape and size. Then this RAP was screened. Then we are discussing what type of gradation to be followed. Is it JTG or ARA or our own IRC? Then there was a discussion that we should have these screens of 26.5 to 12, 12 to 6 and below 6. Those screens, those are the sizes which will give us the required ITS. So the dry ITS should be this much, the wet ITS should be this much. So target was about 85%. We want to achieve more than 85%. So likewise, there was a discussion because the ultimate thing is its performance. So mixing and stockpiling was the next challenge, where if the wrap not properly stockpiled, that segregation will come. So it is again a mix produced from a pug mill, which is almost like a dry mix like WMM. So the segregation to be controlled completely. So that's the idea. Then we started rehandling these stockpiles. First, second, then smaller stockpiles before feeding, mixing together them, then feeding into the bins. So those were the practices we adopted. So these are the photographs where that screening, then rehandling are taken up. Then the next was the production facility. The challenges were feeding the right size. The next was feeding the emulsion during cold period and like Delhi and all, very low temperatures where emulsion may freeze, means it may change its viscosity, and choking of pug mill. So the solutions what we found was we have provided screens on each bin so that the first control on the size itself is there, that we consistently give it. Second is we keep display boards everywhere so that the operators don't go wrong. So they feed the right size into the right bins, and all the bins are provided with sensors, speed sensors, so that the feed inside is continuously consistent, and see that the emulsion is always at 40 degrees centigrade, so that we have put some heating circulation arrangements inside so that we can control the temperature during the cold timing. Then we have continuously cleaning the pug mills, because this emulsion and the bitumen inside the wrap is sticking onto the pug mill pedals, so which is reducing the mixing efficiency. So we keep on cleaning it every day. Maybe every session once we used to clean it manually. You can see how the pug mill pedals are choked with the set emulsion mix or CCPR, and we keep monitoring the temperature of the emulsion all the time. So and we maintain that it is always less than 60. Anything between 40 to 60 is our target. We used to keep monitoring that. Then, as I said, the consistent supply of constituents is the prime parameter for the performance of the mix. So we kept our speed sensors on every conveyor belt so that we know how much feed is going inside. Are the proportions which are, our plants are 200 TPH, or the proportions are the same, that we keep on monitoring. Then we used to calibrate the plant every day. Every day morning, the session starts only by starting the calibration. So we keep seeing that even our sensors are giving the same values or not. So we keep calibrating those plants so that the feed is consistently of the same quantity. Then emulsion tanks are also, we have installed the emulsion tanks on load cells, so that we keep on watching them, that every hour what is the consumption of the emulsion, so that we see that we designed at 3.5% of emulsion, is it really going inside or there is a fluctuation? We used to control it. Then water regulation is also by water meters. This is again a continuous check on the water content, because we designed at 2.5% of water. So the 2.5% of water and 3.5% of emulsion should go. Even the Arpan showed as plus or minus 10% is a variation allowed, but it is too high. That's what we thought. We should have a complete control on it. So these are the meters which we provided. The biggest challenge is working on a live traffic, working inside a live traffic, because this is not in our control. So what we have done is we started going into the people, create awareness, provide them, tell them that where is the diversion we are making this time, and how we have to go, what speed you have to. We have created so many awareness programs, including the training to our own people, because we are working in a live traffic environment. So how to actually behave with those people. Our operators also, we started giving training. Then we approached also local authorities, the local panchayat, the people, the seniors inside the villages. Then we have taken the police support also, because to create this awareness and training to whole people, we felt that that is a success. That is going to this, the matter of success if you actually go into this public and say that this is create awareness. So these are the programs which we conduct, and we provided display boards, awareness programs to many people. Then this quality control. So the ITS, whatever we designed at site, are we achieving the same thing? We want to confirm again by taking course and test this ITS, are we achieving it or not? Then the calibration and recalibration of rolling pattern. So there are some mock-ups we carried out to finalize what is the rolling pattern. As Arpan said, 1 pass and 2 vibratory pass and 6 pneumatic pass. Are we actually getting those values? We used to recalibrate every time. That is, every month or 15 days once we used to recalibrate, because I said the homogeneity of the wrap is not so consistent. Even after putting those screens and crumbling plants and all, still we need to maintain it. So this recalibration of the rolling pattern, are we achieving the same compaction? So we have adopted nuclear density meters behind rollers. As soon as the rolling is completed, we used to reconfirm by the NDGs, because the cores, the sand replacement will take some time. So immediately we have to assess that are we achieving the density. So we have adopted nuclear density, used nuclear density meters to find out this degree of compaction every time behind the rollers. The consistent supply of quantity and quality is one parameter which I covered earlier. So the quantity and quality both has to go together. Otherwise, the expected, the results what we wanted of this CCPR will not be achieved. So that's a routine mechanism we have created to test materials, including the moisture in the wrap, the water content in the wrap, the emulsion content in the wrap, all we were monitoring continuously. So these are some of the photographs about what we have. These are field laboratories, always available. If there are 3 camps we have created, around 17 plants are running in these 3 camps, and all the places we have a field laboratory to continuously monitor this. So I'll just play a video on whatever operations we have carried out, like paving, compaction and protection.
You can see the varying sizes. That's it. Thank you. Thank you, Mr. Sharma, for a wonderful presentation on the construction implementation challenges. So in this session, we have covered the construction equipment that we have been used in this process, and the construction challenges, and then SOPs, that how we have implemented in achieving this quality product. So L&T has done a really very good job. Whatever the observations or remarks raised by our PMC team, ARPAN team, so they really took it very positively, and then they did it very well. And it's really, you have seen in the morning session materials, and in this the construction equipment what that have been used, and the construction procedures, SOPs and all these things. So because of that, all the stakeholders' collective efforts, and more importantly the team spirit, so we could able to deliver this in a very successful manner. The four important points that you can take note of in this technology is mainly the innovation in implementing in this CCPR is a big challenge, means because it is not properly standardized, and then the state-of-art equipment that is being used in this, and then implementation, the wrap, such a huge quantity, and handling that such wrap, huge quantity of wrap. And then finally, with the collective efforts of all the team stakeholders, we could be able to deliver a better product. So almost 3 seasons are passed. Today also we are seeing very good performance on the pavement. So yeah, as you have seen in the beginning of the slides, in this thing, the road surface is very, very bad. Means you can see a popcorn textured face. And today in this presentation, you are able to see a very nice surface. And the one example of such is in front of you. As we have kept one sample core here. You cannot really distinguish as DBM or CCPR. It was such a nicely constructed. So thank you very much for all the speakers for giving a wonderful presentation. Now we are already running late by 15 minutes. Request audience to quickly come up with 3 or 4 questions. If anything is left out, you can anyway always interact during the tea break or so, and the numbers also will be shared. And you can call upon over phone also. So now I request audience to come up with any questions, please.
My question is for Arpan. So when we are using wrap, the percentage of wrap material and virgin aggregate, that makes any difference in percentage of emulsion we add to the mix? I mean, basically I am asking whether the bitumen content in the virgin, not in the virgin, that's a wrap material, that plays any role in mix.
So in coal recycling, the bitumen content in the virgin, in the wrap doesn't make any role. But obviously the wrap quality makes a role, because when we did the lab study in IIT Madras, we used different emulsion contents. We started from 2.5, 3, 3.5, 4 up to 4.5. And then whichever is giving the best ITS and dynamic modulus, that is why we selected 3.5. So for coal recycling, the bitumen in the wrap wouldn't matter, because it is not getting activated. We are not heating it, so it's not getting activated. But in the similar way, because every road will have its different milling material properties, you need to do a different lab test in order to determine the optimum emulsion content.
One more question is, like in CIPR, I didn't see any chunks or screening when we are mixing, whereas when we do milling for CCPR, then we get the chunks. Is that the same milling or is it different?
It's the same equipment, whether you mill in situ, bring it to site, mix it and pave it, or do in situ. The only difference is the line spacing of the drum cutting tools, but end cut size, gradation cut size is same.
We don't do any screening in CIPR, isn't it?
Yeah, that's right. So that's the difference in milling drum and the recycling drum. When you mill with the milling machine, you have a different drum, you have different line spacing. When you recycle with the recycler, you have a different spacing and different configuration. So fines required or gradation required, recycler has a breaker bar, it adjusts that. So we can actually control the cut size or gradation by depth, speed and the rotation of the drum.
So in CIPR, the time taking will be more than CCPR milling?
No, it's faster.
It's faster. No, my question is like, if we can use the same milling machine, we can say the screening process in a CCPR, no? That part.
Actually, to be very honest, it all depends on the type of material you have on the road. So cut size, the brittleness of the material, the original binder material what was placed plays a bigger role. Even milling machines, some cases, as Dr. Reddy said in the morning, we have a young pavements. So chunks formations are not very great, but it's also function of temperature, type of bitumen you used. But in the southern part of India, when you travel, you have very softer material, so you don't need much screening after milling. It's a part of this. So cut size and gradation seals fits perfectly well with the right milling solution.
And one more question is, like emulsion, do we need to maintain 40 degrees compulsory, or do we heat it to maintain the 40 degrees?
It's not compulsory. It is a season based. Otherwise, only in the cold winter season only we adopted that. Otherwise, the natural temperature is sufficient for the mix to produce.
It should not go below 15. It should not go below 10 degrees basically. Because in Delhi we have temperatures going down to 0. So if the water goes to a freezing thing, so because emulsion has a lot of water, so that's why we need to heat. So that's why L&T had put heaters in the emulsion tankers, specifically during the cold, extremely cold seasons, where that it doesn't go down to below 10 or 15 degrees. Basically.
So 40 is not compulsory?
No, 40 is not problem.
Not compulsory.
Anybody else? If not, I think let us conclude this session. Yeah. Okay. Thank you. Thank you all.
So with this, we come to an end of this session. And once again, I would like to thank Dr. Raju for chairing the session. And thank you to all our speakers for such an engaging and thoughtful discussion. Your participation enriches this platform, making it an incubator for innovation and collaboration. Well, this session has been a testament to how theory meets practice in real world of road construction. As we have seen meticulous planning, adherence to SOPs, effective wrap management, and rich machinery are all critical to the success of CCPR projects. Now, I would request Dr. Bhagwan Raju to please present the mementos to our speakers. First of all, we request Mr. Apan Ghosh. Can we have a huge round of applause, please? Next, we are going to have with us our speaker, Mr. Sanjay Bajaj. Thank you so much, sir. We have with us our speaker, Mr. Rahul Kumar. Please put your hands together as we would like to thank S.N. Srinivas Sharma. Now I would request Mr. S.N. Srinivas Sharma to present the memento to Dr. Raju. Please put your hands together. Now we would request all our speakers to please come forward for a group photograph. Thank you so much, everyone. Ladies and gentlemen, now as we proceed ahead with our next technical session, which talks about a strategic perspective on bituminous materials in CCPR. This session adopts a strategic lens to explore the role of bituminous materials in CCPR. The focus is on ensuring end-to-end quality and quantity through efficient supply chain management, cost optimization, and achieving the desired payment performance. This session dwells into the critical aspects of ensuring quality and quantity in the production of bituminous materials, while all emphasizing cost-effective logistics and management. By exploring practical case studies and sharing experiences, our distinguished speakers will provide a wealth of actionable insight. As we navigate this session, let us remember that quality assurance and cost optimization are at the heart of sustainable infrastructure. Together, we will uncover methods that not only enhance operational efficiency, but also uphold our commitment to sustainability. To chair this session, we are going to have with us Dr. Stephen Sharmo, Technical Director, NHAI, US. We would like to have a brief introduction about him. Dr. Stephen Sharmo has been involved with payment engineering for over 30 years, which includes 12 years in Asia. His experience is related to the implementation of cost-effective maintenance and rehabilitation technologies, RAP usage, hot and cold recycling, warm and asphalt emulsion-based technologies are key focus areas of his journey. Stephen has been involved with the construction of more than 100 recycling projects in US and Asia. Stephen oversees the structural payment R&D at the NHAI headquarters in North Charleston, US. Stephen is passionate about conducting research that can result in sustainable solutions. With a huge round of applause, let's welcome him on stage to lead our third session for today, which talks about a strategic perspective on bituminous materials in CCPR. Please, sir. Can we have a huge round of applause? Now, allow me to invite our speakers for this session. Please put your hands together in welcoming Mr. Rajendra Sisodia, Strategic Consultant, Cube Highways. Please put your hands together as we invite on stage our next speaker, Mr. Vishal Kataria, Vice President, Strategic and Analytics, Cube Highways. We are going to have with us our next speaker, Kapil Bhatt, State IB Head, Delhi IOCL. Our speaker, Mr. Rishad Molbhoy, Managing Director, Elrish Bituminous Systems, UAE. Mr. Rajiv Kathal. We are going to have our speaker, Mr. Rajiv Kathal, MD, OMS Polymer Modified Bitumen. Please put your hands together for all our speakers. Over to you, sir.
Good afternoon, everybody. Again, it's really my honor to chair session 3. And we have a really wonderful panel with topics that I believe you will find very interesting and useful as we try to implement sustainable technologies such as CCPR. So let me give you a very quick overview of what will be covered during the session. So Mr. Rajendra Singh Sisodia, strategic consultant at Cube Highways, will discuss on strategic initiatives and outlook for end-to-end management of bituminous materials for optimum performance. So again, we're really looking at maximizing performance. While Mr. Vishin Sisodia to give his presentation. So with over 37 years of experience in the oil and gas industry, Rajendra Sisodia is a seasoned expert in upstream, midstream, and downstream sectors, including refineries, petrochemicals, renewable energy and pavement technologies, IMO 2020, supply chain, decarbonization, digitalization, business process optimization, etc. A member of the Indian Roads Congress and Bureau of Indian Standards, he continues to shape industry standards and regulation. Outside of work, Rajendra is an avid golfer and singer. Wow, that sounds like really fun to be around. So please welcome our speaker for his presentation and contribution. Thank you.
Thank you, Dr. Stephen, for your kind words and introduction. And good afternoon, everyone. Good afternoon, Dr. Reddy, and everyone on the dais, and all our Cube Highways people, and all the attendees. Since morning, we have been talking about CCPR, the landmark work that has been done by Cube Highways, particularly on the GAEPL project. And there is no doubt that this has been one of the largest projects, whether we talk about sustainability or environmental friendly projects. But also it is paving a way for us to look in India for repeating such kind of projects. So I will be basically covering my presentation in 3 portions. One is we'll be talking about CCPR as to what differently we did to succeed in this challenge. And secondly, what is the outlook and thinking and opportunities that Government of India would be looking from us. And thirdly, how we plan to meet up these challenges. So this is how the presentation is going to be, and we will, I hope I'll press the right button. So we have been talking about sustainable development, which is meeting the current needs, but also the challenge for us is to work in such a way that we meet up the challenges to give a clean environment to our coming up generations. And I was so happy to hear Chairman NHAI making the same statement when he was speaking about. So this is something that, like, now we have succeeded one project, and I have no doubt that looking at the cold technology or the emulsion technology that we have used so far as compared to the world, we have a long way to go. And if India is to succeed in sustainability and environment friendly operations in highways, there is nothing that we will not have to consider the technologies like CCPR or the emulsion-based technologies versus the hot mix technologies. Without any doubt, I am not questioning the hot mix technology, but looking at the commitment of India, what commitment India has made to the world, I think we'll see in the next slide. In the COP26, India has committed that we will be net zero by 2070. And by 2030, we will be reducing the carbon emissions by 1 billion tons. So if that is the target India is to meet, in Indian highway industry, one of the focused areas will have to be, now we are in 2024, and 1 billion tons need to be reduced by 2030. Therefore, and one more thing I want to highlight, that it has been always and it will remain, Indian highway industry or the projects are funded by the government. And all money comes from the government in either way. Therefore, somewhere down the line, we will have to align with the desires and aspirations of the government of India. And looking at the commitment of India in COP26, where we are talking about such big targets, it is becoming all the more important that we focus more on technologies like CCPR or use of more and more emulsions in our highways. As we go down the line, we will see how much progress in these years we have been able to make in the coal technology or emulsions versus the world or the other countries in the world. So more and more focus, more and more thoughts are coming to as to be, say from this CCPR at GAPL, where do we go further? So looking at the suitability, as all of us know, that one of the versatility of the asphalt or bitumen is that it is 100% recyclable and it is also repeatable. We can do recycling repeatedly again and again. Therefore, if we use coal technology, we are reducing on carbon dioxide emissions, as well as we are also reducing the use of the additional natural resources. So that makes more important that, and one more thing, that in India today we are about more than 97% of the bituminous pavements. Precisely, more or less everything is bituminous. Therefore, more and more we focus on handling bitumen carefully in this context. More and more advantages, both in terms of sustainability and from the environmental point of view, we are likely to get. As we see that, the content of bitumen is only about maximum 5% or so, maybe little more. From the cost point of view, it is costing almost 50% in some case of specifications. But the responsibility of bitumen on performance of flexible pavements is considered to be 100%. And the demonstration is that whenever a bituminous pavement fails, it may have 10 reasons. But the first reason and the blame goes to bitumen, that it was not good, as I was hearing in the earlier discussions as well. Therefore, now if we are to deal with these pavements, bitumen is one of the key factors that we have to focus. And I am so happy to say that under the visionary leadership of Dr. Reddy, we have clearly specified and identified that this is the key area if we are to succeed in flexible pavements. Therefore, handling bitumen in-house, internalizing everything right from sourcing to modification to going right onto the site and the use of this product. And I am happy to say, as we will see the numbers a little later, but the numbers are large. And successfully, last about 3-4 years, we have been able to handle this without any failure. So the importance of bitumen, once again, generally when we talk about composition of bitumen, we generally discuss asphaltenes, maltenes, saturates, and other things. But in today's context, when we are talking about environment and sustainability, I have a different equation, that we talk about carbon, hydrogen, and oxygen. If you see, the percentage of carbon is 87% in case of bitumen. And therefore, if we are heating this carbon, 87% carbon, as we will see the chart, look at the numbers. In case of, we are going right up to 205. And here I have not listed PMB. If we take PMB, it may be required to go up to 205, 210 for required coating. So every time we are handling bituminous products or the aggregates, we are touching a temperature of 200, up to 200, 210. Now, when we are touching this temperature, what happens to the carbon? So automatically question comes that more and more generation of carbon dioxide and the emissions is likely to take place, which is not desirable. And therefore, at the same time, if we look at emulsions, it is temperature independent. There is no specification, nothing, no control is required for handling the temperature as compared to this. So therefore, emissions, energy consumed, both are under control and we can handle it without any issues. Generally, you would feel that why this kind of picture is coming, but I just wanted to let you feel what happens when it is heated up to 205, 210. This is which happened. We can see visually the fumes right now, and if we count in numbers, it will be large as I will share in the coming slides. So this is the spray of bitumen for, as we can see, and look at the position on the site. This might be little exaggeration, we may be little better, but surely we cannot avoid if we are touching temperature of 205, 210. Contrast to this, now look at the picture. This is emulsion. There is no, it is total clarity. There is no pollution, there is no fume, nothing. So while numbers are different, but physically, even somebody does not know difference between hot bitumen and cold bitumen, he will tend to say that this looks better. And that's how when we when we try and talk to the government, the feeling has to come that yes, this thing needs to be done or this has to be done. So we can see clearly, and as we see, we look at microsurfacing or any emulsion operation when we do. Once again, it is giving a total clear environment without any fumes or emissions. So the point which I wanted to drive is that between the hot and cold, certainly cold is more desirable and more so in the current context when our country has so large commitment, so challenging commitment. Other industries will perform, but in highway industry, this is what we can contribute and do, and the technical experts and the technologists and people like us, we will have to come up with technologies and the processes that are required to successfully implement. And in the same breath, I also wanted to say, we can design technologies, we can explore technologies, we can do all this, but materials are very, very important. If we do not have the right material and the critical materials in particular, no matter how good technology is, no matter how technology has been successful elsewhere, if we are not able to have quality assurance of the critical products in particular, I remember, I think I must say, although Chairman NHAI in the morning when he was talking about, he also highlighted this issue that quality is something we should repeatedly focus and try and ensure. So, and this is what we have practiced here in Cube Highways, and example is in front of you, the success of CCPR project in GIPL, and elsewhere also we are following the same. Just to have a feel as to where do we stand in terms of carbon dioxide emissions. And while I am saying this, I am also trying to say what can we do. My experience, my dealing with the government and looking at the government scenarios, I feel that probably in next 1 or 2 years, there could be directives of using certain amount of percentage of technologies which are cold or in terms of usage of materials, etc., because when things don't progress on ground and it is not meeting the government challenges or aspirations, sometimes there are directives. So in Cube Highways, we are focusing that, and we are clearly analyzing and trying to make up our strategies that this is how we should move. So look at the comparison of CO2 emissions. When we talk about normal bitumen operation, that is the hot operation, emulsion and cold recycling. We are straight away seeing at the end, in respect of the time, various operations are there, we can discuss later, but straight away you can see that when we use emulsions, the CO2 emission is coming down by 30%. And when we move to cold recycling, it comes down by 85%. So that's the kind of difference, that's the kind of achievement in terms of emissions control we can have if we have this cold technology or usage of emulsions. Same way, if we have some idea about operations, straight away we can say the energy consumption also will have the same equation. You can clearly see that as compared to hot work, emulsion and cold recycling, emulsions, the energy consumption is coming down by 30% and cold recycling is about 84%. These numbers are directional numbers. Exactly when we operate, this 30% may become 29% or 31%, but directionally it is very, very clear line on a statement that we have to try and explore the technologies which use lower temperatures or the cold technologies, and further we have technologies like CCPR, CIPR and others. We have to compare, we have to also evaluate as to where do we stand and what are the key areas we need to focus. I am, for last about 20 years, seeing this number, and it pains me sometimes also, that why such a environment-friendly product, that is emulsions, bitumen emulsions, why we are way behind the world. Look at France, 43% of the total consumption. World average is about 20, but we have now reached about 4.5. Very, very low. And when we are talking about our highways, I see in next about Dr. Stephen is here, but I am seeing maybe next year we will surpass US in terms of length of the routes. We are just down by about 0.4 million kilometers. So look at our large scale. So when we have such a large scale, we cannot stay with a consumption of 4.5% emulsion in the long run if we have to consider both sustainability and the environment. So therefore, I think I must say in the same breath that at Cube Highways, while our management is so progressive, so visionary, at the same time, we have been able to identify, after a lot of effort, a lot of critical analysis, a lot of research, our partners who have helped us in project like CCPR, and we are also confident that we can handle multiple number of such projects with our partners who are on the dais, whether it is Indian Oil Corporation, Bitcoin or OOMS. These people have worked with us with shoulder to shoulder. They have been finding little difficult also, because the process of quality management has been difficult. It has not been normal. A lot of questions have been there. Means a general thing is not acceptable. Everything has to pass through a SOP. As we were discussing, everything has to have SOP. But we are so grateful and we are so lucky that we have such partners with us, and with their commitment and executing the desires and the programs that we have today, with confidence I can say that not only in terms of scale, but in terms of ensuring that whatever quality and quantity is required at site, no matter what is the size of the project, we will be able to execute with precision as it has happened in case of CCPR. So my one more earnest request to people in the industry, particularly the emulsion industry in India, that this is something which has large potential. Only thing is we have to work little hard. We have to see the writing on the wall that this is next few years will be the technology of cold and emulsions if we are talking about the bituminous industry. So it's a huge opportunity, and Cube Highways will always be welcoming any such partnership, any such strategy that we have to execute along with you. While so many advantages we will talk, if we look at the Indian picture in terms of seasonality, this is a data of last 20 years, 22 years. July, September is some time, then everybody in a bitumen industry in India, because we are 95% hot work. So everybody goes on holiday because nothing works. It's rainy season. Now, in contrast to this, when we go for cold technology or more and more use of emulsions or more and more cold technologies, we can expedite our performance here in this quarter, and the time which is wasted, 3 months time we are idle, this can be utilized, our progress of the projects can be faster, our IRR on the projects can be much, much better. So this will be another advantage, and there is huge potential, as I said. So this is another advantage when we talk about cold technologies. Just to connect with what I said earlier, energy consumption, carbon dioxide emission, if you look at the numbers, particularly in terms of the processing cost also becomes low because energy consumption is less. Additives cost also is less. And in terms of cost on emulsions, primarily it is bitumen only because about 35% is water. So in every respect of the numbers, everything is falling in favor of the emulsions or the cold technologies or any techniques that we may use. So like at Cube Highways, we have even for minor repairs, we have an arrangement for using the repairs with emulsions. So slowly, whatever small or big, wherever there is an opportunity, if we use, I am definite that the way Chairman NHAI was telling in the morning, when they review sometimes the highway industry's performance, that where are you moving towards carbon dioxide emission reduction or sustainability, once again they will have to quote example of Cube Highways. So this is how I look at the future. The time says up, so I will quickly cover, give me 1 minute, how this has happened. We have a 3-layered quality control system wherein at the first place in the refinery we have the tie-up with the largest enterprise in the country without compromising on anything. Unless it passes the quality, product cannot come out of the refinery. So that's our first success, first certification. But we don't leave it at that. Based on the material testing certificate, it is cross-verified by us. And if we are satisfied, then the material moves from refinery either to the modification plant or directly it goes to the site. When it comes to the modification plant, once again the product is tested. When it goes to the site, again it is tested before it is put to use. And then at the modification plant, once the modification is done, our partners also undertake the full testing of the material of PMB or emulsions, which goes to the site. Again at site, when it reaches, again at site, this exercise of testing the material before use is done. So that's the whole sequence that has been that is there. And I would urge that if anything is to be consulted, anything is required by the industry, it will be more than welcome. We can share all details with you how to do it, but we want that everybody should succeed like this in quality control management. Similarly, supply chain also, in case of bitumen, there is always a complaint about the quantity. But without quantity assurance, nothing is accepted. There is a proper SOP, not even a single kg or a single gram bitumen is acceptable to be reduced, to be reached as site. There is a standard SOP. Our people are wonderful. Arpan was there. Our Cube Tech team has done wonders. End to end, everything is getting assured. Vishal will be covering in detail, but like this is the work our team does. When we talk, we have handled about 243,500 metric tons of bituminous product in last about 3 years. And this is the exercise which goes on daily basis. Whether it is requirement at site, whether it is dispatch from the refinery, whether it is processing at plant, receipt at the plant, everything is done on daily basis. And every Monday there is a detailed, Tuesday there is a detailed review as to what has happened, what do we need to do to improve. So this is the kind of glimpse that you can see. A lot of hard work is required if we want to achieve something. Same way, supply chain management. Polymer is difficult to handle all the way from overseas, the product is coming, but our people ensure that there is not even a single kg shortage at the plant, or there is a delay of supply of PMB or bitumen at site. For last 3 years, I was talking to some of the people who have come on field, by any failure, कोई failure वगैरह है तो बताओ यार हम ठीक कर देंगे. But they are saying, sir, last 3 साल में कोई ऐसा हमको तकलीफ नहीं हुआ. Another thing they were saying कि साहब अप्रैल जून में हमारा ज़्यादा टाइम तो बिटुमिन फॉलोअप पे ही जाता है, मिलता नहीं है. But few people don't have that difficulty because they work hard to get it. So this is how we go. We will be able to manage quality, quantity, and progress of our project. And same way, Dr. Stephen is here. I must admire the global team of NGVT. It was excellent, and I particularly would say Vishal is sitting here. He has done a wonderful job. This was a daily exercise of monitoring the stocks of emulsifiers to manage the CCPR project for SS2 emulsions. And as I say, success does not come with ease, it comes with hard work. So this is what our team has done. Those red things you see, we had a flash, that the moment if I see a flash, that means on this date I will go out of stock. I have to take corrective action. And Dr. Stephen, I would say your team has responded so well that in few cases they airlifted the material to ensure that there is no delay of emulsion supply for the project that we are talking about. So it is better to share what exactly has happened. And these are the numbers I think we have seen. And as I said, environment-friendly, cost-effective, innovative technologies and materials are required for successful implementation in Indian conditions. I have to underline. We might read research papers which are published in US or Europe, but we have to understand that we have to work on the technologies which can be successful here. So we have to see that it works in Indian conditions. And once again, I am not trying to please Dr. Reddy, but I admire his visionary leadership. We have about 2 years back started working that to meet this, what we need to do. And what we need to do is coming in next slide. This is what we are creating. This is a R&D center which is going to come up next year, and the name which we have given is Mentoring Innovations, New Developments in Science. We are seeing here that what we need to do to see 5 years down the line, 10 years down the line, and we are working on this. We have pavement laboratory equipments are practically ready. So I think by about next first quarter or second quarter, we will be able to see R&D center of Cube Highways live. So this is what I wanted to say, that Cube Highways, we don't talk today. We also talk of future, and we are ready. And for doing that, we have to once again do hard work. So this is what we did. We have done complete study of the mapping of various things that the various institutions in India and abroad has done. And after doing this exercise, we arrived at that what we need to make the pavement laboratory the world class. And then again, we did the exercise of the equipment manufacturers. There are about 28, 30. Sometimes the only reference coming was either US or Europe, but we have been able to find the best in the world. And these are going to be, they are our partners. They have already supplied the equipment. So I will end up with this. Normally we will end up with conclusion, but I have seen where we are and where we want to go. Thank you very much.
Thank you very much, Mr. Sisodia, for your very thought-provoking presentation and emphasizing key hard work ahead of us to implement sustainable and innovative solutions. So very well done. Thank you. Our next speaker is Mr. Vishal Kataria, Vice President Strategies and Analytics at Cube Highways. He will talk about the GAEPL case study on emulsion production and supply. So that will be very interesting. Let me say a few words about Mr. Kataria very quickly. Vishal Kataria holds a bachelor's and master's degree in civil engineering from the IIT Kanpur with a specialization in pavement engineering. With nearly a decade of experience in the operation and maintenance of highways, Vishal currently works with Cube Highways, where he plays a key role in improving highway infrastructure across the country. His expertise spans pavement evaluation, pavement design, and pavement maintenance, with a strong focus on implementing cutting-edge technologies. Vishal has successfully introduced and managed the use of SMA, high modified asphalt, hot recycling, and cold recycling in several operational projects. Notably, the HIMA technology under his leadership won the Gold Award in the Innovation category at the National Highways Excellence Awards. Vishal is dedicated to advancing highway infrastructure through sustainable and innovative solutions, ensuring long-term durability and performance of road networks. Please welcome our next speaker.
Thank you, Stephen, Dr. Stephen. So I will be presenting, today I will be presenting about the production quality control and the supply of SS2 emulsion, as well as different bituminous product which has been supplied to Ghaziabad Aligarh to complete the 6 laning. So I'll just give a little bit background about Cube philosophy for procurement of bituminous material. We have a slightly different construction strategy as compared to industry. In most of our assets, we use polymer modified bitumen for a longer pavement life. Secondly, we appoint a construction partner for execution of our MM and construction works, and all the bituminous material is procured by ourselves. From last 8 to 10 years, we have completed several projects with this philosophy. In 2020, we have started doing these modifications of PMB and emulsion internally. All the activities, if we see what are the activities which are involved in bitumen procurement, so we are procuring all the raw materials, whether it is base bitumen, polymer, emulsifier, directly, and then we are getting all these materials modified at premier modification facilities which is available. And then later on we are doing this transportation of this material to our sites. So if we see, these are the things which we are doing, what are the benefits? So if we see about the benefits of in-house procurement, obviously the first thing is the total control on the quality of the bitumen product which is getting manufactured or which is getting consumed at our road assets. Secondly, we have a full control on the raw materials. We ourselves can decide what kind of a bitumen will go, what kind of a polymer should use, and how the performance will be there with these raw materials which are there. And thirdly, obviously, given the portfolio size, the economy of scale which we get considering the portfolio. If we talk about supply partners, in last 4 years, we have been partnering with different partners who are sitting here for DICE also, and few are there also as the delegates. So we have an Indian Oil tie-up with Indian Oil for supplying of bitumen to our assets, whether for directly using for as a VZ40 or for the modifications. Then we have a tie-up with Kraton, NGVT for the supply of polymer, Indule NW5, which we have used in SS2. Then we have a tie-up with Bitcoin, OHMs for the modifications and for the transportations of this material. And if we see the states in last 4 years, we have completed 17 projects of construction and major maintenance projects with this philosophy which we are using it. Around 1,40,000 metric ton of bitumen has been procured from IOC till date in last 4 years. And 4,200 metric ton polymer and emulsifier are directly imported from US and Europe. And if you see 99,300 metric ton of PMB and emulsion has been manufactured and supplied to our assets successfully. If we move to Ghaziabad-Aligarh sections, and we'll see what is the bitumen supply mechanism we have used here. Since this is a different project, this is the kind of a different project because the 6 laning was involved. The total requirement was around 54,000 metric ton of bituminous material to be supplied within 16 months, given the timeline. So what we did here, if we see the right side of this PPT, we have taken all the base bitumen materials from IOC refineries, Mathura. We have taken it to our modification unit, which is there in and around Kosi. We have imported all the polymers, all the emulsifiers. We have done the modification at modification units, and then we have supplied it to the 3 base camps which are there at Ghaziabad-Aligarh section. And if you see the quantities, the most of the quantities out of this 54,000 metric ton is PMB and emulsion, which required some kind of a modifications, which are not available, readily available in the refineries also. If you see next, in bitumen supply, what are the challenges and challenges and then planning strategy which has been adopted. If you see initially when we started this project, from bitumen point of view, there were a couple of challenges for the supply of bitumen. First challenge was there was a 3 months lead time for the import of emulsifier as well as polymer due to geopolitical conditions at that point of time. Even sometimes it is taking more than 3 months, 4 months around. And secondly, there was no contingent time for the execution since 6 laning of 100 kilometers has to be completed in 16 months, which was the timeline as per the CA. So the idea was not to have any kind of a shortfall in terms of bitumen supply to complete this project well within time. So the kind of a strategic planning approach which we have adapted, Mr. Sisudia also mentioned about this. So I'll just give a few points. So we have already finalized all the partners well within 3 to 4 months before the start of the execution projects, so that we can plan everything and all the partners can also plan everything. Meticulous planning will be is done for emulsion as well as the polymers because of lead time, 3 months lead time, as Mr. Sijuda also mentioned, tracking systems which we have put up to have a discussions with them. And even NGVT has also done airlift a few times for us so that there should not be any delay in terms of material. Thirdly, we have planned the base bitumen in such a way that there should not be any kind of a production hamper on our modification plant at any point of time. And thirdly, a systematic approach was implemented to monitor the requirement on monthly, weekly, even daily and hourly basis in peak time with our execution partner, with our modification partners, with the IOC, everywhere. Finally, with this, what we achieved. So in terms of if you see the supply, 100% supply has been made uninterrupted. There was not a single instance where work got hampered due to unavailability of bitumen. 100% supply was made with the desired quality throughout the project. And with the help of with the support of our partners, we have created world record also in supply of bitumen for the world record, which is created by our execution partners on the site. So these are the achievements which we got. Now I'll talk about SS2 emulsion, which was the main focus for CCPR. If we see, I'll just take you through the process flow which we have followed. We have done a customized formulation. Professor Murli and Dr. Stephen also talked about this, which is based on the wrap which was available at site, the condition which is there at site. Then the same formulation which was finalized in laboratory has been validated in our partners lab as well as their facilities from execution point of view, because whatever we did finalization in lab, we wanted to see whether it can be achieved in the plant or not. Thirdly, the source of raw material, we have finalized single source of raw materials to get a consistency in the material also. So that we already discussed. Then finally, we manufactured the emulsion in our partners plant. We'll discuss in further. The quality control, as Mr. Sijudar also mentioned, we have put up strict quality control SOPs. We have deployed few people from our side on all the plants to just see if products is getting products is proper or if there is an issue in that. Finally, transportations, we have also ensured that there should not be any mixing of the products so that we can avoid the contamination in the product emulsion which is getting produced. So these are the things. Lastly, it gets again verified at site, which already Mr. Sisir also mentioned. And everything, we have also developed one in-house software. We have tracked everything on from our build date so that we can get, from logistic point of view, we know where this vehicle is and how, what other supplies has been made. So this is about, next we'll move about formulation and specifications of SS2. So we already discussed this in first presentation. I just wanted to give a brief about this. The formulation, we have finalized a formulation laboratory, and after verification at plants, laboratory as well as execution facilities, we wanted to finalize all the percentage which is there, just to get a uniform and consistent material for SS2 for the CCPR, so that there should not be any variability in site. And all these parameters which has been finalized, which are customized for cube. And if you see from IAS, we have put a few more control points, few more parameters, so that we can also assess what is the condition and what is the results of the residue binder which will be there after emulsion. I also wanted to highlight few points. We not only the final parameters which we have checked, we have also put up control points during the production of SS2, different control points, just to be sure that whatever we are doing it, we get a consistent product. So in terms of temperatures, in terms of what would be the pH, TDS of water, what would be the pH of emulsion, SOP solution, all the control points are put up, and then all the verifications has been done with the control points so that we do not miss anything out. And if you see the quality control chart in this table, we have procured VG30 around 970 trucks of VG30 from IOC. Even though it is coming from IOC, more than 50% of testing has been done in our PMB plant, just to show that, let's say, if there is any change in the property, major change in the property, so that same can be changed in the formulation of emulsion also. And SS2, 221 batches are produced, and 100% batches are checked for all those parameters. If we move further on the manufacturing steps, so if you see these steps, which we already, Dr. Stephen also mentioned these steps, the only thing I wanted to highlight, every steps if you see, we have put up control points so that we can control the process also, not only the final product. Let's say if you talk about soap solution, it has to be have a pH between a limit between 1.8 to 2, or temperature, what should be the temperature, and what kind of a raw material which has to be used. All the raw materials will be consistent, whatever we have finalized. And then bitumen, what are the temperatures at which bitumen is getting mixed with the soap solution, and what is the final, whenever we are getting the final emulsion, what are the properties of final emulsion. So this is the process which has been followed, and then finally quality inspections. Once the people deployed at our facilities, if they are okay with the quality inspection, then only it gets dispatched. So if we see, these are the quality control testing photographs which we did during our process. These are just a snapshot I just wanted to show. Finally, these are the outcomes of all the emulsion which we have manufactured at our manufacturing facilities, and these are the results. If you see the viscosity which is there, if you see during our formulation we have finalized a range of 20 to 100, which is a 80-second range, which we have finalized. Finally, the product which we have produced at our modification facilities, it is within 16-second range. 95% of the products produced between 16 seconds range, and 100% product is produced between 22. So we can see the uniformity or the consistency in the product, and this is what it matters a lot, because finally it is going at site, and this is something which we are doing new. All these parameters are finalized considering one curing time, considering one set of final products which we should get at the site. So we have ensured that there should not be major variation in these parameters. Similarly, if you see residue, we have finalized 62%, 60%, we have received 64%, almost the average minimum also 62.9%, which is better. And if you see, even it is the minimum limit, we have not crossed more than 64%, 66%, sorry. Similarly, pH is there, and this is the outcome. I just wanted to show what test we have done on residue. Generally, there are only few tests which are given in IS specifications. However, in our customized specifications, we have put a few more control points here, because we just wanted to see, as Professor Murli also mentioned, we wanted to see what kind of a final product after evaporation of water, what would be there, what bituminous material will be there. So we have tested everything. Penetration, if you see, the limits are as equivalent to VG30, which we have used. Similarly, softening point also. And we have also checked the complex modulus just to understand what would be the PG grade of this material. And it was always more than 2 to 4. So these set up an idea what kind of a quality control is done, at what level it has been done. The only thing is, once we get a proper product, then, because everything is linked, because the product is designed based on some certain material which is there. If we are changing something, it will have an impact in the site also. So not only this, let's say sometimes what happens in industry, if we have to do some kind of a recycling or some kind of executions, we take a final product as SS2 or maybe a PMB, but controlling the quality, even though the ranges or the parameters which are given in the standards, Indian standards. Finally, I just wanted to also mention the world record which has been created in this project for laying of 112 kilometers in 100 hours. So I just wanted to talk about from PMB supply. So if you see, we have decided to, along with L&T, we have decided to start this world record on 15th May, 10 a.m. So in terms of PMB supply, the process started 15 days back. So we have started discussions from 1st May. From 2nd May, we started inverting all the bitumen from refineries. Then we have started productions. And before the start of the actual work at site for the world record, 62% of the PMB was already supplied by that time. And if you see, by 49th hour, we have completed the 100% supply. The initial plan was 100 kilometer. But then when we feel that we can achieve more, then we have also supplied the additional quantities within 76 hours. So these are the testament of the planning which is done along with all our partners which are sitting here. The way planning is done not only for these, throughout the project. In the peak hours, we have supplied 4,500, sometimes 5,000 metric ton of supply from a single facilities, which itself is tells you what kind of a planning is required. And finally, these are the learnings and recommendations based on the project which we did in terms of SS2 supply. So one thing I just here wanted to highlight. So whenever we do such kind of a new implementation of new technology, the mix design has to be perfect. It has to be done thoroughly, checked, thoroughly researched, and based on this mix design, we should also formulate the formulation of PMB or emulsion which we wanted to use. Secondly, I would suggest we should always stick to one raw materials, which will always give you better consistency in terms of performance, in terms of the results. And if we are changing raw materials, there has to be new mix designs for emulsion as well as the mix. Then there has to be, so what we did, as Mr. Sridhar also mentioned, we have prepared detailed SOPs, step-to-step SOPs, and we have implemented those SOPs. It's not like just we have prepared SOPs and then those are not monitored. So every time we monitored whatever is written SOPs, what is happening at site. So these are the things where we can control, and because these are the production which are happening on a larger level, not in a laboratory kind of a thing where it's in small samples we have to produce. So the implementation will be very, very critical. Finally, the monitoring of manufacturing product is also required, feedback from site if there is anything which is not proper, if people are facing, our contractor or our execution partner is facing issues while executions. So we should understand their problem and then we should take corrective actions. Robust planning, as we already seen for the procurement of raw materials, if we directly procure, because sometimes it takes 3 months, and because of geopolitical situations or any situations which is there, it may take 3 months, 4 months, 5 months. So these are the things where you have to be proactive in terms of planning also. You have to keep your contingency in your hand, and then you have to plan. So, and finally the transportation, I would suggest we should not mingle the products. Sometimes what happens in urgency, we are using emulsions, we are transporting emulsion in bitumen tankers, bitumen in emulsion tankers. Ultimately that contaminate the product and it will lose these properties. So that's it from my side. Thank you.
Sorry, I'll just take 30 seconds. Just for one more point I wanted to highlight, because a lot of people are asking what you guys are doing in Cube Highways, why everything is getting successful. So in the model that Vishal has explained, one of the things we are ensuring is that we are taking care of our partners. We are ensuring that the work they do for us, they are paid in time. And today we have a application which is Build Aid, and in Build Aid we have everything lined up, right from bitumen supply to emulsion and everything, their transportation, everything is online. The quantities are getting certified, and there used to be issues about the payments. Payments are getting delayed. After all, they are in business, so they will need payments in time. So one of the things I wanted to highlight, that our outlook and the policy is 100% transparency with everyone, including the partners, and that's how the whole thing works. We are always open in case they have any problems, any suggestions. We try to implement. Thank you.
Thank you very much, Mr. Kataria, for sharing your experience with us regarding the project in terms of supply chain, in terms of SOP, in terms of statistical control. Really like your approach to use statistical analysis to ensure consistency, because that's really a very key aspect to the success of a project, the consistency and the reliability of the outcome. So thank you for your experience that you shared with us again today. So we have some other industry experts lined up for session 3. Our next speaker is Mr. Kapil Bhatt from State IB, who's a State IB head from Delhi Indian Oil Corporation Limited. So let me say a few words about Mr. Kapil Bhatt. He's a distinguished professional with an exceptional career spanning over 26 years in the petroleum industry. His expertise, dedication, and innovative mindset have made him a notable figure in the field. Mr. Bhatt's impressive journey is rooted in a solid academic foundation. He holds a B.Tech in electronics and telecommunication and a postgraduate diploma specializing in petroleum management. These qualifications have been instrumental in shaping his forward-thinking approach and driving his success with the industry. Throughout his career, Mr. Bhatt has consistently taken on leadership roles, including serving as head of divisional offices for Indian Oil Corporation across major cities such as Mumbai, Chandigarh, and Jammu. In these positions, he demonstrated exceptional skill in aligning operational strategies with business objectives, fostering growth and creative value. Currently, Mr. Bhatt leads the Institutional Business Department for the Delhi and Haryana State Office at Indian Oil Corporation. In his capacity, he plays a pivotal role in steering innovation, enhancing customer engagement, and achieving tangible outcomes that contribute to the organization's success. Please welcome our next speaker. Thank you.
Thank you, Dr. Stephen, and respected dignitaries on dais, my colleagues from the industry. I feel privileged today standing in front of all learned men and women and professionals from the construction industry. Thank you very much for giving me the time. First of all, I want again, congratulations to the Cube Highways for setting up a world record in their feather that has demonstrated their dedication, commitment, and the voltage towards the innovation. Cube Highways has started CCPR technology for this project, which is Ghaziabad Aligarh project. This is a landmark project for us also, where they have displayed that they are environmental friendly and they have reduced the cost also. Indian Oil is thanking Cube Highways to selecting us a partner in such a landmark project. Indian Oil always tries to be attached with all my partners, and we have always delivered the quality product everywhere. That is our tagline, that we are having the care and innovation in our values. Indian Oil, seeing the development of India, where we aspire that by 2027 we will be a developed nation. So we are investing in refineries very heavily, that around 1 lakh crore of rupees we are investing in the refineries, where our nearby Panipat refinery, we are enhancing our capacity from 15 MMTPA to 25 MMTPA. Similarly in Koyali, Baroni, and we will be increasing our bitumen facilities as well. Currently we are installing, we have installed capacity of 3.2 million metric per annum, which is catering India, and that is not sufficient because we have to import some of the quantities. We try to enhance the capacities of bitumen. Not only bitumen, actually we are enhancing our capacities in the petrochemical also and alternate energy also, which is the need of our, as Mr. Vishal already said, that sustainability is the need of our. In sustainability, we are already have several projects in our line, that we are having 2G ethanol plant in Panipat, 3G ethanol plant at Panipat. 2G ethanol plant is extracting ethanol from the agriculture wastes, and 3G ethanol plant, we are reducing our emissions and extracting ethanol from gases like carbon dioxide, carbon monoxide, and hydrogen. We are doing remarkable job in setting up our EV charging stations. We are given ourselves target of setting up 10,000 EV stations by end of this year. We have already crossed 9,500 EV stations. We have also installed a battery swapping facilities at various pumps. So around 91 battery swapping stations we have already installed, which is being helping us to give a edge over the competitors. Regarding other alternate fuels like CBG, we are also doing a good job there, where we have installed a big plant in Punjab and Gorakhpur. Around 32 plants we have across India, and 91 retail outlets is supplying CBG. Around 7,000 metric tons we are supplying every year of compressed biogas. We are working towards the bitumen also. Bio-bitumen is the trend, and recyclable bitumen, it is also in a trend. We are working towards with our partners for that. And it gives me immense pleasure to be among you and saying that this partnership between Indian Oil and all construction company, we are not building our roads only, we are building the nation. Thank you very much for giving me the time.
Thank you, sir. Our next speaker will be Mr. Rishad Molubo, Managing Director at Elrich Bituminous System UAE, Innovation to Legacy, whom's India's role in shaping India's roads and runways. Let me say a few words about the next speaker. So Mr. Rishad is the third generation of a 100-plus-year-old family business and brings over 45 years of experience in managing the family's diverse activities. He's currently the Managing Director of Elrich Bituminous System UAE, the technical partner of Bitcoal India. Bitcoal India is a distinguished supplier of the Elrich brand of modified bitumen in India. The company operates 2 state-of-the-art world-scale manufacturing plants and laboratories for PG-grade PMB and specialty bitumen emulsion products. Bitcoal has also been India's most recognized bulk bitumen supplier for over 25 years. In addition, Mr. Rishad serves as the Managing Director of Richmond Group. The Richmond Group is an international conglomerate with manufacturing and trading operations across Australia, China, India, Singapore, Oman, and the UAE. The group is known for its successful establishment of global manufacturing and trading operation. The Richmond Group is currently one of the most reputed companies in the region for sourcing, shipping, manufacturing, and distributing bitumen and modified bitumen products. The group operates multiple bulk bitumen terminals, manufactures and sells value-added bitumen products with operations spanning from Africa to Australia. Please let's welcome Mr. Rishad to the podium. Thank you.
Dr. Reddy, the entire team at CUBE, and distinguished delegates, I am humbled and honored to be standing here in front of you to share with you a little bit of what we at Bitcoal Elrich Richmond Group do. As Dr. Stefan mentioned, we've been active in multiple businesses, from steel to bitumen to petroleum to shipping, shipping being complementary to our trading activities. So we've been pioneers in India for the import of bitumen since '98. We supply to all the Indian PSUs. We have accreditation for all the products we produce of international quality. We have several PMB and emulsion plants in the world, in Iraq, in Qatar, in UAE, in Oman, and in India. All these plants are continuous plants so that we don't make batch by batch. They're continuous plants, so we have a high consistency of product quality compared to batch plants. And obviously larger volumes that we can prepare in lesser number of hours. This is one of our plants in the Middle East, where we have a storage of 15,000 tons of bitumen. We make emulsions, cutbacks, PMB, and drumming for PMB, which we supply to Africa. We are one of the first people to supply drum PMB to Africa, which is then decanted, heated, agitated, and laid. And we have had no problems at all. We've done, I think, the last 2 years, about nearly 30,000 tons of PMB in drums. We supply about 800,000 tons of PMB, bitumen globally from West Africa to Australia. And in the recent years, we've done probably over 400,000 tons of PMB in this region. We have at our plant state-of-the-art labs. As you can see, the reason why we've got white floors, and we're very proud of having done that with your support and with the coordination of Vishal and his team in achieving this. And so we do on-site production. We've built a terminal in Qatar in the middle of the desert, and we produce 53,000 tons of PMB in 18 months for a highway project that went around the ring road in Doha. So these are some of our capabilities. We initially started developing mixes containing RAP together with the Al Ain University municipality. Development of special high resistance HMA for airports together with L&T and IIT Delhi. And we've done a lot of rehabilitation work in runways and highways in the Middle East. We have been producing a proprietary hybrid PMB, which I had mentioned to you. Minor road distress and can extend pavement life by several years. And recently, Whitcall was involved in microsurfacing for excavation work for about a stretch of 70 kilometers in India. These are some of the projects that we have done. We've done about 13, 14 airports around the world, many highways in India and abroad, and in Africa, in the Middle East. And we, as I said, we've also supplied a lot of PMB into Tanzania, Zambia, Ethiopia, and various places in the world. So that in a nutshell is what we do. Thank you very, very much.
Thank you, Mr. Rashad, for sharing your contribution to the project here, the CCPR project, and your activities worldwide. We appreciate that. Our last speaker for the session 3 is Mr. Rajiv Katal, Managing Director, HUMS Polymer Modified Bitumen, and he will talk to us about innovation to legacy, HUMS India's role in shaping India's roads and runways. So let me say a few words about Mr. Rajiv Katal. He's a visionary leader in civil engineering, has established himself as a transformative force in the Indian road and runway construction industry. With a passion for solving infrastructure challenges, he began his journey by voluntarily retiring from MPS-EB in 2002 to pursue his entrepreneurial vision. In 2007, he founded Tanya Industries, a company dedicated to developing advanced bituminous products such as emulsions, polymer modified bitumen, and chrome rubber modified bitumen. which have significantly contributed to the sector's evolution. In 2015, Mr. Katal took the helm of OOMS, a global leader in PMB, leading its India and SAARC operations. Under his guidance, India has grown into a powerhouse, operating 5 state-of-the-art manufacturing facilities and offering a diverse portfolio of innovative, value-added products and solutions for road and runway construction. His strategic vision and unwavering commitment to quality and innovation have positioned OOMS India as a leader in infrastructure development products. Mr. Katal's forward-thinking approach and dedication to excellence continue to shape the future of the Indian infrastructure landscape, driving progress and delivering products and solutions to meet the country's growth needs. We're very happy to have Mr. Rajiv Katal as our next speaker. Thank you.
Good evening, ladies and gentlemen. Thank you, Cube Highways, for giving this opportunity. It gives me a great pride to stand before you today. Over the past 25 years, OOMS India has journeyed from innovation to a legacy, playing a major role in shaping the infrastructure of our nation. Our story began in 1913 with the establishment of OOMS International in Netherlands. Fast forward to 1999, we introduced PMB technology to India. Over the years, we have launched groundbreaking innovations like glass grate, crack sealants, became a wholly owned Indian company, and achieved NABL accreditation in 2020. Most recently, we have developed advanced solutions like cold and hot recycling regenerating agents in year 2023. The timeline shows not only our progress and innovation, but also our commitment to excellence. With operations in over 30 countries, OOMS has left its marks on roads, runways, and highways across the globe. Our products include modified bitumen and emulsions, have been integral to the development of over 120 airports worldwide and thousands of kilometers of highways. Each project reflects our commitment of quality, durability, and sustainability. We have a legacy of over 110 years of international experience. Our products are in action at 20+ airport runway in India and 80% of Indian defense airfield and pavements that have lived even 15 and 23 years without any need for recarpeting. Our pan-India presence keeps us well connected to serve all corners of the country. Our partnership have been crucial in our journey. Over the last 5 years, we have been partnering with Cube Highways for 15+ projects and have been handled 160,000 metric ton of bituminous product for them. Our collaboration with CRRI resulted in the development of hot regenerating agent tailored to Indian roads. These innovations underline to focus on addressing the challenges of the future with cutting-edge and cost-effective solutions. Developing a custom CCPR emulsion has a challenge we loved solving. We were asked to formulate the CCPR emulsion, creating the right balance of viscosity and residue content was no small feat. Yet, though rigorous R&D over 20 formulations, we have successfully in creating a solvent-free, environment-friendly product that exceeds the Indian standard. This is the essence of OOMS India, turning the obstacle into opportunity. Let's take a moment to reflect on some great numbers for the Ghaziabad-Aligarh Expressway project. We have produced 5,400 metric ton of CCPR emulsion, nearly 5,000 metric ton of PGPMB 7010V, and handled over 13,000 metric ton of VG grade bitumen, and over 1,500 quality tests done. This was also the first trial e-locking facility for bituminous vehicle between Cube Highway and OOMS as per the ministry guidelines we have done. Each number shows how efficient, creative, and dedicated our team is. Here are some pictures of the plant walked through during the record-making feat of 100 lane kilometers in 100 hours. The team from Cube Highways visited our Mathura plant to see the production of PMB and emulsions. At OMS, sustainability is not just a trend, it is our duty. Our product, Rejubit, jointly developed with CRRI, restores aged binder to their original state with enhancing their strength and enabling to reuse of 80% of reclaimed road material. We are conserving natural resources, reducing environmental impact. Rejubit currently is being used with Cube Highway and SCC in the eastern part of our country. As we celebrate 25 years of innovation, let us remember that our journey is far from over. Together with our support, we will continue to set new benchmarks, contribute to nation building, and help create roads that stand the test of time. Thank you for being a part of this incredible journey. Let us keep paving the way forward together. Thank you.
Thank you, Mr. Rajiv, for sharing your company's contribution to the India infrastructure. I think now we're at the time where we can open for questions. So please feel free to grab the microphone and ask our speakers questions.
Hi, my name is Sanjay from Wittgen, and my question is to Vishal. Vishal and Team Cube, first of all, again, congratulations for this super convocation today, and this coal recycling. You know, you set the benchmark in the industry, I would say. I think it's the first company in India who has done 110 kilometers unconventional, against a lot of thoughts on this. That's good, thanks, congrats again. But what do you think going forward? What's next? I mean, Cube is one, but India has 140,000 kilometers. How do we take this forward?
So, so my take would be, so we are trying whatever best we can do. So if you see, we are discussing with NHAI, we are discussing with more, we are telling them what we are doing, how this is benefited India. And eventually what we feel, this will come, not now, maybe after 5 years, 2 years, 5 years, 10 years down the line, because recycling is something which eventually has to be there if we are doing maintenance. Because the aggregate, there will be limitations at some point of time, not today. If a company like Cube Highways, if they are understanding about recycling, we are using it. If you see even in hot mix, if we see BC, there is no guideline for bituminous concrete. We are using in bituminous concrete also. So the idea at Cube Highways is always to go for sustainability, to increase the percentage of the RAP wherever and the way it is possible. So this is from this is my perspective. Rest we'll see how it goes.
Thank you for the question and answer. Maybe we have time for one more question. If not, that's okay, since we're kind of running behind.
So ladies and gentlemen, with this, our third session of strategic perspective and initiatives on bituminous materials in CCPR comes to an end. Thank you, Dr. Sharma, for chairing the session, and thank you so much to all our speakers for such insightful discussions. The ideas shared today are a testament to the collective knowledge and expertise in this room. Let's continue to exchange ideas and collaborate towards a sustainable future. And with this, we are going to close the session, and this session has highlighted the critical role of quality assurance and cost optimization in the production and supply of bituminous products. With the knowledge shared today, We are equipped to set new benchmarks for the excellence and infrastructure development. Let us take this vision forward, leveraging the insights and expertise shared during this session. Now I would request Dr. Sharma to please present the mementos to our speakers. So firstly, we have with us our speaker, Mr. Rajendra Sisodia. Next, we have with us our speaker, Mr. Vishal Kataria. Next, we have with us Mr. Kapil Bhatt. Thank you so much, sir. We would like to thank our next speaker, Mr. Rishad Molboy. Please put your hands together for our next speaker, Mr. Rajiv Kathil. Now I would like to request Mr. Rajendra Sisodia to please present a memento to Dr. Stephen Sharma. I would request all our speakers to please come forward for a group photograph. Thank you so much. Thank you, everyone. So, ladies and gentlemen, as we all know, we are running out of time. So, we are planning to cut the tea break and we are going to move ahead with our next session. I believe all of you had an insightful day which is filled with rich discussions. As we transition into the final technical session, we dive into the global experience of CCPR, performance evaluation, and sustainability. This session will provide a thorough analysis of CCPR implementation from an international perspective, focusing on its long-term performance, mechanical response, and sustainability impact. We'll also be exploring case studies, including real-world examples of CCPR technologies in action and their measurable benefits for the environment. This session, as with the others, have been carefully designed to address crucial aspects of CCPR, aligning with our shared goal of advancing sustainable infrastructure and paving the way for more resilient and eco-friendly roads. Without further delay, I would like to introduce our chair for this session, Dr. Reddy, Chairman of Cube Highways, to lead us through the discussions. With huge round of applause, let's welcome him on the stage. And our speakers for this session are Dr. Stephen Sharma, Technical Director, Ingevity, US. Ladies and gentlemen, can we have a huge round of applause for our speaker? We have with us our next speaker, Mr. Bhanoj, Vice President, Strategic Analytics, Cube Highways. We have with us Professor J. Murli Krishnan, Professor, IIT Madras, and Ms. Sippy Kumar, Senior Vice President, ENS, Cube Highways. Can we have a huge round of applause for the entire session speakers? Over to you, sir.
Good evening. Since morning, over 3 engaging sessions, I think we had a very elaborate discussion on various building blocks of CCPR, starting with investigations, strategization, materials, SOPs, implementation, and so on. So we're now heading into the final session. This is on global experience of CCPR, performance evaluation. And since morning we have been using this word sustainability largely basically subjectively. So we have a speaker in this session who will define basically what sustainability means and how do we measure. So I have 4 speakers here, Dr. Stefan. So 3 of them we already know, so we'll skip introductions. When it comes to Ms. Sippy, like now I'll introduce her. Dr. Stefan will present field studies of CCPR and, with reference to international experience. And then, we would like to know, basically, where does he put, this JAPL when compared to, the international experience. Bhanoj will speak on a very important topic for success of this, which is basically aggregate, gradation. Professor Murali Krishnan, so he will speak on evaluation of strength gain on CCPR. In the morning, I think we had some discussion on how quickly we can open this to traffic. This therefore becomes very important and relevant. And then finally, as I said, CP, on sustainability, how do we measure and what do we measure to say that on a sustainability scale, where does this rank? So I'll now invite Dr. Stefan, to share his international experiences with us. Thank you.
Thank you. Thank you, Dr. Reddy, for the introduction. So hopefully you're not too tired of me yet. So the good news, it's my last presentation. So I'll get started. Really want to give you an international perspective on the use of coal recycling. So this is what I will be covering, with really an emphasis on how to incorporate CCPR or coal recycling in a rehabilitation scheme, and really want to emphasize a few case studies. So we'd like to pick 3 countries: the US, China, and then Malaysia. Malaysia, I like it because it's, a climate very similar to India, so hopefully there is some similarities that we can benefit from. So it's a little bit of a case study marathon, so I'm going to go a little fast because there's quite a bit of information to cover. So before doing that, again, I know we're kind of, don't need maybe to say too much about the background on CCPR, but there is also something that we're seeing a little bit in the US and maybe elsewhere is CCPR is gaining popularity, and one of the reasons, besides being sustainable as we were talking about, but it's just practical aspect. One practical aspect is that there are some places where the amount of RAP is growing. The RAP stockpile are becoming bigger and bigger. So, how to deal with that, how to consume it. If you put it in hot mix, maybe you put 30%, 40%, but your pile will not shrink too much. But if you do 100% RAP or 90% RAP, you can consume your RAP quicker in a cost-effective way. Then another phenomenon is in the US, the asphalt industry is really on board with sustainability, CO2 reduction, and hot mix producers are open to the idea of doing CCPR because that's something they can do themselves. They can really be part of this process. So there is a more of an incentive from the industry perspective. So we can say the stars are getting aligned, and it's probably a good, there's a good potential for CCPR in the future. So one thing we can keep in mind is coal recycling, CCPR or in place, is a very valuable option when you are in that pavement decay curve in the rehabilitation area. Mill and fill is very traditional, but we shouldn't really forget about some of these coal recycling techniques that are there to solve structural problems, because they can really address the problem. And really specific to that point, what I'd like to emphasize is, the thickness of your treatment is very important when it comes to a structural repair. Because if you do a pavement design, and if you only do, for example, you have a fairly distressed existing road, and you will do only a mill and fill with a relatively thin hot mix layer. So if you do 5 centimeter of a mill and fill, there is a specific example here based on project conditions as far as subgrade value and traffic. But basically the point that we're trying to make here is if you do just a mill and fill, your design life may be less than 2 years. But if you can treat your pavement structurally deeper and you combine a 10 centimeter CCPR with a 5 centimeter overlay, or even a thinner overlay, a 4 centimeter overlay, then your life expectancy really goes up a lot. So you can get more than 10 years. So again, you know, if you do your pavement structural design and the cost effectiveness of the treatment, sometimes you're better off spending a little more money going deeper in your pavement, but you get a much longer life and it's a much more cost effective solution from a life cycle cost standpoint. So I just wanted to emphasize that, you know. So now let me go back to really the purpose here, which is to share a few case studies starting with the US. So I'd like to mention a project from NCAT, so National Center for Asphalt Technology at Auburn University in the US. That's a very influential entity. They do very good research, and they're basically, whatever they say is what many DOTs will follow. So it's, again, a reference in the field for us in the US. So recently, they've really looked at pavement maintenance treatment, pavement rehabilitation, and including coal recycling. So they built in 2015 some test sections on what they call their high volume road. So it's US 280. And basically, they wanted to test the concept of using coal recycling as a binder course with a very thin overlay. So the overlay is only 2.5 centimeters over a 9 centimeter coal recycling. So it's a very kind of lean treatment. So they wanted to test the effectiveness of this kind of rehabilitation approach on a high volume roadway. And they built different test sections. So that's again started in 2015. And they build CCPR and CIR. Also, in their sections, they used foam and emulsion as the stabilizing agent. So it's kind of very interesting, and it's again very heavy traffic, fairly heavy traffic, 18,000 vehicles per day with 16% trucks. So as of 2024, the roadway has seen about 5 million easels. And again, it's only with a 1 inch or 2.5 centimeter overlay. So what's really interesting, and you can find their research results online at NCAT, so you can download all the evaluation that they've done. So they've done many things, but one of the thing that they did on this study is to run FWD. And FWD, you can use it to back calculate the structural coefficient or dynamic modulus of the layer. And what's interesting, based on the 4 sections that they have, CCPR and CIR with foam and with emulsion, they can back calculate a structural coefficient or a modulus value. And some of the values turned out to be very high. If you're not familiar with structural coefficient, typically hot mix is 0.44, and you had the CCPR that was 0.66, well in excess of hot mix asphalt. So basically, to summarize, it's telling you that the cold mix can be as strong as the hot mix. So that's very encouraging, because that's the kind of input you need in your pavement structural design. So very, very favorable result from in situ evaluation based on FWD. Now, they are monitoring the performance, and condition of the roadway over time is very critical. How well is the treatment working? So in the US, they like to follow what they call MAP 21, which is the way to look at the performance in the field. So very quickly, as background, they look at cracking, rutting, and roughness or smoothness. And they have established, based on recent laws in the US, some typical guidelines for what is considered good performance, fair, or poor. So these are the limits there. So you can see if you have less than 5 millimeter of rutting, it's very good. If you have less than 10 millimeter, it's in fair condition. Cracking and smoothness, you have the limits there. So of course, we want the roadway, we want the treatment to remain in good condition for as long as possible. or at least to be in the fair condition. We don't want to go back to the poor condition. So in other words, how long does it take after you do your rehab to not be in the poor condition? So here it is. Again, NCAT is great because everything you can access it and you can read it for yourself. And they even have an online real-time information regarding the performance of all their sections. So if you follow the link, you can go and see what the condition of the roadway is as of today. So again, built in 2015, so that's 9 years later, and so far 5 million easels with only a 4 centimeter overlay and the cold mix being the binder course. So you can see the performance. So all the treatments overall are doing well. So after 9 years, everything is in fair condition or better. For example, the Emulsion CCPR is in outstanding condition. After 9 years, it's still in the good condition as far as cracking, rutting, and smoothness. So that's very, very impressive. So that's the proof, I believe, there that cold recycling combined with a hot mix overlay is a very effective technique. So you can see, you know, the cold recycling section doing very well. So now let me switch, and I know I'm going to run out of time, so at the end I'm going to really fly over some slides, so sorry for that. So I'd like to talk about China a little bit. Some other people mentioned their approach to recycling. So China has been really very much embracing recycling as a whole. So they started evaluating Emulsion CCPR in 2006. I actually worked in China starting in 2011 until 2019. The last 14 years, basically, 15 years. So I had a chance to see many of their projects that we see on the map there. So basically, their first job was in 2006, and we've seen a very strong adoption of the cold recycling technology to address some of the issues there. And basically, up to date, they've done more than 10,000 lane kilometers of Emulsion CCPR. And it's very interesting to see the history where basically they started as a replacement of the aggregate base, their cement-treated base. So that was very successful. So they moved up in the pavement structure. Then it was the bottom HMA layers. So did that for many years. And then in 2015, they moved to the binder course and put Emulsion CCPR as the binder course, which would be here the equivalent of your DBM, with only a hot mix overlay on very heavily trafficked roadway. And now we're at the phase where they in China do even binder course, cold recycling with the thin overlay, and they can do the overlay on the same day of the cold recycling when needed if you have really congested areas. And they're at the point where some design institutes are accepting the 1-to-1 ratio of replacement hot mix to cold recycling because it performs so well. So now they say, okay, we give it the same structural value, which is pretty amazing. So it's a fairly mature technology there in China now, also because they have a policy where the government says, if you fix this expressway or this road, you have to reuse 98% of what you take from the road. So what to do? You know, CCPR is kind of the way to deal with it. Otherwise, in hot mix, you could maybe do 40%. So what do you do with the remaining, you know, RAP that you get from the project? We also have a very mature, they have a very mature specification, and I've done a large project for the last, since 2006. So I want to give you a quick example what happened in 2019 because it was a very congested roadway. They wanted to do cold recycling as the binder course with a thin overlay, but they had very limited work window. So they said, we need to do everything on the same shift. So everybody was like, can we do it? So nobody knew if it was really possible. We thought, we're not sure what's going to happen. If you put hot mix on the CCPR that hasn't cured, will it make the hot mix standard? Will it be stable? So we thought, well, let's try it and see what happens. And it turned out to actually be very successful and have no issue with the construction. So that was a milestone there showing that this could be done with the same day. So here are some of the details about the project, where basically they put the HMA overlay on the same day. So I'm moving to the third case study. So that's a project in Malaysia. I really wanted to bring it up because Malaysia has very similar weather conditions to some of the places here in India. So I thought that'd be maybe a good parallel. So what's very interesting there is they kind of saw what they were doing in China, and they got the idea to try this coal recycling as the binder course. Because one of the typical treatment that they do in Malaysia is what they call mill and pave, where basically they mill, as I will show you here, I'm going to go a little quick here. So basically they do what they call MP 110. So it's kind of 110 millimeter rehabilitation. So it's milling 110, replacing 60 millimeter with a binder course, and then putting another 50 millimeter of a wearing course. So that's the typical rehab technique, and they can do it in one shift because it's very heavy traffic on some of their main expressway. So they wanted to try coal recycling and do the exact same thing. Can I use coal recycling on my very heavily traffic roadway? That 15-year design had 60 million easels, so very heavy traffic. So binder course for coal mix, and then can I just put my HMA overlay on the same day? And they also wanted to know, could they go even as thin as 60 millimeter coal recycling as the binder course, which is what they typically do when they use hot mix as the binder course. Historically, the minimum thickness that I think people are comfortable is around 7 centimeters. So we were not too sure about 6 centimeters. So we thought, well, we can try and see what happens. But at the same time, could we also do a section where we're going to go with 80 millimeter just to see, if thickness plays a big role or not? I'm already out of time, so I'm going to have to skip a lot of things. But in maybe less than 2 minutes, I'm going to try to finish. So you can see here some details about the wrap stockpile. That's a challenge. What do you do with all this wrap that they have there? That's why they're looking into CCPR. They want to consume this mountain of wrap that they have, so they bring the fractionation, like what you did on your project here, and then did all the good work that we need to do ahead of time as far as formulation, mix design, QC, and all that. Do the job mix formula, so establish the mix design in the lab, do the plant mix lab compacted to verify the mix design is okay, it matches the original job mix formula, so that's done. So we move into production. So they set up their CCPR plant. It looks a little rough because that's actually an old cement treated base that was converted, but if you have a good process to make sure that the components are metered properly, you can really make it work very well. Actually, that plant made a very consistent mix. So you can see what the mix looked like being produced in a dual shaft pug mill and then loading the truck, very similar to the project here. Now we're to the project where basically we did the mill and pave on the same day, because it's very, very heavy traffic, 60 million 15-year easels. So doing the good work as far as producing the mix, placing the mix, compacting the mix, doing the QC, so you have everything kind of right and consistent. And then what's very interesting is really the performance follow-up, where they did a very in-depth performance follow-up where they did coring at different time, at 14 days, 3 months, 6 months, 9 months, 12 months, measuring the properties of the cores from the cold mix binder layer compared to the traditional method, which was very interesting on this project. You had the traditional way of doing things, and next to it, on the same lane, with the same traffic, you had the CCPR binder cores at either 6 or 8 centimeter thickness. So taking field cores, measuring mechanical properties, and also looking at the pavement condition. So I'm sorry, I'm going to have to skip that because of time. So these are all the core results. It's very interesting. Now the field performance, so if that's something we really want to look at. So that's after 1 year of traffic. Again, it's only a 5 centimeter overlay over the CCPR binder course. And then you can compare the thicker and slightly thinner section of the CCPR binder course versus the traditional alternative, which they call ACBC asphalt concrete binder course 28 millimeter. So a comparison. As far as rutting, comparing the pre-construction versus after 6 months or 12 months, all the sections are performing very well. So there's really, you're still in the good condition there as far as rutting, less than 5 millimeter. Cracking, no cracks after 1 year at all. So it's going very well from that standpoint. IRI is still in the good condition for all the sections. And this is kind of what it looks like. So you can see in the upper picture, that was the condition of the road before. You had very severe cracking. And then doing the rehab with the CCPR as the binder course compared to the traditional mill and pave with full hot mix, everything is in really good condition after 12 months. We went back recently in August of this year. So again, the road is still in very good condition, And then I'd like to introduce the next milestone, which they're doing now in Malaysia because of the success that they've had so far based on this project. There are still some sections that are very heavily trafficked and so congested during the day, they cannot do the rehabilitation during the day. So they have to do the work at night, and they have to release to traffic everything at the end of the shift. So we have to do the cold mix and the overlay on the same shift at night. So you can see the picture there, that's the paving of the CCPR at night, and then they put the hot mix on the same shift. And that was actually done earlier in October this year. And looking at it, a little more than a month later, everything is still in very good condition. So time will tell, it's still very new. We need to look at it in a few years, but this is really a next milestone. And I'm not saying this is what we need to do, this is what we want to do with CCPR. If we can let it cure, let it gain strength, and then put the HMA overlay, the less risk we take, the better chances of not having problem we'll achieve. But in some cases, if you have to do it on the same shift, then you have no choice. Either you do it or you don't do it. So, again, I'm sorry for going over the time a little bit, but it used to be that coal recycling was believed to be a low volume roadway, maybe treatment. So I think we have, evidence from many past projects, including the very well documented US NCAT project from 2015. And there's so many other projects that we are aware of to show that you can use coal recycling even as a binder course on very heavily trafficked roadways successfully. So we just, I went over 3 case studies from US, China, and Malaysia. Sorry, we're very limited with time, but so far, again, if done right, as far as field performance, in terms of cracking, rutting, IRI, it can be very successful. We see some amazing trends. In China, on some projects, they give the same structural value for cold mix as they give to hot mix, which is pretty amazing. Again, I'm not saying you have to do that. If you want to give 1.25 versus 1 ratio, it's okay to be conservative. You give more thickness, you get probably longer life. But, experience and performance will tell us, can it be closer to 1-to-1? Maybe. You can do very rapid construction if needed. The overlay can be done quickly. And then we see that in some cases, recent cases, it can be done also at night. So I want to thank you very much for your time. I apologize for speeding up a little bit and not having enough time to go in more depth. But thank you again for your time.
Yeah, thank you, Dr. Stephan, for presenting the case studies from US, Malaysia, and China. So what caught our eye was the 25 millimeters thickness on CCPR and the same day overlay, both in China and Malaysia. So we'll definitely reach out to you for more details on this. I know there were a lot of details because of time we couldn't. Anyone here, if you need any more details, please write to us. We'll procure those details and supply. So we'll move to the next topic, influence of aggregate gradation on the performance of CCPR. So Bhanuj, you have 10 minutes time, I guess strictly 10 minutes time.
Thank you, Dr. Reddy. I think, so 5 minutes Stefan has taken from my time, but yeah, it's fine. So, we'll try to cover it up. We'll be back one day. Thanks. So, today, I mean, this is some interesting topic, but it's a little bit complex, but we'll try to make it as much easy as possible. But first of all, I should kind of thank, because this is the paper which we have presented in TRB 2024. So, where we have kind of showed influence of aggregate gradation on the mechanical characteristics. So, this work was kind of a joint work which was done by Amarjit. Right now, he is doing his PhD in US. Dheeraj, Mr. Arpan, Dr. Murli, Professor Murli Krishnan, and then Dr. Stefan and myself. So, it's a joint work based on the data diligently collected by our team on the ground. So, we'll try to throw some light. What is the influence of, is there any real influence of aggregate gradation on ITS? That is point number one. If yes, what are the sieves? Because at the end of the day, we cannot control every sieve. We cannot keep a bound to every sieve saying that I need aggregate gradation band to be like this. Because we are talking about real life project where we are going to get RAP, where it's tend to get variability. So what are the critical sieves that we need to look at? That is one we are going to touch upon. And one more interesting thing that we have identified as part of the study is milling speed, milling depth. Does it have any influence on mechanical characteristics? So we found some interesting insights in it. So hopefully, we'll go through that. Yeah. So this is the broad agenda that I will be covering. So most of the people have already mentioned, so we have 3 base camps. So each base camp is equipped with separate CCPR plants. So we are talking about 3 CCPR plants. Here, the project length is a little bit squeezed because we have removed that first 10 kilometers and last 20 kilometers where we did conventional methodology. For this work, we have only considered where we have executed CCPR. So the other interesting aspect that I want to kind of request audience to kind of remember, at least for the next 5 minutes, is if you look at the payment condition, so carefully if you look at, so section 1, about 70% is in poor and very poor, whereas for section 2, we are talking about almost 98% is very poor and poor. And section 3 is about 85 odd percentage. So it has a relation, that's why I'm asking you to remember how it actually kind of plays out in the quality control. So, people might feel like, but why do you want to do this research? Is there any need? So, what when we started this work, the ITS values were here and there. We are not able to control. What is happening, we do not know. One day we get 700 kipa, another day we get 1000. Suddenly, next day when we cache them all, we get 200. It is not meeting our specifications. So, what is actually happening? So that's where we kind of got a motivation. Okay, fine. Let's try to understand why there is this variation. From where actually we are getting this variation. So that's how the motivation has started for this research work. So this is the kind of I think many of you already would have seen in many of the presentations. This is the mixed design that we have followed, where we are targeting about ITS value of 310. Whereas as part of our mixed design, we got about 450 kipa. And this is the gradation band that we are having. So for the data collection for this research work, we have collected about 350 data points, which is used for the analysis, in which section wise you can see in section 1 it is about 100, in section 2 it is about 140, and section 3 it is about 115 data points that are collected. When I'm saying data points, so it has 2 data in each set. So one is dry mix, other one is wet mix, because dry mix will give us the kind of a gradation before adding emulsion, cement, water, any of those things. So that we have directly taken from the charging belt, which we directly get from the cold feeder bins. And then there is one more data set which is corresponding to the same dry mix. So where after mixing, whatever we have got from the mixed plant. So we have collected that sample as well. That we have used to kind of look at ITS. Initially, we also want to look at airwords, but it was becoming complex. So we have restricted ourselves to ITS value. So we have gradation from the dry mix, and we have ITS, which will be referred as mechanical kind of a property. So which will be used to on the wet mix. So this is the gradation that we are having. So from here, I mean, it looks like it's the one thing I would say, like it's very well, in fact, maintained or managed, I should say, because like for a RAP gradation to have this kind of thing is very difficult. But however, still here also, if you look at compare from section 1 to section 2, section 3, there is a variation that is there. So how this variation is actually playing, we will see. So for the data analysis purpose, we have used 3 different approaches. One like quantification of homogeneity of the data, and the second method is about statistical, which will be like very straightforward, which many of us know. And third one is about maximum density line. This is coming from Fuller-Thompson research work, which was conducted in 1920s. So how a densely packed structure, how it is kind of going to create. So these are the 3 methods in which we are going to kind of look at in terms of variation of the aggregate gradation. So if you look at the first aspect, when we talk about homogeneity of aggregate gradation, so based on the research that we have conducted, so we are trying to identify, okay, what is the best method where we can, is there any homogeneity equation? Because many people have done research work in terms of aggregate gradation. So when we, out of that research work, we are able to find this particular equation where we are talking about like homogeneity curve. So here the like dependent variable is like, we are looking at standard deviation, and then we have percentage passing in each sieve size. So this particular equation, this is a kind of an regression equation. So we are going to identify A, B, C, which are so based on the data that we have, we will try to fit in. So what it actually talks about is at a particular, let's say we have 9.5 mm sieve and then 4.75, 2.36. So for 9.5 mm sieve, if you look at, let's say in one particular batch, it might be 90% passing. In next day, when we have taken the material, it might be 80% passing. So what we are looking at is like in terms of this percentage, what is the standard deviation that we are observing? That's what we are looking at to identify which particular section is showing better homogeneity. That's what we are looking as part of this particular study. So if you look at, these are the kind of an curves, like once we did that regression, like when we looked at, so from here you can clearly see section 2 is showing better in terms of homogeneity than section 1 and section 3. So these are the equations. So I mean, these are like we do not have to get into those equations. So then we were curious to know, okay, so why section 2 variability is less than 1, then 3. So if you remember the first slide where I asked, where I requested you to kind of remember very poor sections. So if you look at the table that is there on the right side, so like which clearly talks about in section 2, our milling depth, like greater than 100 mm, we are talking about when it's great, it can be 100, 120. So we are having about 95% of section. And whereas if you look at section 1 and section 3, there is a variability. But if you would have noticed, or if you remember what Mr. Arpan told in his talk, we have ensured the milling speed to be constant throughout the project, irrespective of the depth of the milled surface. So now there is the answer. So like which clearly shows to have constant milled speed, irrespective of depth, will result in variation in terms of gradation, which will result in the influence of the homogeneity. So that is what the study kind of is giving light, like throwing light. So what we need to look at, if there is a like depth is varying, then automatically we need to identify what should be the milling speed. These are the learnings. So like this also we get to know after carrying out all these things. So now if we move to the second aspect, where we are talking about statistical approach. So like it is like a lot more straightforward, but there are too many numbers. But if you look at carefully at the numbers, especially from the standard deviation point of view for section 1, section 2, section 3, it clearly showcases for every particular sieve, maybe leaving 75 micron, every sieve, like section 2 is having lesser standard deviation, then section 1, then section 3, which again substantiates what we have kind of discussed in that homogeneity curve. So which means section 2 has a better wrap in terms of gradation than the other two sections. So similarly, we just wanted to kind of look at, those are the numbers. We also want to look at in terms of what is the range that we are talking about for each particular section. This again, it represents this is a violin plot where we are talking about on y-axis, if your plot is let's say a little bit larger, which means it is showing that there is a higher range, which means the difference, we have very huge difference between minimum and maximum. Sorry, my time is up, but I will try to cover up in next 5 minutes. So we are talking about if that violin is little bit bigger, so then we are talking about there is kind of an non-homogeneity. So it also kind of clearly shows that section 2 has better kind of wrap. Now if you move to maximum density line concept, so where we are talking about Fuller-Thompson. So I mean, maybe you might not heard about Fuller-Thompson, but every day whatever gradation that we use in our quality control is coming from that concept, which was developed in 1920s. So where he has kind of studied and told that to have the maximum packet density for any kind of a mix, it should follow this particular equation where which is kind of people call it as 0.45 power equation. So if it is kind of fitting that, that's the maximum density that one can achieve with respect to a mix. So so what we are trying to identify, okay, so we have that maximum curve, and if you look, you may get a doubt that it's a power function, why are we having a straight line? So this x-axis on the graphs that we are showing, it's power 0.45, so automatically that equation got y equal to x, so it is kind of a straight line. So when the gradation is also kind of adjusted in that manner, if you clearly notice here, there is a pattern that is changing here, where between 9.5 and 4.75, there is a shift that is happening from the gradation where it is moving from positive side to negative side. So, I mean, just remember this, there is also kind of an why that has an impact. I will kind of tell in next slide. So, to understand better, because this is about aggregate gradation variability. Now, at the end of the day, what we want to answer is aggregate gradation have any impact on mechanical properties, which is ITS. So, for that, what we try to identify is we have tried to calculate the deviation between that blue color line and the green color line for every particular sieve, which we are saying percentage normalized deviation. So from that percentage normalized deviation, we try to compare with respect to our ITS values. So to see is there any kind of an impact on it. So before that, I mean, I'm going to make a contradictory statement. Even I'm also 100% not sure why this is behaving in this manner, but however, to the audience, if you look at here, section 2 has higher standard deviation in terms of ITS values. Now, there can be a question that can come up saying that aggregate gradation, section 2 has the best, then how come when it comes to ITS value, we have higher standard deviation? I also do not have 100% surety answer to it. So, there is a kind of an possibility reasons with respect to kind of, and we face some challenges in the testing in the middle phases when they were working with the ITS equipment. But having said that, it's not only exactly that, there can also be a situation in terms of how the mix produced. There can be n number of variables, but however, this is little bit kind of contradictory to my statement that I made for aggregate gradation. So now when we compare, because this is the final agenda, right? So now when we compare aggregate gradation with respect to ITS. For that, as I was explaining, so we have used normal deviation for every particular sieve from the maximum density line, and then for that particular aspect, we try to compare with ITS values to see is there any impact. So if you look at the first curve is for 9.5 mm sieve, so where it clearly shows for every particular section, there is a variation with respect to the normalized deviation. So which means there is an impact that is coming because of the aggregate gradation variation for 9.5 mm sieve on ITS values. Same thing if you look at 4.75, also it is also giving some kind of a similar trend. But what you should notice here is 9.5 mm via x-axis is in positive terms, whereas for 4.75 the x-axis is in negative. So which means if I go back to this curve which I asked you to remember, so what we are saying, to get better ITS, so our 9.5 should go up. That's what it is saying. So which means the coarser material should be a lot more coarser. Similarly, it is also dragging the finer material, saying that the finer material should also be coarser, then we will be going to get better ITS. This is what this data is kind of showing. So now, like for other, we did similar like kind of an exercise for all the other sieve sizes, but however, there was not much correlation that is observed. For an example, I have kept a 75 micron sieve graph where you can clearly see it is everywhere. So which means like for other sieves, there is not much impact that ITS is creating with respect to variation in that particular sieves. With this, what we are kind of safely kind of concluding, for a CCPR, at least for the conditions that we have kind of did at Ghaziabad Aligarh, if we can control 9.5, 4.75, our quality control as well as the kind of uniformity in the mix is going to be a lot more better, because those are the two sieves which are significantly showing impact on the ITS values. And the other thing that we have noticed or that we have learned is milling speed should be constant, but it should be linked with respect to the milling depth. It cannot be an uniform irrespective of whatever the milling depth is. So this is another thing where you should kind of like since Vidgan is here, you should kind of any contractor or any concessionaire who is working, we should tell to Vidgan, because I have seen some of the data shown by their milling expert last time when they visited office. They have the phenomenal data, but I'm not sure why they do not share. So like ideally they should tell for this particular depth, this is the speed you should operate to get better control in terms of wrap. So I think that one should take care. And then, so I mean, other things are a lot more, I would say, research oriented. And one more thing is like, we have also kind of did one analysis where before screening, after screening. So it clearly showcases screening plant has a significant impact in terms of having a better quality control. That is also one important thing to be noticed. So thank you so much. I hope I did not bore you guys.
Yeah, thanks Banuj. That has been very informative and a lot of numbers, a lot of analysis. I guess like all the Indian movies nowadays have part 2. I think in the next study he will tell us like why uniform gradation or like less uniform gradation is basically is leading to like the largest standard deviation. So moving on, so the next speaker is Professor Murali Krishnan. He will present the evolution of strength gain in CCPR. As we said, like this is I guess is a very useful parameter as we get to denser and denser traffic roads. So if you want to open the thing quickly, I think these findings will be very useful. So I'll hand it over to you. Thanks.
Thank you so much. And I really appreciate all of you, 6 o'clock in the evening, and you have been hearing a lot of technical things. 20 years I am teaching at IIT Madras. I have never seen such an attentive audience. So please come to IIT Madras. At least sit in my class for one day. My kids will at least learn a thing or two from all of you. Thank you so much. So I lost 20 seconds in this. So let me just start. This is a very interesting material in terms of strength gain. So let me find out what it is. So I'm just going to go a little bit on the steep side. So you just need to bear with me. This might become very technical for some of you. So if you don't follow, don't worry. Just let it go up. Okay. So I'm going to talk about the mechanics of emulsion based coal recycle mixtures. And then we did some interesting analysis with laboratory characterization with one of my MTech student. And then we also collected a field data, and in fact we have a paper lectern presentation on coming January 2025 at the TRB and some implications. So basically this is something that we need to really understand. So I'm just making it as a very general statement. Whenever you are collecting a data, your experimental techniques are at multiple scales. Macroscopic, mesoscopic, microscopic. So you are looking at different scales of observations, and depending on the scales that you follow, you are going to measure force, displacement, morphology, macromolecular arrangement. So you need all this if you really want to make some statement about such kind of evolving material. And what is this going to help you? It is going to help you to model the response of the material. So that is what I meant as constitutive modeling and all those things. Do you remember this picture? In the morning I showed you a picture about TG2. And now what I am showing you is a slightly simplified version of the picture. You see on the left hand side, on the x-axis there is bitumen percentage, and on the y-axis what you see here is percentage of cement, and you can actually connect these lines. So if you go high on the cement, you are looking at a very strongly cemented material, and if you go on the x-axis right hand side, you are going to see more like a bituminous material. An amazing study was done by Andrea Graziani from Europe. He wrote this paper in 2022 in Materials and Structures. So what they did, they went and took all kinds of bitumen stabilized material, whatever you want to call the name, and then they tried to plot it more or less in the same thing. So what you see here is a picture that consists of data points of many mixes of different dosages of cement as well as bituminous emulsion. So if you just walk from one end to the other end, you see that CTM, which is your cement treated material. Then you have a BSM, which is what TG2 calls as bitumen stabilized material. You just go up on it, you have cement bitumen treated material. So that means they are more or less in the same regime. And then if you go to the right hand side, you see a coal recycled asphalt. And then you see this 45-degree line that talks about B by C ratio of 1. More or less similar to what you call as your water cement ratio, right? So here it is residual bitumen to cement ratio. So how much is the residual bitumen is there and how much is the cement? So this is going to be like this. Now comes the challenge. How do you classify this material? It all depends on where your material is going to be. That is number one. Morning Dr. Stefan presented something about emulsion. So I should apologize because I wrote whatever he explained as simplistic. Okay, that is a very simplistic way of saying how the emulsion breaks. Emulsion don't break in the way that is done. That is typically done at a undergraduate level. We explain it in the realistic way, depending on whether your reaction kinetics are going to be, whether it is a reactive or a non-reactive aggregates, the mechanisms are completely different. So you can see that there is an evaporation kinetics. On the other side, you are going to see that there is a contraction kinetics. So these two things are going to happen, and it is not necessary that you are going to see either this or that. Both of them can actually happen. And added to this, this is a very funny material. I spent almost 1 hour in my class talking, linking zeta potential with viscous sintering, but I won't do that. But this is a very interesting picture. One of my students demonstrated that this could actually happen. It's a very interesting thing. If you want to know more about it, come and talk to me separately. And this was one of the work that was done by my MTech student. She is doing her PhD in Germany, Adira. In fact, we presented it in one of the CRRI meetings in 2019. So what really happens is when the emulsion is breaking, it is slowly breaking out, the rheological behavior also changes. So depending on the temperature that you see, it can become Newtonian, non-Newtonian to Newtonian, and that is what really happens here. So why I am saying all these things is when you take a wrap and then add emulsion to it, add cement to it, and then you expect that it will all work nicely, they are not going to work nicely. Right. Now comes the most important thing, and this is what I mentioned in the morning, that TG2 just saying that you could add all this fluid content together. You cannot. This is a 1920s reaction kinetics model on cement done by Professor Waters, and this was also extended for similar things. The reason why I just wanted to show here is when you add some water and then when you have a cement, the reaction kinetics proceeds. Now again, it all depends on how much dosage that you add. So if I add 2% cement, I can assume that there will be some hydration that will be happening. So when this hydration is happening, some amount of water that is available will be used for hydration, but it will be partially only hydrated. The water has to come from the emulsion, and this reaction kinetics is going to happen over a period of time. So what will really happen? So you are going to have capillary water, you are going to have gel water, you are going to have external water, you are going to have gel solid, and you are also going to have gel water. So that means the water from the emulsion coal recycle mixture will not necessarily lead to void after evaporation. So that is going to happen. Now, if you are looking at a volumetric analysis of this material, things can become even more complicated. So if you see on the left hand side, you see that there is a liquid and a solid. The liquid consists of emulsion. So there is a residual emulsion, there is water in it, then there is an external water in it, and there is an absorbed water in it. And so in terms of, if you look at it on the right hand side, if you focus your attention on the solids, you are going to see aggregates, that is virgin aggregate, reclaimed asphalt, recycled aggregate, cement. Now, how this volumetric analysis actually evolves when the compaction is really happening, you are going to see that the air voids are going to increase because there is hydration happening, water is being consumed. But that does not necessarily mean that this is going to be a more porous structure, because what can really happen is there can be an increase in the solid phase because of the hydration that is happening. So what we can basically say is there is a decrease of water content, there is an increase of void content, but there is also going to be increase of the solid phase due to hydration that is happening. So if you just add the sum total, it might look that there is an increase in the void content, but the modulus also will increase. So that will kind of confound you about what is really happening here. So what it means is, I just want to read this statement: volume of the reaction products formed during hydration is slightly lower than the cement and water reacted, slightly lower. That's the whole thing. And this was done, one of the study done by one of my PhD student, 2015. So we started doing work on DSM, and this is a statement that I really want to make to all the field engineers here. There is a misconception about the high air void content that you see in this material. There is a mistake here, because when you are talking about 10% air voids or 15% air voids, you are talking about one number. You are not really talking about the distribution. What can happen is, if you are talking about HME, you are talking about, you are used to a 6% air voids. Now I am laying a material with 15% air voids, and people actually get panic attack when they see this. So, but the point is, it is the distribution. So if you take a look at it, there is this 15%. So we did this computer tomography and scanned the whole thing to see what is the air voids distribution. It's one of my PhD students' work, and you can actually see that the voids are uniformly distributed. So it is not really the number, it is the distribution that you are really looking at. And then we did this environmental scanning, electron microscopy, and then CHNS analysis to try to see whether any hydration products are formed. We could not see anything for less than 1%. So that means it's merely mopping up the moisture. So this is the mechanism that we really need to understand as far as the emulsified coal recycled mixtures are concerned. So I'm just going to run through few of the things. This is a laboratory study that was done by one of a master's student, but the data was compiled by another PhD student. So what we did was, we did 4 mixes. One had 3% emulsion with 0.5% cement content, 4% emulsion with 0.5% cement content. Then we made another one with 1.5% cement content for the same emulsion dosages. So we were basically looking at how the air voids are varying. Now, how did we compute the air voids? That is a story for a different time. So you can actually see how 3 days, 7 days, and 14 days, you can see how the voids are increasing. You can actually see that the voids are increasing, and you are also going to see that the modulus is also increasing, right? So that is the point that I really want to make here. Okay, so now when I do the dynamic modulus in my AMPT that we have here, Haversine compression, do it at various ranges of frequency, you are going to see how your modulus value is also increasing. So from 3 days to 7 days to 14 days, the modulus values keeps increasing from, you can see that how it is varying as a function of frequency at 10 and 40 degrees centigrade. And then if you also see how the strength gain is happening, you see the red lines, you are going to see that from 3 to 7, there is a substantial increase in the modulus value, but you don't really see it from 7 to 14. That is what it basically says. And so you, again, I will just focus my attention here little more on the master curve. So if you see that red color line on the top picture, the modulus value seems to be slightly on the lower side. As the material is curing, 7 days curing, it just seems to come up, and then final curing, what you can see, it comes up basically. So what it means is, as the material is curing, so I have to say it, this is the x-axis is reduced frequency. So if you are talking about low log reduced frequency, you are talking about high temperature, low frequency. Okay, so the modulus values are lower, and you can actually see that the modulus value keeps moving substantially here. And then we did some fancy analysis, relaxation spectrum, Fourier rheology and all those things. I don't want to get into that, but I just want to only take a look at the shape of these figures. You will see that at 3 days to 14 days, the relaxation kinetics have substantially changed, and you can actually see that the material is gaining strength, and you see that the peak value of the spectrum keeps moving to the right hand side as you are going along. So this is about what you will talk about, the laboratory characterization. But let's talk about the most important thing, this particular project wherein phenomenal data collection was done by the people from CUBE and VRT at the time. So you won't believe it, 74 locations along the project stretch, 6 hours, 18 hours, 24, 48, 72, 92, 120, in the middle of the night, in the early morning, in that climate, people went and collected this data. In fact, if I were you, I will just clap to all the field engineers who collected this data. Amazing, amazing piece of work, because this is around 387 data points were collected, and this gave us considerable amount of information that normally you do not see in this kind of data collection that you did. And so now what you did, you see here, you can actually see how the modulus value is increasing, right? You know, this is for 6 hours, 24 hours, 48 hours, 72 hours. You can actually see how the modulus values are saying. Basically, we followed a sequence in LWD, and you may want to just take a look at what is the modulus value at a drop mass of 20 kg, and you can see that it is twice, it is increasing, the modulus value is increasing. And the interesting part here is this modulus value is also dependent on the thickness of the layer. And as you know, Arpan as well as Banoj were mentioning, you had different thicknesses at different thing. And so if you see at locations, let us say 9 to 16 on the right hand side, that green line, more or less the thickness is the same, and you can actually see how the surface modulus is varying, but there is a drastic variation on the left hand side where the surface modulus, the layer thickness was also varying. So it kind of very interesting as to what is really happening as far as the layer thickness is concerned. Then what we did was we just wanted to do some fancy stuff. So this is a very interesting model, Michaelis-Menten model. This is a paper that came in 1913. Basically, this is related to how to model the biological reaction kinetics. So what we did was we just wanted to see how the modulus value is varying. So could we model that? This is the equation that we used for modeling it. But then you will ask, but why do you really want to predict it? Because we just wanted to find out the parameters, and then we just wanted to simulate, because the $1 million question basically is, okay, so can I do like what Dr. Stefan was saying, can I do on the same day? And now your data basically shows that the curing rate more or less reaches a constant value around 20 hours or 24 hours. So that means you could do a same day paving. The next layer could be done immediately in the next day. So basically what happens, what are the implications here? Now, if you are a designer, you are going to be very confused. What is the modulus value that I am going to use as far as the design is concerned? Because the modulus value in 120 hours goes twice. So which modulus value should you use? Number one. Number two, the construction part, when to lay the next layer. So do we have answers for this? And now Dr. Stefan has papers in case studies in construction materials he has published, in which they have even documented strength gain happening over a year. So that means, at the end of 1 year also, if you go collect the data, the modulus value seems to be increasing. So now when I am going to do a pavement performance modeling, let us say I do an FWD and all those things, what is the modulus range that we are looking at? So that is going to be a very, very interesting, challenging issue here. So thank you so much for your patience. I have to acknowledge Shiv Shankar, my former graduate student, Atanu as well as Pugedin. Thank you so much.
Thank you so much, Professor. A lot of details. So now I get a feeling that we could have done this over 2 days rather than basically cramping everything in 1 day. So the final topic, we've been talking about sustainability since morning. CP will take us through basically what do we mean by sustainability. So brief intro to her. She has about 17 years of experience in environmental and social diligence, sustainability and impact assessment in the infrastructure sector. She's a key business leader at Cube Highways. An environmental engineering graduate from Delhi College of Engineering, which we now call DTU, I guess. She previously worked before joining Cube at SMEC, Halcro, SNC Lavalin, contributing to projects funded by World Bank, ADB, IFC, NHAI, and so on. At Cube Highways, she has developed ENS strategies, establishing GHG emissions reporting and integrated sustainability into operations aligning with global standards. She also advises on sustainability linked to finance and decarbonization, leveraging her expertise in frameworks like the GHG protocol, GRI, BRSR, and IFC guidelines. Over to you, Sapir.
Thank you, sir, for the introduction. So, yeah, so we have been talking about sustainability, reduction of the carbon since morning, but now my presentation will be focusing on this particular subject, on how we have estimated GHG emission reduction due to this technology. Sorry. Yeah. So let me start with the definition of sustainability. So sustainability is basically, meeting the present needs without compromising future to meet their own needs. And it stands on 3 pillars: environment, social, and economic. So on the economic front, I think one of the speakers highlighted that this technology is cost effective. I think 25% cost it reduced. On the environmental front, obviously I'll be speaking in detail. On the social front, if we are doing some good to environment, indirectly we are helping community and social aspects by decreasing the emissions which could impact their health or their living being. So in that way it covers that scope. So yes, it is a cold recycling technology, and the 2 major aspects which we have studied in detail to estimate GHG reduction are basically, in this technology, DBM layer has been reduced from conventional 150 mm to 50 mm. That is the first take, and along with that 25% wrap has been used. And the other aspect, obviously, as we have been discussing, 110 mm CCPR layer has been laid in the project with utilization of around 85% of wrap. Now, on the environmental benefits, on this also we are discussing like it reduced energy consumption and it reduced materials. So how it reduced energy consumption? So basically, as CCPR is a cold mix, so we avoided fuel consumption in the entire process. And then to run the hot mix plant, we all know that we need a high-speed diesel as a fuel. And instead of laying of 150 mm, if we are laying 50 mm, there also we are avoiding a lot of fuel. And then third thing is the transportation of the virgin material. As due to the usage of the wrap, virgin material reduction has been achieved. So in that way, the transportation impact has been also reduced, which led to fuel consumption reduction. And also, so in this project, L&T has utilized electricity to run the plants, 2 plants, and in fact they use natural gas also in one of the plants. So when we reduce the production mix, we have reduced the electricity usage also, and that is also one of the important factors of reducing the energy consumption. Now on the virgin construction materials, already we all know now that it reduced aggregate to substantial level, and it also reduced bitumen due to these 2 aspects. And other major benefit towards environment is basically it helped in avoided the landfill site or disposal issues which I think country is facing currently. I mean, we have also seen this kind of wrap material being dumped along in the shoulders, but this kind of technology has helped solving that problem also. And this is also aligned with the UN sustainability goals. So there are 17 sustainability goals, but if you look at the screen, these are the 4 sustainability goals where this technology is aligned. And in the last, you can see climate action. Combating climate action is the major SDG it is aligned with. Now on the methodology. So yes, when we started working on this project, we were not able to understand how to start, what to do, because we were not finding any kind of case study in country or in fact, in global also. So what we did, we did an internal exercise here. So we compared the conventional approach with this technology, the CCPR technology. So here we can see the 3 steps. First of all, we conceptualized this project. Now I am coming from environmental engineering background. I understand few of the aspects, but in total I cannot understand. So first few days we sat with our technical team, be it Bhanoj, his team, or Vishal. We sat many days with them to understand what are the processes involved in CCPR, what are the technical terms, what are the different layers. Now I also know what are the different layers. And then we also understood the conventional construction approach so that we can do the comparison in the later run. And after that, we also did detailed couple of site visits, in fact, to the, to all the 3 plants. We sat with, Neeraj and his team in L&T. We understood the process. We asked for a lot of data with them. That also we did thoroughly. And then we listed the GHG emission sources. GHG is basically greenhouse gas emission sources. What are the various sources which contributes to the emission of these kind of aspects. So we highlighted here, as I highlighted in the last slide, energy and material are the major contributors. And then ultimately we finalized the approach on how to calculate the reductions. Now second aspect, because we are working on numbers, data collection also was a very big challenge for us. So we started with understanding on the BOQ, because BOQ gives you the consumption, the volume of the production mix. So from there we took this volume production on the BC, DBM, CCPR layer. And then on the fuel part, so fuel part, it includes LDO, LSHS. LDO is light diesel oil, which is used for bitumen heating. LSHS is low sulfur heavy stock, which is used for aggregate heating. And then, as I said, in one of the camps, we used natural gas. We collected that data as well, which was used across the 3 plants in L&T camps. And then coming on to the electricity consumption, it was used to run all the plants and machineries at site level, like HMP, screening plant for CCPR, batching plant. So we collected that data also on the energy consumption from the readings they were having, L&T team was having. Then on the transportation front, we also understood what is the lead, what is the distance of different sources of these construction material. For example, in the bitumen, what is the refinery location? And in case of aggregates, there were 3 quarries from where we procured the aggregates. We understood that, took the distances for them. And then we used cement also in CCPR. So we took those leads to make our calculations. Then third part was data analysis and the key considerations. Now we know that we faced challenges. As I said, we faced challenges. We could not get direct data in all. So there were certain consideration we took in this exercise. So on the first of all, to calculate the construction materials, as I said, we took the volume of the production mix, and we had then the design criteria. I mean, we knew that in the CCPR how much RAP is being used, how much bitumen is used, how much emulsion is used. So we took those percentages, and based on that we estimated the construction materials like bitumen, aggregate, and cement, and RAP also we quantified based on this design mix, both in case of CCPR and in case of conventional. Conventional, we understood from the team that in conventional 96% virgin aggregate is used, and 4 or 5% bitumen is used. So those considerations we took. On the fuel consumption part as well. So it was again a big challenge for us how to take the full data on the fuel consumption. So there also we identified the intensity. Basically we took we took the data on LSHS, LDO or PNG for certain months, and then we took the data on the actual volume mix based on the DPRs. Then we identify the intensity, I mean how much LDO is used for per ton production mix. So that kind of intensity we derived for the fuel. And similarly for the intensity also, electricity intensity we also identified based on the production mix. And then based on that we identified our sources and the activity data. The other aspect was to identify the emission factor which are suitable to the Indian conditions and which are suitable to do this kind of exercise. We did that, and then we ultimately calculated the emissions in both the cases, conventional as well as in this CCPR technology, and then we deducted. Simple mathematics comes here. So I'll go to next slide and brief that. Yeah. So key considerations here I have highlighted. So, so in this exercise, we not only looked at DBM and CCPR layer, we looked at all the layers, be it BC, DBM, CCPR, WM, GS. We took all the layers because in our Q highways, we are also doing the emission, as Dr. D mentioned, we also do the portfolio level emission inventory. So in that case, we had to do this scope 3 emissions also. So we did emission for all the kind of activities, all the kind of layers in this project. And then after that, now coming on to the diesel. Here, it is a big challenge, and I think I will throw a question in the end also, how to sort this issue. So in this project, in this kind of big project, we do have lot of machineries, lot of vehicles, lot of subcontractors, lot of aspects. Here we tried to get actual data, but we found a challenge because ultimately we wanted this project to be validated also. For example, if we in our mind we had a vision to go for carbon credit also. In that way, the data should be proper and it should be validated. So in that we faced issue. We could not collect vehicle-wise or machinery-wise data. So we took that assumption, which is based on NITI Aayog's model, which says that 10% of total contract amount can be taken as the for the fuel consumption. So that assumption we have taken this project. And then additional activities which are included in the CCPR. For example, we know that bitumen emulsion is used, cement is used, and then diesel is used for running the screening plant. So all those considerations also we have taken in this analysis to do a proper or judgmental balancing. Then when we estimated the emissions, we also considered upstream emissions, which is basically indirect emissions. When, for example, when we are consuming electricity, we have also considered the emission factor related to when it was produced, let's say, at the substation. So those are called upstream emissions. So we have taken that in case of electricity, fuel, and material, all the three aspects. So other major thing which was required to be considered is the emission factor, because our emission factor is the key to estimate the carbon emissions here. So here you can see a lot of emission vector sources we identified, which includes EcoInvent. EcoInvent is basically world's largest LCA database. LCA is basically life cycle assessment, which gives data for the Indian scenario as well. So we took embodied carbon emission for bitumen aggregate and OPC cement from there. And then based on IPCC, which is Intergovernmental Panel for Climate Change, 2006, and global warming potential based on the latest report from them, we have taken the fuel combustion emissions based on that on the specified fuel in the table. And DEFRA 2023, which is UK-based factor, these are also well accepted globally. That we have considered for, again, embodied emissions for various kind of fuels and electricity. For the electricity consumption, basically, we use CEA 2023, which is Central Electricity Authority, Government of India factors, which is properly aligned with the requirements of this study. And on the bitumen emulsion, embodied carbon, we have taken from EPD. EPD is basically Environment Product Declaration. So here, for this also we face challenge because in India we don't have EPD for, let's say, bitumen emulsion, bitumen, or the PMB. So I think that is the other major question which I'll be throwing in the end of this presentation: how to, how to sort this issue, and what kind of LCA or what kind of aspects can be taken into consideration by our suppliers or vendors also. So these are the inventory which we, inventory of the emission factors which we have considered. Now these are the, this is a simple mathematics. Now when we finalized our activity data, for example, let's say the energy consumption, then we multiplied it by the factor, whatever we have considered, and we getting the tons of CO2. Now other small definition I wanted to give: tons CO2 equivalent we call. We don't call tons CO2. Equivalent is basically considering all kind of gases which leads to global warming, including carbon dioxide, methane, hydrofluorocarbons, and nitrous oxide. It is a combination of a unit measurement for GHG. So that we use. So here we can see we have saved 78,000 tons of CO2 equivalent due to this project. And a graph is also shown here which shows the conventional versus CCPR emissions. So here we can say that fuel savings have contributed majorly. 67% of GHG emission saving is coming due to reduction of fuel and due to this technology, followed by 30% by the raw material, and then rest electricity. So under fuel also, we saved around 52,000 due to fuel reduction here. And out of which 40% is due to combustion of fuel and 45% basically due to the avoidance which we did for the transportation of material, which was not required. And 14% is the upstream, indirect. Raw material, again, it is all embodied. And more important, I think one of the more important aspects which I wanted to highlight basically in these kind of construction projects, the emissions are coming majorly from the embodied carbon, not direct. Here, the raw material based emissions which you are looking at, these are all embodied. Basically, embodied means the process how they have manufactured and came to our plant. So that is the embodied carbon emissions. We are getting from raw materials around 24,000 and 1,500 are reduced due to the electricity. And in the right hand side, I have also shown rough quantities of the resource saving. So here, virgin aggregate, we saved around 0.8 million metric ton. And similarly, there are quantification of all the resources. And as we have been discussing since morning, RAP has been used around 0.5 million metric ton in this process. So this is a quite detailed table, but I will not go one by one. Just wanted to give a brief. As I said in the beginning, so we have considered all the activities in this project. You can see here, Bituminous concrete preparation is there, DBM is there, electricity, CCPR preparation, wet mix. Every aspect we have taken, and then with the respective emission factors, we have multiplied the quantities we have devised based on the approach I mentioned earlier. In the extreme right-hand side, you can see the effective GHG accounting. So here, if you see in the DBM layer, basically 55,000 we are saving. Obviously, since we have reduced the width from 150 to 50, major of our major contributions coming from that only, and that too due to the reduction of the virgin aggregates. And similarly, in the CCPR, you can see the figures are coming in negative. That means we have emitted more when we are working on CCPR. So we have used bitumen emulsion, aggregate cement, all these are having their own factors. So we have emitted more. But if we balance these things, ultimately we are getting that we have saved around 78,000 of tons of CO2 due to the adoption of CCPR. And so these are the upstream calculation, indirect calculation. Here you can see a good amount of reduction we have done. 23,000 we have saved due to the avoidance of the transportation of raw material. 7,000 we have saved due to the upstream reduction in the upstream emissions of the fuel. And then around 390 odd we saved due to the upstream emission due to the electricity, which includes transmission and distribution loss as well. So these are the challenges which I was discussing. So first thing is basically on the energy consumption, basically the fuel, diesel. So how we can combat this problem? There are 2 or 3 things. One is the, we obligate contractor to give us, monthly level data, which is being used directly and also by their subcontractor with a thorough diligent monitoring. Then only this problem can be solved in the country. And other thing is basically if, we have very good research people also here. So if anyone can do the research and, find out what is the machinery or equipment or vehicle-based emission factor, that also exercise we can do to overcome this problem. And the other major challenge which we faced, as I mentioned, we could not get India-specific emission factor for bitumen, PMB and bitumen emulsion. So in that way, I was discussing with Mr. Rajiv also, who has come from OOMS, to do LCA. LCA is basically life cycle assessment. Basis that we can have India-specific, or we can say the vendor-specific emission factors, because there also they do a lot of lot of changes. They were telling that they have now started using biomass, which in turn reduces emission factors. So we should have, if Cube is working with these contractors in the long term, I think we should encourage them to do the LCA for these aspects. Similarly, for the modification which has been done again by the third party. So this will further authenticate our calculations. And And the last thing which I wanted to highlight is basically monetization of GHG savings. So here also Cube Highways is trying, though I cannot guarantee we will be successful, but we are trying to venture into voluntary carbon market based on the emissions we are saving due to these kind of technologies, not only GAPL, but other projects also where we are using these technologies in periodic maintenance. So one of the carbon credit registry is Vera, which based on our feasibility study, can accept, I mean, we can go ahead and venture into this. And when we searched on this thing, we found that so when we go to a carbon credit market, we should have a methodology which is accepted and approved by the relevant authorities, UNFCCC. So we have found that there is one methodology which is used in US. So that means this kind of CCPR projects are being used, and people are taking credits there also. So why not India? So we can develop such kind of, we can venture into developing such kind of methodology by, collaborating with the consultants who are working in this area, and then try for this try in this voluntary carbon. The challenge which we will face here also is the data, because the carbon credit projects also rely on the accurate data, because a lot of validation and verification is done both on the baseline data and the emission factors. So there we need to strengthen our approach so that we can venture into that. And in fact, in the Indian scenario, the carbon trading has started in India also. In fact, India has also listed 13 activities for trading in the carbon market, in which one of the activities is high-end technology for energy efficiency, though its definition is not clear because it is quite new or young, I can say. But we can venture into that also. Once we start with this voluntary carbon market, we can look for venturing into the carbon trading in India and seek the host country approval. So if we get host country approval from the relevant authority in India, that can easily be monetized with the proper, I mean, with the better rates. So in the voluntary carbon market scenario is not, I would say it is not very much encouraging because rates are low. I think it is 1, 2 or 3 USD per tons of CO2 equivalent. But if it turns into the compliance market or in the Indian scenario, which is being developing fast, we can have the better rates. Let's say around 18 to 51 USD per CR. So you can say here. So CORSIA is basically carbon offsetting and reduction scheme for international aviation. So what they do, they basically cannot reduce fuel they are using because they have to run their crafts and those. In that case, they purchase the credits, they offset and purchase the credit from the international market. So based on the MSCI price forecast in these ongoing years, so their rate they have forecasted around 18 to 51, which I was talking. So these are the kind of future scenario or the development in the trading also, which can be explored further, and I think we can benefit from them. Yeah. Thank you so much for hearing me.
Yeah. So thank you so much, Sippy. I'm afraid I don't think we really have time for questions. I guess, yeah. So if there are any 1 or 2 questions, we can take. But keep if you have any doubts, questions, further information, please do write to us. We'll reach out to speakers and get that information. Yeah, good. Okay, so thank you so much to all the speakers. This was really engaging and a lot of information. So I'll now hand it over to you.
So with this, the final session of today, Global Experience of CCPR, Performance Evaluation and Sustainability, comes to an end. And for that, I would like to thank our chair, Dr. Reddy sir, for chairing this session, and also thanking all the speakers for their valuable contribution. As a token of appreciation, we would like to present the mementos to our esteemed speakers. I would like to request Dr. Reddy sir to please present the mementos to our speakers. So first we have for our this session, Dr. Stephen Shammer. We would like to thank him for his contribution. Please put your hands together. Next we have with us Mr. Banuj, our next speaker for the session. Thank you once again. Next we have with us Professor J. Murali Krishnan. And for this session we have Ms. Sippy. Can we have a huge round of applause, please? Now I would request Professor J. Murali Krishnan to present the memento to Dr. Reddy sir. Thank you once again to all our speakers, and I would request you all to please come forward for a group photograph. Thank you so much. Thank you all the speakers for their remarkable contribution to today's session. It has been an enlightening experience, and we have gained so much knowledge on the global experiences, performance and sustainability of CCPR. As we conclude this technical session, we would like to invite Mr. Rajendra Sisodia, Strategic Consultant at Cube Highways, to deliver the vote of thanks. Can we have Mr. Sisodia, sir, on the stage? Please put your hands together, everyone.
The most difficult task, because everybody is keen to go, but generally vote of thanks we try to conclude and everybody prepares to go, but I'll also add up something that whatever we have done today, we also will need to decide our way forward, where we want to go from here. So to begin with, I will thank Chairman NHAI and our very dear Mr. S.K. Nirmal for gracing the inaugural session of this wonderful conclave. I also thank all the guests for their active participation. I also thank all the speakers for making so much of effort that we are able to hold the guests full room even till end. I thank Dr. Reddy and Mr. Bovin for their support and guidance, which has brought this wonderful conference for conclusion today as we see now. I also thank all the Cubians and the hotel staff for working round the clock meticulously to put everything in place in perfect condition to see the things happening as we had planned. And before I conclude, I would also say that success of CCPR at GAPL for Cube Highways, while it's a time for celebration, but it is also giving us a lot of responsibility, as India is looking up to us to repeat this performance. And therefore, our task will be still tough, because when you perform at this level, your next target becomes still much, much higher. And but I am confident that with the clear focus, clear vision, and the leadership of Dr. Reddy, the Cubians are ready to take the next challenge with their hard work and dedication. And in the end, I will also add up a lighter side that while I have added this target for all the Cubians to be prepared, but to keep their enthusiasm, I'll sing two lines for all of us, or all Cubians, to go with high spirits and repeat this much better performance. So it goes like this. रुक जाना नहीं तू कहीं हार के, कांटों पे चल के मिलेंगे साए बहार के. Thank you. Have a great evening.
Thank you, Mr. Sisodia, for your kind words and for your message, which has been conveyed to all of us, for beautifying, summarizing today's event. On behalf of Cube Highways and the organizing team, we would like to extend our deepest appreciation to all of you, our distinguished guests, speakers, and attendees. Your active participation today is what made this event a great success. Once again, thank you all for being a part of this conference, and we look forward to future collaborations and continued discussions on CCPR. We hope that the ideas shared today inspire innovation and action for a more sustainable infrastructure in India and globally. Videos of this deliberation shall be available on our website. This concludes our event for today. Please feel free to continue networking and engaging with each other over refreshments. Have a wonderful evening ahead. Thank you so much. Also, I would like to thank our supporters for this event, IIT Madras and NHAI, and our partners of this event, Witten Group, IOCL, OMS India, L&T, and Bitcall. Thank you, everyone.